Hey everyone, welcome to this Google Cloud Platform full course by Mindmajix, where we take you from absolute beginner to advanced level all in one video. Whether you are a student, IT professional, or learn about cloud computing, you are in the right place. In this course, we will cover everything from setting up your first project on GCP to mastering services like Compute Engine, Cloud Storage, BigQuery, Kubernetes Engine, IAM, and more. But why learn GCP right now? Here is the reality. Google Cloud is the fastest growing cloud provider trusted by companies like PayPal, X, Spotify, and Google itself. According to the Gartner's 2025 Cloud Market Report, GCP is gaining rapid adoption due to its powerful AI, analytics, and cost effective infrastructure. And when it comes to the jobs, the demand is booming. Companies in India and globally are hiring cloud engineers, DevOps experts, architects, and data professionals with GCP skills. As per Naukri and LinkedIn India, there are over 20,000 plus active GCP related job openings right now. According to the Ambition Box and Glassdoor, the average salary for a Google Cloud engineer in India ranges from 6 lakhs rupees per annum for entry level roles to 25 lakh rupees per annum for experienced professionals and architects. So, if you are aiming to future proof your career, boost your income, or crack your next cloud job interview, this course is for you. Make sure to watch till the end because we will also share tips and career guidance to help you stand out in the GCP job market. Before moving ahead, I want you guys to like, share, and subscribe to our channel so you never miss any update from us. And if you want to learn Google Cloud course with certification, then check out our GCP course where we will cover latest industry curriculum, hands-on projects, mock interviews, and more. Check the link in description below. Now let's dive in with our GCP course.
Regions and zones. Where exactly these cloud data centers are located? That's our next question. It is located in almost all the major cities in the world, all around the world. Almost all the major cities and countries it is located. Total more than 30 data centers are there totally currently, and it will be keep on expanding as well. So just imagine in India there are two data centers, Mumbai and Delhi. So regions and zones. We are going to discuss about very important terminology in cloud: regions and zones. When it comes to AWS, it is regions and availability zones. So here GCP locations. Search this, you will find the locations which is available, and it will be keep on expanding as well. Currently there are 29 locations, and it will be very soon there will be three more locations will get added. It will become 32 or 33. So region and zone. As I said, in India, Mumbai and Delhi, these are the locations, cities where GCP, Google Cloud data centers are available. We can host our applications in those data centers, and we can access online. So it doesn't, and again, it doesn't matter whether the user location, whether you are in the same country or different country. You can host anywhere. It doesn't matter. We can create our applications anywhere. All right. So just imagine Mumbai, the Google Cloud, not imagine, it's there in Mumbai, Google Cloud data center is available. Then we can call Mumbai as a region. Mumbai is a region. All right. Because region is something in the city where Google Cloud data center is located. It's just a city name where Google Cloud data centers are located. Next, zone, region and zones. We are discussing region and zones, right? Zones are the actual data centers. In every region, there will be minimum 3 zones. In every region, there will be minimum 3 zones. When I say data center, it's not a single building where everything will be there, or not like that. The design is something like, if you consider Mumbai as a region, and there will be one zone in some specific location. Maybe after some 10 or 20 kilometer apart, there will be another data center. So minimum 3 zones will be there. 3 different data centers will be there in the same region or same city, and it will be physically apart as well, because it is for the high availability. If there is any issue in one building, or any power supply issue or any connectivity issue, it should not affect the entire region. That is the idea of having separate isolated data centers. All right, regions and zones. Okay, here regions and zones. GCP resources are hosted in multiple locations globally. We can see 29 locations. Region is the specific independent geographic location which consists zone. So you can't see a region. Like if you go to Mumbai, you can't see something called a region. You can see zones. Zones are the actual data center. 3 different zones. Zones are nothing but a data center. It will consist of all the servers, storage, networking, everything. It will be consist of. So region is a city where Google Cloud Data Center is located. Zones are the actual data center. Very simple. Let's see where and how it is available. So here is the map. I'll drop this. You can search for GCP locations, or I'll drop this link as well. I think link won't be able to, like it will go off, right? Anyway, you can keep the link separately, and it will be keep on expanding as well. Let me zoom it. So here you can see the map where and all the GCP locations are available. The blue circles are the current data centers, and the font size is increasing, not the picture size. Blue circles are the active data centers. The white circles are under construction. The DC is under construction. All right, you can see US, UK, Asia, Australia, and Africa. In different continents, it's available. And you can see, and those are under constructions. In Middle East, there are many coming up. In US and UK also, there are many coming up. So we already know there are data centers all in all these locations. There are data centers, and not only one data center, there are minimum 3. Only in one place, Iowa, you can see Iowa, there is a star here. See exception, region has 4 zones. Only in US, Iowa, there are 4 zones. Only in one place, only in one region, there are 4 zones. Except this, everywhere, minimum 3. Only 3 zones are there. Maybe in future, they'll be expanding it. Next, okay, listen carefully. So we have data centers everywhere. All these data centers are interconnected using Google's private network, Google's dedicated private network, which means cables, okay, using dedicated cables. All these data centers are connected each other. Then only we'll be able to access, right, for sure. So this is the idea here. See, you can see all these data centers are interconnected using cables. There are cables under oceans. Everything is interconnected. That's why we are able to access. We can host everywhere, and also all these servers can talk to each other, communicate each other. This is something big. All right. So there are dedicated cables which used to connect all the regions and zones. And to make it happen, there are other locations as well. If you notice here, this is few. These blue circles are few. If you come here, these black dots are more. Right. These are called edge location. GCP offer connection to services from 146 location across the globe. This is called edge location. Edge location is nothing but network location. You can see network location. To make this happen, make this connectivity happen, maybe to route the network or boost the network. And there are some other technologies are also involved. Other requirements are also involved, which is CDN. So this is this is the connectivity. Okay, it's called edge location. This word also you need to remember: region, zone, and edge location. Edge location, we don't use it frequently because it's a backend. Regions and zones, anyway, you are not going to forget because every service we are going to discuss. But edge location, you need to remember what is edge location. These are the network location, network point of presence, where you will divert the traffic or route the traffic, and many other things like CDN and many other features are also involved in it. Regions and zone scope, because this is very important when if you are going to be an architect, or if you are going to design, like you asked right just now, you Akhil asked, right, design based on what all the criteria we can design, location. And there is one more criteria, which is scope. When you're designing, it will help you, and when you're understanding the concept also, this will help you. The concept of scope will help you. And right now you won't exactly understand what is scope, but make a note. Whenever we discuss a subject, a service, there is a concept called scope, like what is in this service, what is the scope of this service. Almost all the Google Cloud services are classified based on scope. not a proper classification, but you need to think in this perspective, in the scopes perspective. And there are three scopes. One is zonal, regional, and global. Zonal, regional, and global. So almost all services are, we can divide based on this concept called scope. As of now, you can make a note when that service comes, and when we create the service, I'll explain why, based on how we can based on how we can divide, or this particular one, but it's the scope of this particular service. Example, zonal, disk VM instances and all, it is zonal. When it comes to regional, external IP instance groups are regional. When it comes to global, VPC, image, snapshot, all these are global in scope. Interfaces, GCP interfaces, how we can communicate with Google Cloud. So we are having introduction to Google Cloud, right? So different things we are discussing together, regions and zone and scopes. Now interfaces, how we can communicate with the Google Cloud. There are three ways we can communicate. First one is console, and second one is command line. Third is API. Just first one is console, GCP console. Once you create your free trial account, it will take you to home page. This is your home page. This is called GCP console or Google Cloud console. You can see console.cloud.com. This is the primary way. Most of the cases, this is the primary way of dealing with the Google Cloud, communicating with the Google Cloud. Whatever you wanted to do, you can create a machine or create a storage or network, anything you can do with this console. This is the first way of dealing with Google Cloud. Maybe the most popular way of dealing with Google Cloud. Next, okay, I'll walk you through this. Before that, the second option, Cloud Shell. On the right side, there is a button, Activate Cloud Shell. I just clicked here. If you click, the command line interface will get open or get active. So if you're using a Windows machine, you have a command line interface, right? CMD, command prompt is there, right? And if you're using any Linux operating system, Ubuntu, or if you're using MacBook or something, you have terminal, right? That's also a command line interface. Just like that, only for Google Cloud to communicate with the Google Cloud. If you want to communicate using command line, this is the next way to do it. How many of you are not comfortable with Linux? That's not a problem, but it will be good if you learn some very basics Linux. Maybe if you spend some 2 to 3 hours, that will be enough. All right, very basic commands. So if you get a Linux machine, what all you will just check, like how to list and how to see the file systems, or how to switch the directory, how to list and hidden files. All these very basic things, if you are learning, that will be good. That will help you. But again, if you are going to work in Google Cloud, definitely you will end up on running some command and running some script, or somehow you will end up on doing it. So you can start now itself, and it won't stop you for learning Google Cloud. It doesn't matter, but it will be good. It will be easy for you if you know already. Okay, so maybe this weekend or something, you can spend some time to learn basic Linux. So why did I say that? Because when I click this, and when this command line got open, right? This is a Linux machine. Your command line CMD, not CMD, the command line Cloud Shell is a Linux machine. This is called Cloud Shell. Okay, this button is Cloud Shell. So you can see it's a Linux machine. All right. So all the very basic Linux command you can run here. And what is the use of this command line interface? Whatever you are doing in this GCP console, whatever you do here in GCP console, the same thing you can do it in command line as well. Okay, I'm talking about interfaces, right? What is interface? So the interface is something which helps us to communicate with the Google Cloud. So this is primary interface, the GUI or graphical interface. So here I just went to storage. All right. In this project, I just went to storage. You can see many storage buckets are there. Total 6 storage buckets are there. You can see GCP training 18th Feb, 26th Feb, many are there. Okay, I just listed here. Same thing, I can do it with command line as well. Forget about the command, you will learn that later. See the same information I can see from command line as well. See GCP 26 Feb, 18 Feb, whatever. And many things. Whatever you are doing here, I can create a bucket. I can create a bucket here also. What is bucket? We will learn later. But whatever you're doing with the console, I can do the same thing with the command line as well. All right. So that is the second way of communicating with the Google Cloud. There is one more way, API, using APIs when you are doing automation. When you're doing automation, you will use API. That is also the way, when you do scripting or automation, the third option you can use it, which is API. That this we will deal with later. All right, these are the three ways you can communicate. The most popular way is GCP console, and if you're comfortable with the command line, you can do that as well. And there are some specific tasks you can only do with command line. There are some tasks in the second half of the training, not today, second half of the whole training. We're going to discuss that. So anyway, take your time and learn some basics. It's not mandatory also, but it will definitely help you somehow. So this is GCP console. Left side top main menu is there. If you drop down, you can see all the services. See, there are some compute services, serverless, storage, databases, networking, all the services provided by Google Cloud. You will find it in the main menu. Okay, if you want to go to any service, just go there and open that service, use it. So you can select any service like this. And if you want to go back, this is the home button, Google Cloud home button. You can go back. Next, there is a button here. If you drop down, you can select a project. At this moment, you will be having one project. All right. Some my project or whatever, there will be one project. What is project we are going to discuss in some time. Okay, I'll explain what is project when that slide comes. So just understand, you have option to select the project. If you have access to multiple project, you can select from here. Next, search box. If you already know the service name you're going to access, you can use the search box instead of going and searching here. This is more quick if you already know the service name you're going to deal with. So Kubernetes, just search and navigate there. All right, search box. Next is chat. This is if there is any support required. Then Cloud Shell. You will see a notification button here. All the important activities will be notified. All the major activities, some errors and everything will be notified here. Then your information, project info. Here, if you go to project info, if you want to rename your project, you can do this. You can do this as a first activity maybe. Just name, just remove this, use your name, because when you are sharing screen and all, I can quickly understand. So you can see, right, different names of the candidates. So you can give your name -GCP and save it. Maybe all of you can do that now or later. Billing. If you click on billing, you can go to billing. Maybe you can search or go to the main menu and go to billing. Yeah, I think there is a pop-up right on top, activate. You may need to activate it. All right, there is a button right on top, activate, right side top. Right side top, yeah. Free trial, credit and 90 days remaining. Okay, just click on activate. See if any of you get the same screen, you need to do this step. Activated successfully. All right. Okay. You can close that tutorial on the right side top, that pop-up you can close. Yeah. Okay, and you can increase the font also a bit for others. So the right side top, there are three dots, right? The browser, right side top, not again the top one, the browser level, three dots. Yeah, there you can zoom a bit. Yeah, just to scroll it down. So those who have any issue with the account, or if you want to confirm your account is active, you can go to billing overview. Right side bottom, you can see this 22,000 credits. So it's $300. You will find this in this area billing. Go to billing and double check whether you got this free trial credit or not. This is how you can confirm your account is active. All right, on the left side you can go to left side middle, you can go to budget and alerts. This activity optionally you can do it. Create a budget. So you have 20,000 rupees in your account, right? So if you don't want to exhaust this amount, maybe you are going to create, you can close this pop-up also right side top, because you're going to use many services, and if you don't want to exhaust this amount and not taken back your GCP, your credit card or something, you can set up this alert. Maybe you can my alert or something, you can give the name, scroll it down. You can set up the threshold here. Keep coming down. Next, click on next. Not yeah, that one. So you can set a target amount, maybe to 20,000. You have 22,000, right? So 20,000 target you can set. Next, and you can set up some threshold, 50%. If it reached to 50% usage, you will get an email alert, and 90% and 100. Maybe if instead of 50, you can make it some 70 or 80. It's up to you. You can edit it. It's up to you. The point is you will get an alert when it reached to this free trial amount. All right, so that you won't really exhaust with this credit. You will get an idea. Scroll it down. You have custom options, like when you need to get alert and all, see email to the billing admins and users. Fine, you can finish. Just click on finish. Let's understand what is Cloud Shell also for some time. Cloud Shell, as I mentioned, it's CLI of Google Cloud. It's a Linux machine. Second thing, it's a Linux machine, because when I run this command, you can see what is the version of Linux. It's a Debian Linux uh, console version. When you click here, when you click in this button, what is happening is one Linux server is getting created in the backend, and it is getting boot in the backend and only for you. And it's not a normal Linux machine which is embedded with your Google Cloud account. You can see this yellow color one, right? It's my project ID. Okay, it's internally connected with your account. That's why I'm able to list all my buckets and all the informations in my screen. So this is an interface. It's a Linux machine. When you click, it's getting only when you click, it's getting booted in the backend. And if you keep it for some time, it will get disconnect also. You may need to reconnect it. Maybe if you keep it for 1 hour and all, it will get disconnect, and there will be a reconnect button. You can reconnect again and use it. It doesn't matter. That's how it works. Um, in Linux, there is something called home directory, right? Home directory. It's just like desktop in Windows. So home directory, when you click, it will take you to the home directory, just like it will take you to a desktop, right? Windows will take you to the desktop, just like that. When you log into any Linux machine, it will take you to the home directory. In this home directory, you have 5 GB space to keep your file, day-to-day files. If you want to keep it, there are 5 GB space for every users. So if I run this ls command, ls is the listing command, you can see my files, some day-to-day used files you can see. So maximum 5 GB of data you can keep it. It's not a storage to keep it permanently. The daily in desktop, what all you keep it, all the like day-to-day what all you use, that you will keep it, right? Just like that you can keep it. 5 GB is the limit here. That also you need to understand. So here all the some script or file or anything you can keep it here. That is the next property of Google Cloud. I mean Cloud Shell. And normal Linux command, it will just like this, it will work. Okay. And Google related command, there are some specific prefix and all you will end up on adding. So as when I was listing, I just added one prefix, right? GSUT ls. This is a Google command. And this is a Linux command. This is a common Linux command. If you know Linux, you will know this is a very basic listing command. So that's why I said if you know Google, I mean, if you know Linux, it is easy to relate what is happening. See, ls hyphen l. So this is again, those who know Linux, it will be easy what I did. See, this is a detailed listing. So you will find more information here, total, whatever, so and so. All right, ls space hyphen l. So df space hyphen h. Those who know, it will be like it is listing the file system. So just like that, if you know it, if you know Linux, it will be easy what exactly is happening in this commands. So there are Google commands, not only gsutil, there are many other commands. So here, when I click here, I can list all the projects, right? The same thing I can do from here as well, but the command is different. Out. See the same information I can use it, but here the command is different. Gcloud projects list. Anyway, we are going to learn this eventually. As of now, just don't worry about the command, but what it does, you need to be very clear. All right. When I say it's a Linux server, this is not the place where you can host your application. All right. This is just an interface to communicate with Google Cloud. All right. It's a temporary VM instance, G1 small with the Debian OS. It terminate after 1 hour of inactivity. Favorite tools are pre-installed. Developer friendly, 5 GB storage space. When I say favorite tools are pre-installed, there are some tools, right? Some common tools like Git. It is pre-installed. If you want to upload anything to Git, it's already installed. You don't need to separately install. Terraform, it's already installed. All right. If you are uploading or if you're deploying some code to Terraform, you can do it from here itself. It's already installed. Just like that, all the common tools are pre-installed. If you want to install anything specific, that you can do it as here in Cloud Shell. So this is from this slide we are actually starting our IAM topic, identity and access management. Listen carefully. This is a little tricky. We are going to discuss about resource hierarchy. I just showed some project and all right. See, there are some many projects, and in your case, there is only a single project. You will find only a single project here. What is project? Under project, you can create all your resources, like all your services. I can say compute service or storage service, everything. You can create it, and every project is isolated as well. A project is totally isolated. How I can confirm? See, when I go to storage under Vishnu project, I can see many storage. When I switch to some other project, I can see only one storage, which means project is an isolation boundary. Like whatever you are creating inside a project, that will be within that project itself. Like internally, it doesn't have access. So just imagine I have just one project. Okay, only one project. We will limit into one project, just like your current account. You have an account, one project, right? So if you pick an organization, very large organization, one project is not really enough to handle all the requirement. A large organization, maybe thousands of employees are working, the uh, offices are there in multiple places, a lot of projects are running, lot of requirements are there, multiple teams are there, multiple departments are there. To fulfill all the requirement, one project is not enough, obviously, right? Logically, one project is not enough. You can't really have a service of sales, HR, IT, or all the department servers. You can't really keep it in one place. You need to isolate it, you need to separate it. Makes sense, right? You can't really keep it in one place and give access to HR team, sales team, everywhere, everyone to this particular project and use it. That's not the right way of doing it. You need to isolate it based on multiple criteria, maybe based on departments, maybe used based on the environment, maybe development environment, testing, staging, production. Based on that, you need to divide it based on departments, multiple criteria. You need to divide it. Make it happen. There is a concept, resource hierarchy in Google Cloud. You can see on top of this hierarchy, organization, example.com. Then under organization, it will be folder, project, and resources. This is almost self-explanatory. You can see here on organization. If, for example, you are going to set up a Google environment, Google Cloud environment for IBM.com, IBM or the organization IBM. So on top of this hierarchy, you need to attach with the public domain name of that particular organization, which is ibm.com or ibm.in or whatever domain name. Domain name needs to be attached on top of organization. Then under that, you can divide based on how you want. Maybe based on departments. You can it's explanatory, right? See, folders. This is for sub organizing your requirements, sub-organizing it, see, based on the departments, engineering, sales. Under that, the projects. This is what we are dealing with, right? When I was dropping the projects, this will come under folders. From here only we are dealing with, and under project only you will have all your services or resources, whatever you're creating in actually in Google Cloud, whatever the application or network or whatever we are going to use it, everything will be under a project. Without a project, we can't use any of this. Without a project is the primary grouping mechanism, primary isolating or grouping mechanism. Always there will be a project. Without a project, you can't use it. Folders are still optional. Organizational is optional. In our case, organization and folders are not there. In real time, you will find these two may not be there. But from in our case, from this only we are going to deal with. But you should understand there is a concept here, logical concept. This is how you design the environment, and this is how you isolate your environment based on multiple criteria: organization, folder, project, and resources. Let's understand each one separately. Organization is the root node in the Google Cloud resource hierarchy. Root node means everything will be under organization. Hierarchical ancestor of project, resources, and folders, because everything is under uh, organization, right? So hierarchical ancestor of all. It belongs to an organization instead of the employee who created it. So in our case, we are creating a project and using it, but in real time, it doesn't matter. No matter who create this project, there is no dedicated special ownership to the person who created. Everything will be under an organization. Here, those who are managing in the organization level, they have full access. So maybe they can delete, modify anything. They can do it from a higher level. Organization administrators have central control. That's what I said. Organization ID is the unique identifier. I'll show you this. We don't have organization ID. If you go to your account also, just click on all. There is everything. Whatever all the projects are under organization. See, in my case also, all the projects are under organization. But here, it's no organization because it's not an active organization. If you have an on company or on organization only, you can really make this happen. Here it will be showing ibm.com, accenture.com, or so and so. And there will be an organization ID. It will be and it's numeric. Like here, this is alphanumeric, right? But here it will be no numeric, some 8-digit or something, 67853, something like that. There will be unique identifier, globally unique identifier will be there. So this is the place you can see the hierarchy. If there is folder, it will be visible here. It will looks like this here. Instead of this now organization, ibm.com or something, and there will be numeric number as well. And the folders also will be there. Under folders, you can divide it, okay, just like this. So under folder, under engineering, you will find 3 projects: dev, prod, and test. Under HR, you will find many other projects as well. That's about organization. Next is folders. Folders are for sub-organizing, under organization, sub-organization, sub-additional grouping mechanism, isolation boundary between project organization. Folder can be model legal entities like HR departments. It's totally up to you. Maybe it depends on your hierarchy and your departments, how you want to divide. Folders, additional mechanism is each team folder could contain additional subfolders to represent different application. Folders act as a policy inheritance point. What is policy inheritance? We will discuss it later. In general, folders are the additional grouping mechanism. That's all you need to know. Projects, this is what we are going to deal with a lot. You already have a project. Every account, without a project, you can't do anything. You can't create any resource. Technically, you can't create any resource. Project is the base level organizing entity. All your resources are under a project always. 2 identifiers, 1 mutable display name, lifecycle. Let's see what it is. If you go to your project page, go to project settings, 2 identifiers. When I say 2 identifiers, one is project ID and project number. Project ID we are going to use a lot. I said, right, project ID. See, this is project ID. If you want to switch to another project, I need this project ID to switch. So project ID we use a lot. Project number very rarely we use, but still it's an identifier. It's a global identifier. This number, it's the unique number only for your project. This is also unique, but this one anytime you can you can change it. Project name, it doesn't matter. So it's quickly changed. Anytime you can do it. All right. So just rename your project with your name because for you it doesn't matter when you're sharing screen and all, or if you're providing access at that moment, it matters. All right. Next, yeah, there is a button, shut down the project. Shut down the project. If I click on shut down, I need to provide the project ID. See, it's asking for the project ID. So as I said, project ID we use in many places, right? So this is one of the place. When I provide project ID and click on shutdown, it will set to shut down next to 30 days. Okay, after 30 days only, it will completely shut down. So when I click on shutdown, next to 30 days, it will be in inactive state. Your applications or data won't be accessible. But yeah, and also it will inform all the project owners. You are not only the owner, right? In your current case, you will be the owner, but there will be multiple project owner for the same project. So everyone will be informed that this is going to be shut down, and after 30 days only, it will completely shut down. But billing and all will get stopped. So next to 30 days, it will shut down. So either project two life cycle for the project, either it will be active or delete requested. Active or delete requested. These are the 2 life cycle for project. Either it will be active, or if you click on shutdown, delete requested. If it is delete requested state, next 30 days it will be inactive. It will stay there, but it will be inactive, and later only completely will get deleted. This another diagram where you have subfolders. Okay, see, if your organization is large, this is the area it will get increased, like this area folders, because this additional grouping mechanism, right? This list will be more, like this lines will be more technically. Project resources server. The one we discussed, right? The project organization. This is also part of IAM. This is the first service we are going to discuss under Google Cloud. IAM, Identity and Access Management. It comes under security. Cloud Identity and Access Management. Okay, So you have a project. You need to provide access to another person. All right. Right now you have a project. You need to provide access to another person. You're the owner of that particular project. This is the service who is going to help you. Okay, if you want to provide access to someone else, identity and access management, this service help you to provide access, regulate the access, not only provide the entire access, manage the permission, regulate the permission. This is what it is used for. IAM. IAM means identity and access management, enable you to create and manage permission in Google Cloud resources. There are different areas, different perspectives on this. We will discuss in detail. Enterprise grade access control, very easy to use. You can set up the full access. When I say full access, maybe the organization level access or project level full access, folder level full access. You can provide something like that, or you can have the granular access. So if you are a person who's going to deal only with the Kubernetes. If you are a Kubernetes architect, you're going to set up everything in Kubernetes. You can just only get the access in Kubernetes. Or if you're a person who's going to deal only with the networking, like network creating, network firewalls, routing, all these things, you can have only access to networking part, not the entire project. You don't need access to storage. That way, you can set the granular access as well. It's totally free of cost wise. There is nothing to provide the access to set up the policies, set up the roles, providing the roles, anything for all these activities. You are not charged. It's a logical concept, so it's free of cost. How IAM works? It is very simple compared to the traditional technologies like Active Directory or LDAP. You might have heard about it, AD, right? When you join an organization, you will get a you will create you will get a username, right? That is getting created in AD most of the cases. That will be created. There will be central username to log in everywhere, all application, all servers, everywhere, right? So that is actually getting created under AD most of the cases, or LDAP. If it is Linux and all, it will be LDAP. Mostly in Windows, it is AD. So compared to those technologies, this is very easy how it works, how IAM works. If you can answer these three questions, it is very easily you can understand how IAM works. Who, what, and which resources. If you want to provide access, example, Jyoti wanted to provide access to Archana. All right, Jyoti can go to her console, that IAM console. Who who want to provide access, like to whom want to provide the access? Archana's email ID will be the answer of this question. Okay, who? Archana's email ID. So we are dealing with email ID, right? To authenticate Google Cloud, we are using email ID. So we are not using usernames here, unlike maybe if you want to log into a server, you may need username. But when it comes to cloud, no matter AWS or Azure or Google Cloud, we are using email ID to authenticate. So if you want to get access, email ID is the answer of who. So Archana's email ID, you need to get and go to IAM and provide the access. What access needs to be provided? Next question is what access? Whether it's a project level access or compute engine or storage access or an organization level access, it depends. That this answer, right? What? Next question is what? Role. What means role? What exactly? What is the access you need? Maybe a project owner or a viewer or many things like this. Which resource? If you are providing project owner access, project is the resource here. Project is the resource. If you are providing storage admin access, storage is the resource here. It will be a little tricky. Let's see how it looks like. Go to IAM. Just go to IAM. You can type here or IAM admin. Here you can see this is the actual owner. This is the person who created this project, and he provided access to me. This is my ID. All right. If you look at your IAM console, you can parallelly check it. You won't find all these kind of service account or whatever. Only your ID will be there. Your email ID will be that email ID which you use to create IAM. I want to provide access to someone. Very simple. Go to click on add. Provide the email ID of that person. Very simple. No username concept, it's just email ID. So this is the answer of who. Next is what. What access you can provide. See, custom and all I'll come later. So if you want to provide any project level access, you can go to basic access and provide the project level. Viewer, owner, editor, browser. These are the project level access. So if I provide owner, I'll get ownership in this entire project. See, I'm the owner right now, project owner. All right, this guy is the owner and I'm also owner of the project. That's why I'm able to add another person. Okay, if I'm not the owner, I can't do that. So that's a basic, that is under basic access. Okay, basic access means it include entire project. Next is the granular access. You will, whatever the list you're finding under this, that is granular access only to that particular service. Example, Cloud Run is a service. Cloud SQL, if you're providing access to only database, Cloud SQL admin you can provide. All right, so in our case, Jyoti is providing access to Archana's. Archana's email IDs will be here, and providing access to Cloud SQL. All right, Cloud SQL admin is the role. That's the answer to this particular one. What we are answering, who, what, and which resource, right? Who is email ID, what means Cloud SQL admin, which resource, which is Cloud SQL. Cloud SQL is the resource, Cloud SQL admin is the role. No complex things involved, just you need to know what is the role of that person. Based on that, you need to provide, go to basics and provide it. If it is a project level, you can provide like that. And also you can provide organization level, folder level also, but we don't have option to show. That's also very, just very simple, something like this. Policy. See, just now I was showing Cloud SQL admin, right? You're providing one email ID and you're attaching one role into it. That's what I was trying to do here. An email ID and one role into it. Okay, so I'm providing an email ID, attaching a role. If I save it, this forms a policy. This activity, the task which I did, that is called a policy creation. Policy creation means attaching a role to a member. That forms a policy. See, attaching plus one member, one role. And it can be either single member, group, service account. This and all you can forget as of now. We'll discuss later. Attaching a user to a role, or either single role or multiple role. That forms a policy. All right, member, role, and policy. A cloud IAM policy bind one or more member to a role. These two we already know, right? Member email ID, role is the permission. So if you attach, if you bind a role to a member, that forms a policy. Now we reach to a very tricky and very interesting concept, IAM policy inheritance. IAM policy inheritance. So here, the same slide which I used at last with the subfolders, I used it, right? Let's take a scenario here. Listen carefully. Not a complex thing, but it's little confusing or tricky thing. This is right now. Just assume that we are going to set up a full Google Cloud environment for an organization. Whatever we'll take IBM, very common example. So here, organization. As I mentioned, the organization level, we need to attach the public domain name, which is ibm.com. So I just created the organization. Okay, here I just created the organization. So this is how in real time also it works. When you are completely, if you're going to create an environment, this is where you start the organization level. First, you are the very top level, the decision makers. They will be working with the Google, and they will set up the organization here with working with the Google, attaching the public domain name. Will create the organization. So I created the organization here. All right, started with the organization. This is active. All right, next we'll take maybe for convenience we will take ibm.india, so it is easy to relate, right? So here there are 3 folders I'm creating. One is maybe one is Bangalore, Hyderabad, and Delhi. Okay, 3 different folders I'm creating. So IBM Bangalore, Hyderabad, and Delhi. All right, 3 I'm creating. And here for IBM Bangalore. So who's from Bangalore here? Anyone? Shankar. Okay, Shankar is, I don't know, I'm not sure, but I'm just taking the name. Shankar is responsible for IBM Bangalore, and maybe Archana is responsible for Hyderabad and Delhi. Okay, so I'll reduce. This is okay. This is Hyderabad. This is Bangalore. This is Delhi. I'm just providing 3 folder access to 3 persons here. Okay, maybe Shankar, Archana, and Jyoti. Okay, 3 folder access I provided. Understand? This is IBM Bangalore. I provide to Archana, Shankar, and Jyoti. All right. So far, so good, right? 3 folders I have created and 3. Archana is responsible for entire workloads under IBM Bangalore. Archana is responsible. Next, Archana created 2 folders. Are you able to follow or confusing? So far it's good, right? No confusion so far. Archana is creating 2 folders, Team A and Team B. Team B, Archana is providing access to Kundan. Team B, okay, Kundan is responsible to handle these workloads. All right, Team B, here Kundan, and 2 products are there, product 1 and product 2. Who else? Okay, Jyoti is responsible for product 1. So here Kundan and here it's Jyoti. Jyoti is responsible for product 1. Okay, I think Jyoti, I already used the name right here. Okay, who else left? Devika is responsible for product 1. I already used the name here. So Devika is responsible for product 1. And Devika created 3 projects. Okay, I'll recap it anyway. So just 3 products. Test GCP. Mohan is responsible for test project. Mohan is responsible for test project. So Devika provided access to Mohan. So I'll just recap the scenario. I have created organization. I provided access to 3. I created 3 folder and Shankar, Archana, and Jyoti. Archana created 2 other folders, provided access to Kundan, and again Devika, product 1, Mohan, here test GCP, Mohan provided access. So far so good, right? Clear? Now, policy inheritance. This is the concept we are going to discuss, policy inheritance. See, I have organization admin access because I'm the one who created. I have organization admin access. I have central control on everything, each and everything under organization. Because if I have the top level access, the organization admin access, this will get inherit to everything till resources. Inheritance, right? The word inheritance. Focus on this word, inheritance. My access will get inherit till resources, which means I have admin access to all these folders, all this project, and all resources. Archana, here Archana, you got access whatever is under department Y, whatever the workloads under department Y, team A, team B, product 1, product 2, all the projects. But you have no clue what is under department X because you have access from this only. Make sense? You have no clue what is under how many folders are under department X or how many projects are under this. This is Hyderabad, right? Yeah. And the same way, only Jyoti have access to whatever under this Delhi region, Delhi folder, whatever the folders or project. And Jyoti have no clue what is under department Y. Clear? And Archana got full access. If you have folder admin access, you have admin access from here to here, but not under here. The same way, Kundan got access everything under team B, but not under anything under team A or whatever here, and so on. This is called policy inheritance. the policy will get inherit all child resources. Okay, for all child whatever you're getting, like if you're getting the access in project level, all the child resources also you will get the same access. If you're getting viewer access here, you can view everything under test project. If you're getting owner access, you will get ownership on all the resources. You don't need to separately provide it. You don't have to provide for compute engine, app engine all together. If you're going to use the entire project, you can come here and provide, so that the policy will get inherit to all child resources. Very simple, all child resources. Wherever you are getting, whatever the level you are getting, from that level, all child resources, the policy will get inherit. Clear, right? That's called IAM policy inheritance. Who will, if you are providing access, who to whom you are providing? Okay, that's the answer of this one. Who's the person who get the access? First is Google account. Google account we already created using Google account, using Gmail account. We created the account, and next one is service account. And always it should be a Google account. It's not mandatory that it should be a Gmail account. You can have any other domain, but using that there should be account created in Google. That's the idea. So at the rate Gmail, not only at the rate Gmail account or at the rate Gmail or something. Using anything you can have a Google Cloud account. But using whatever the ID it is, using that you should be having a Google account. So Google Group. Second one is second one is service account. Service account we are going to discuss in detail using using a separate slide. At that point, I'll explain more. The next one is Google Group. You can create groups in Google. There is a URL groups.google.com. All right. If you go to this URL, groups.google.com, instead of providing access to individual IDs, you can provide access to groups, Google Groups. You can create a groups, something like this. You can create a group. Example, if you have a team where everybody will be getting almost same access, then instead of providing individual access, it will be good if you provide group access, because in IAM and all, the entries will be less and the management also will be less. The management headache, everything, it will be much more easy to do that. So you can go here, groups.google.com, and you can create a group. It will looks like this. The extension will be, again, it looks like an email ID. The extension will be @google.com. All right, something like this, and you can add all the email IDs you want. Google Groups. Then there are some more things like workspace domain, identity domain, G Suite. Workspace domain means you can provide access to the entire domain. Whoever, if you work for an organization at the rate ibm.com, whoever got email ID .example.com or .ibm.com, whatever it is, for that domain, the entire owners or an entire whoever got email ID with that domain name, they will get the access. If you provide access to some website and all, you can use it like some internal website. However, it doesn't matter. You don't need to specifically go and create account for each and every employees of your company. Instead of that, you can provide access to entire domain. In cloud identity domain, and G Suite. This is another important area, identity domain and G Suite. This is something big. Okay, if you are managing, did anyone hear about G Suite? Okay, GCP is a SaaS product of Google Cloud, not Google Cloud, Google SaaS product, software as a service product. If you are starting a business or something, you will get the entire business package. Entire business package means all the IT related requirement. If you will get a mail option, you can host your employees' mails there. The organization mails, and storage, Google Drive as a storage, then all the Google Sheet and all this my office package requirements, right? Excel, Word, something like that. Google also got a document sheet. All almost all the Google products in a package. You will get it. This one, almost all these products. See, Drive, chat option, calendar, meetings, and all these this Google Sheets, everything you will get it as an enterprise package with security and everything. So this is called Google G Suite. Okay, for not exactly this, there are many more features. You can host your mails, many things you will get it. So that G Suite you can attach with the Google Cloud if you want. If your organization is already using G Suite, you can attach it with the Google Cloud. That is another important part. So just like G Suite, there is another domain level management, which is cloud identity domain. There also, what you can do is in both the place, what you can do is you can create users, you can create their email IDs, you can create groups, many things you can do it in these areas. This is if your organization is already using, it is easy to attach with the Google Cloud. So it's easy to integrate with the Google Cloud. The last two are not specific with every service. There are some service you can provide access using the last two, all authenticated users and all users using these options. Some specific websites and all there, if you're hosting a website in it, you can provide access all authenticated users. Sometime when you log into a website, it will ask for authentication, right? You need to log in with any of this account, like Google account or Facebook account, something like that. If you authenticated, or if you sign up using some account only, you will be able to access certain pages, right? So for if you are creating website something like that, only for the authenticated users you can provide access. Actually, we are doing it in second half of our training, the last two. Then the last one, all users, no matter who, without authentication, like if you get a URL or something, anybody can access it. So all these are under who. And the most used one is Google account and service account. Where you need to focus is these two: Google account and service account. Google account, using Google account, you already have an account, right? And when it comes to organization level, it will be different. In your organization, your office mail ID, you'll be creating account, and not you will be creating, or will be providing account. It is very easy to provide also. Like today, we are going to do it. You don't need if there is already organization GCP accounts access, it's very easy to provide to another person. Everything you already set up, like billing account, everything is ready. Then it is very easy to provide to another person. Any questions in this list? First two are the important ones. Rest all are optional. It depends on where you work. You will get chance to work on it. And last two are very simple. These two are something optional. Sometime you may get to chance to work. Otherwise, not. Next one is role. Okay, who we answered. These all are the possibilities of who. And first two. First we are good. Second one we are going to discuss later. Next is role. Okay, what resource, who and what. So what means it is role? Okay, the answer of what, which is role. Role is a collection of permission. You cannot grant a permission to the user directly. Instead of that, you can grant a role. When you grant a role, you grant them all the permission. It's a confusing statement. Let's see what it is. Okay, I'm going to IAM. What was the statement? Role is a collection of permission. You cannot grant a permission to the user directly. Let's see. I'm going to role. Roles, event the roles here. And role is a collection of permission. That's our first statement. Let's see what it is. Maybe something non-one will go. Storage. So if I open this, I just filtered with cloud storage, and I'm going to open it. So this is your role, storage admin. This is your role. If you are providing access under IAM storage admin, this is your role, and role is a collection of permission. See, these are the permission for this role. These are the different set of permissions for this role. role is a collection of permission. You cannot assign a permission to a user. That's what our statement. This one, permission, you cannot assign. You can assign only roles. If you want, you need to group it into role and then provide it. And if you, before providing, if you want to know what all the access you're providing, you can just come back and check. See, all these are the access. It's very readable, like what all the access the user will get. You have an option to check it just before providing the role here. First, see, I'm going to roles, and when we provide here, before providing here, we can go to the role and check what are the permissions you have. There are three types of roles. Three types of role. First one is basic roles. Basic roles I already mentioned yesterday, which is project level roles: owner, viewer, editor. These are the three basics roles I can say. This is something rarely used. So very basic roles: viewer, owner, and editor, and all these are self-explanatory. Viewer, all the viewing permission, view permission. You can view the entire project. Owner is something you can do. Okay, after viewer, editor is there. Editor, using editor role, you can do any changes, any modifications in your project. Any kind of modification you can do using editor role. And honor role also can do all the modification, including IAM and billing account. Using editor role, you can't manage IAM and billing account, which means if you are an editor of a project, you can't really provide access to someone else, some other user or something. IAM they can't manage, and also this one billing part also, billing account also you can manage using editor role, but using owner you can do everything. All right. That's a basic role, basic roles. Then all these are predefined roles. All these are called, except this basic roles, everything is called predefined roles. See, there are a lot of roles. You can just check, like, see, Cloud Run, Cloud SQL, storage, data proc. There are many roles. Okay. So all these are called predefined, except basic roles. All are called predefined role. That is something granular roles. So, but the predefined roles are something specific to a service, exclusive to a service. Different types of roles are there. If you go to one, if you just go to one, there are many sub roles as well. Here, logs role, admin, writer, accessor. It depends on the roles, depends on the predefined role. The right side, these will be changing, like what, which is based on what it does, what that service does. Based on that changes. Data proc, only 6 are there. If you go to data store, there are many. All right, that is predefined role. Then the last one is custom role, what Jyoti asked. Custom roles, you can go to add role. If you go to IAM, you can go to add roles, and you can not this, sorry, IAM and roles. You can create a role and add permissions. There are total 5,558. This will be always getting changed also, like anytime this will increase when the new services and new features comes. This will be increasing as well. You can provide, you can add the permission and create. Otherwise there is another better option, or that's where you use it more. You can edit existing roles. So existing roles will be there. You can use this option, create from role. And maybe if you want to remove something, example, I want to remove this delete option before I provide access to someone. I don't want them to delete the content of my storage. So something like that, you can do it. I'm just removing two delete options. See here, storage bucket delete and object delete. These two I'm just deleting and creating a custom role. You can easily create it. All right. So this is something. It is like instead of creating a new role, this is how we use it, or we can combine two roles and use it instead of providing multiple times same the two different role to anyone. You can combine two roles and use it. See here, I have created a custom role. You can figure it out based on the icons. I'm removing one. Three types of role. First one is basic roles. Second is predefined and custom. So roles are the collection of permissions. You can see the group of permission. Three types of roles: basic, predefined, and custom roles. These are the basic roles: viewer, editor, and owner. So editor is self-explanatory. For owner, all editor permission plus managing roles and permission under IAM, and also setting up the billing account of project. So some of the predefined roles. Example, we already saw that. Last one is custom role. You can create custom role with the required permission. But custom roles are not really recommended roles. Can someone say why? What will be the possibilities? It's not so widely used on custom roles. Custom roles are not so widely used. The reason is custom roles are not maintained by Google, because in that particular service, example, we just checked cloud storage, right? There are 25 permissions, and later they may add some new features, new permissions in the predefined role. The 25 will become 30, just imagine. But if you create a custom role using 25, like by removing, we just removed two permission and created a custom role, it won't be updated in the custom role for sure, right? Obviously it won't be updated in the custom role. So it's not maintained by Google. When new permission or feature adds, then the custom roles won't be updated automatically. So that is something you need to keep it in mind before creating a custom role. To create a custom role, you must choose the organization or project to create in. You create custom role by combining one or more available cloud IAM permissions. Last one is which resource. There is no explanations required. Whatever, if you are providing if you are providing storage admin role, the storage is resource. Then basic roles, project is resource, or organization folder. All those also can be the answer of which. Project level permission inherit to all the resources. We discussed that in detail about the inheritance. IAM service account. All right, we kept it aside. Service account is a special account used by the application or resource and not by the individuals. Which means, so if you work in an organization, you may use some accounts which is not exactly your user ID or your account. Like example, if you are connecting with a database, sometime you may need to use the DB account, maybe DB admin account or DB user kind of account. So anyone, that's called application account or generic account. Somewhere it's called generic account or application account. Different names used to call. Service account is not exactly how we use the application account or generic account in operating systems. It is slightly different, not slightly, like many things it do. Service account, for multiple reasons we use it here, but it's almost like this. The idea is almost like an application account. Service account is a special account used by an application or resource and not by an individual. We don't really switch it using our ID. We don't log in using our ID or switch it or something. It's totally independent. Let's see how it works. Service account is a special type of account used by an application. Okay, that's very important. Or a resource. When I say application or resource, it's totally talking about Google Cloud resources like storage, compute engine, or whatever. What are all the services provided by Google Cloud, and not by an individual. It is identified. Its email ID, which is unique to the account. Or again, service account is also an email ID. It do not have passwords. Service accounts do not have passwords. You can log in using JSON files. Actually, key pair. You can use the RC key pairs, which is JSON files and all. You can use it for authentication. Doesn't have passwords. But in Unix and all, if you create a service account, there will be password, right? There are chances you may have password for that. cloud IAM permission can be granted. Let's see what is the use case of service account. If you go to here, IAM, you can see some email IDs which starts with some random numbers. See, all these are service accounts. Okay, except this one and this one, all are service accounts. So this is how it looks like. You can see here compute engine default service account. So here you can create a service account also. Before that, let me explain what exactly this service account do. So just like as I said, always there will be scheduled job and there will be other authentication, external authentication or internal authentication also happening in Google Cloud. We'll take an example of Jenkins. I don't know how many of you are familiar with Jenkins. Jenkins is an automated job, like you can schedule the job, you can schedule at some specific timing to run this particular script or trigger some activity or something externally. Jenkins is a third-party company and third-party tool it is. It's not really a Google Cloud product or something. It's a totally third-party tool. So a third-party software or tool which need to authenticate with Google Cloud. See, when we are authenticating, we are just opening GCP and using the email ID. It is getting authenticated already. I provided password, so it is allowing me to get in to this console. That's how we are authenticating, right? We're using email ID and password. We are authenticating. Am I right? So when some external tool or external software needs to authenticate with the Google Cloud, there should be a mechanism that is called service account. All right. We will take a better example. Using Jenkins, you are creating a storage or copying a data from storage. Copying, we can live. You're creating a storage, like using Jenkins, you're creating a storage, or using Terraform. Like if you use Terraform, also you need a Jenkins pipeline to create a storage. Again, all these are automated jobs. Okay, if you don't know anything, if you don't know what is Jenkins and Terraform, also you can ignore it. Just imagine it is a third party tool which need to authenticate here. And what it is going to do is it is going to make some changes in storage. Just imagine storage. I'm taking a very simple example everywhere. Storage. Okay, it is going to make some modification or creation or something under storage. So what you can do is come here, service account. All right, you can provide the service account name, storage. You can see storage, the email ID will be storage and your project ID. You can see here, this is the project ID. That's how the name looks like. See, this project ID is getting updated here. And service account, we already mentioned service account is also an email ID, right? So the email ID looks like this, iamgsserviceaccount.com. So description, I'm not providing, I'll just create it. And what exactly I'm going to provide access, where exactly? It is to service account. I can provide access to the entire project also. It doesn't matter, like if the Terraform or Jenkins is going to make any kind of changes in your project, that also fine. But I'm taking a small example here, service account, and I'm providing roles. Storage admin. So service account, if you create an empty service account, you can't do anything with this because it doesn't have any permission. You need to provide permission. What exactly, for what reason you're going to use this service account. Say I provided storage admin permission, and if you want, you can provide the individual user access also so that they can manage this service account. I'm not doing that right now. See, I just created a service account. All right, this is how it looks like. And for the permission, what I can do is I can download a key pair. See here, manage permission, manage keys. I'm just going to just switch to here keys. Okay, so there are different types of authentication. Those who are not doing it, we use username and password, which means username you will provide, and password also you will type and get in. But there are many there are passwordless authentication in Unix, like your SSH passwordless authentication. That is another way of authentication. Instead of password, you'll use SSH keys. SSH keys you will be passing, copying one time, and next time, every time it login, it will be automatically get allow you to in maybe individual or application account, anything. The same way here also, it is a key authentication, key based authentication. You can use, you can create a key for authentication. It's a one-time task. You need to create the key. You need to copy to wherever, whichever the service you're using. If you're using Jenkins, you can attach this service account plus key with the Jenkins. There is a place to do it. If it is Terraform, when you write a Terraform code, there also you can update. You have option to update it. So here there are two types: P12 or Jenkins. Jenkins is something very common format. I'm just using. I'm just downloading Jenkins. See, the key is downloaded. So if you open this, I just downloaded the key. This will be a little confusing, but when you use it in real time only, you will come to know this service account and key based authentication, or how exactly you're going to use. But theoretically, you should know what exactly, what is this at least. You should have a clear idea. Right? Is it readable now? You can see service account, project. You see in this key what all the details it has. Private key. You see all these. This is the actual key which is getting passed. You can see the email ID, which service account it is getting passed, and everything. You can find it here. This is something when you really use it only, you will get a better, very clear idea. As of now, just to understand theoretically what exactly it does. It is used by the application. You can use it for external plus internal authentication. Internal, I will explain in a different scenario. So as of now, is it clear how we can use for third-party tool or authentication? So far I was talking about user managed service account. There are two types of service account. One is Google managed, and the second one is user managed. So far I was talking about user managed, which is we are creating, we are providing permission, we are copying the JSON file to somewhere and using it. That is user managed service account. There is something called Google managed service account as well. If you go here, can someone check your console as well? How many are available? If you go to IAM, all right, you can check until later. So here you can see something, compute engine default service account, compute engine default service account. Okay, so this is something I didn't create it. This particular service account, this 1139, this random number, right? I didn't create it. This got created automatically when I open first time. When you open compute engine or some specific service like compute engine or app engine, something like that, there are some specific service. Not every service got a service. Every Google Cloud service, it doesn't have the service account, but there are some large services like compute engine or app engine. Somewhere in that there is the, it required a service account to work, actually work normally. It required a service account. You can see here compute engine default service account. All these are the service account created by Google itself, created and managed by Google itself. This is for internal authentication, internal permissions and authentication. When I say internal authentication, here this is compute engine. Okay, so compute engine is a large topic. Like it has so many things. Networking is part of every compute engine. Got an IP address. Every instance got an IP address. Disks are part of it. There are many things work together. So when it comes to compute engine, see, disk is authenticating to network, or network is authenticating to VM or CPU memory. Many things are working together, right? For the internal authentication purpose, it required a service account. That is Google managed service account. This is the example of that. And look at this, how many permissions it's got. Google managed and user managed. User managed, we are managing if you are specifically providing access, but Google managed one, Google itself will create and assign the permission. You don't have to do anything. This is not created by me. All right. In your account also, this will be updating soon. You don't have to do anything. It will automatically come when you open compute engine for the first time. Here, if you open this service for the first time, it will be automatically created. All right, cloud IAM permission can be granted. We already did that just now. Application use service account to authenticate itself to set of APIs used by services and application to interact internally with the GCP APIs also. This is something Google managed internal authentication also. Set of Google GCP APIs means GCP services. Service account permission can be modified anytime. You can modify it. If a large application into divide into microservice also, service account helps to authenticate internally. That we will deal later, like when it comes to microservices. Google managed and user managed service account available. Google managed service account get created and permission assigned automatically. The one I just showed. All right, that's all about IAM. We started on Friday and we are finishing the topic now. We will do a lab right now. Before doing the lab, some of the best practices when you are working in IAM. Set maximum policies at organization or project level and avoid at resource level. Some of the best practices, all right? Always give least amount of access to resources. Like whichever, if the person is going to deal only with storage, only provide storage admin or whatever the editor or whatever the access. Don't provide anything extra, some additional access unnecessarily. You're not supposed to provide. Always give the least amount of access. Grant roles to Google Groups instead of individuals. If you have an option to create a group and use it, go with that. Don't always provide individual access. Be extra cautious while granting permission to service account. May know why. What will be the reason? Be extra cautious. The same reason of application account, like you were giving an example of batch processing, right? What will happen if you are what are the some extended possibilities? See, if you just now I just showed how to download the key and copy it somewhere and use it, right? um, See, just I copied this JSON key to some other external tool, third party tool, or some other server. I will give another example. You are using a hybrid cloud. You are copying example in your hybrid cloud. We already know what is hybrid cloud, right, from last session. Like you are using on premises plus Google Cloud, and from on premise you are using Google Cloud storage for backup solution. Like you are copying all this backup data every day from your on premises, your data center server to Google Cloud. So for that you need a service account, right? In storage, if you're making some changes daily basis, you're copying data totally from an external network. So you created a service account, you copied this JSON key to your on premises. You need to visualize this. You copied the key to the on premises, and from there you're using it. Whatever the script I was showing, right? In script you have updated whatever. Later, like you resign from the organization, all right, and still there is a possibility, like until unless you're not properly documented or whatever, others won't be knowing where and all you are using this service account, right? The keys and all, where and all you have copied, or some other person's copied and all. You have no idea. This is one of the security breach of service account. You have no idea, but you will be finding it in logs and all. But that is very difficult. You need to go and search technically. So you need to be very careful when you use service account. Provide the permission. It should be right permission, because this is something you're going to. It's out of your control. See, if you create a storage, you can find it in Google Cloud Console itself, whether the storage is there or not. Later, you can modify, delete it. But this is something where and all your authentication is coming. You can't really. You can figure it out using the logs and all, but it's not really very straight, right? You need to go and search it. So that's why you need to be always cautious before creating and providing permission to service account. There are multiple possibilities. It will be making any harm to your account, GCP account. Make sense? So let's do a lab. We will provide some permission in a project to another email ID or other user, and how that permissions looks like. Okay. So first, all right. Keep this open and open one more tab, GCP tab. Just right click somewhere on the, yeah, there, and open it. Before we start the lab, I will just show you how the service account is getting created. See here under IAM, as of now, there is only one entry. It's our primary email ID, which used to create this account. Now, go to the next tab, go to Compute Engine. Enable it. Compute Engine API. First time, you need to enable the Compute Engine APIs. It will take a couple of minutes. Maybe you can go to IAM and check it once. Yeah, all right. So you can see there are default service accounts created. Sorry, Google managed service accounts created. The top one is Compute Engine default service account. All right. When you do that also, there will be default service account will be created. Okay. Now, this is a Chrome browser, right?
Yeah.
Okay, you can open one more browser and log in with the other ID, other email ID. Any browser. Just open google.com and log in. Just google.com. Just okay, go back to Chrome. So Chrome is the primary account, and Microsoft Edge is the other user. Okay, this is the primary account. Chrome is the primary account. All right, let's start providing the permissions. Just go to add. Others also can do later. It's very simple activity. Just provide that new ID, which is the new ID. Just and first we will start with a very small permission. Instead of providing project level access, we will start with a very small permission. Just type storage. All right, come down, scroll down. Storage admin will be there. No, not that. That's compute storage. That's a different one. Storage admin will be there.
Yeah,
storage admin. Yeah, that's right. Save it. All right. Before that, one more thing you can do before we switch there. Just go to the second tab, the VM instances, right? That tab, and go to the home page from here. And project info. Just go to project settings. Under project info, there is a button. Go to project settings. Yeah, get down. And here you can rename this project. You can provide. You can just type your name -GCP or something. Yes, demo GCP, and save it. Underscore may not be allowed. You can use hyphen instead of that.
Okay.
Yes, save it. Now you can switch to Microsoft Edge. See what we did? We provided a different permission to the users. We used the same person, but same person's ID. Just we need to switch and show, right? So that's why. So technically, we just provided access to another person. We already know we use email ID to provide the access, not a username. So now you can switch to Edge and search for GCP console. Google, just search for GCP space console. We already provided storage admin permission to this user. You can go to the second down, scroll down, the console.cloud.google.com. That you can click. See, using this ID, you didn't create any account, right? So far, you didn't create any account, right?
Right.
So it's first time you are using this email ID for GCP console. So you can select project on top left side top. There is a button, select project. Next to home button. Next to home button, there is a project selection button. So here, look at this demo-GCP. project you have provided access, right? That is already visible here with the new email ID, with the new user. It's already discussed. See, using this ID, I'm repeating, using this ID, the new ID, there is no Google Cloud account created by Jyoti, but still it is visible. The once since you provided access, that project you are able to select. Now, can you go to home page, or you can directly go to cloud storage on the left side middle. Cloud storage is there. And what access we provided? Storage admin is the access we provided. So if you come here, storage admin, you can create the bucket. There is a button, right? Create bucket. Okay, create bucket. All this button is active. If you click, it will help you to create bucket. Hold on, go back to home page. Just click on Google Cloud Platform. No, here itself, Edge itself. Yeah, go to home page. Okay, go to compute engine, VM instances. Yes. See, if you open compute engine, obviously you do not have sufficient permission to view this page. Using the new user ID, we try to open some other service because we provided access only to storage admin. So when we open compute engine, this is the error you will get. If you don't have permission, you do not have sufficient permission to view this page. If you want, you can do one more thing. Go to this Edge and open some other one more service also. You can open and check whether you have access anything else. Like go to home page. Here it's something little Kubernetes or VPC or anything. Yeah, everywhere you will find the same error because you have access only to storage. Okay. All right. Now you can go back to Chrome browser. Yeah, you can go to Chrome browser. Okay, we are going to provide one more permission. Go to IAM. Okay, now again one more permission. Let's go with a different permission. Just edit your account. You already have a storage admin, right? Here, edit instead of adding. You can edit it. Yeah, this one, there is extreme right. There is edit button. Just edit your new entry, new email ID entry. There is a pencil button, right? No, there is a pencil button down, like along with every entry, it writes that one, which is okay from bottom, second or first, which is your secondary. Okay, not that storage admin you need to edit. Okay, storage, yes, that one you need to edit. All right, so this is the permission we provide. Let it be storage admin. You can keep it just like this. You can add another role. Here you can add basic viewer role. Drop down basic and viewer role you can add. You're not providing owner permission yet. You're just providing the viewer permission just to save it. All right. At the beginning, we provided storage admin, and now it's project owner. Sorry, project viewer. You can switch to Edge. Yes. You can just close that recommendation on the right side. Okay. And what's next? Okay. Now you're in storage, right? You can go to somewhere else, maybe compute engine. Okay. You're in Edge, is it? Hold on. Why? Okay. You can go to home page. On the left side top, there is a home page, right? Home button is there, right? Left side. Yeah. Click home. Yeah. Click there. Yeah. This is the expected home page. Yeah. So go to compute engine and VM instances. I hope others are following. Refresh from top, from the browser level. Go to browser and refresh from there, because we provided viewer permission, right? We are supposed to view this page without any error. So hi, Solomon. I think last session you didn't introduce yourself like last time. Are you there, Solomon?
Hi, Anish.
Okay, so you can introduce. You can. I don't know. Like I spoke to Mindmajix, but I don't know you. Like, what's your total experience and which profile are you working and why are you looking to learn Google Cloud? Will you fill these three questions?
Yeah,
Your
actually,
total experience, profile, and the intention of learning Google Cloud. Please go ahead.
yeah, I have total of 4 years experience. Hello,
Yeah,
can you
go
hear?
ahead. Yeah, please. You can. I can hear you.
Yeah, but I worked on network side. Right now, it is a company requirement for the GCP. For that, I'm learning the GCP.
So network side means what's your total experience?
It is 4 years experience,
4 years, right? Network service. Network side means like cloud network or
not
uh,
cloud.
okay, generally. Okay, this is the
Mhm.
first cloud you're learning. Am I right?
Yeah.
Okay, so networking means network admin. You are right.
Yes, yes.
Okay, 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 fine. All right. So we have a different from different areas, different people are there. So when we discuss that topic, you can take help from internally. All right. We
Yes.
have from networking, administration, databases, data warehousing, every background we have. All right. Now, if you come back, look. If you look at the screen, the compute engine that's opened, VM instances, um, and you can't really create an instance. You can see that create instance button is grayed out on top. Create instance button is not active. But when we open storage, it is click on that, it won't work.
Yeah, it shows the
Okay.
message required
Yeah, right,
permission.
right. So if you go to storage and if you do it, definitely it will be working again. So the reason is here you have viewer permission, right? All other services you can just view it, like if you have some 10 compute engine, you can view it, like what is the name, what is the IP address, all these information you will find it from there, but you can't really make any changes there. Okay, so here there are two permissions, right? One is project viewer permission and one is storage admin permission. And there is again one more point we need to consider here. We discussed about policy inheritance in the previous session. Policy inheritance, the project viewer permission is something inherited. When you open compute engine, that's an inherited permission. That also you need to consider. It's clear, right? It's an inherited permission. Do you remember? We provided access in the project level, but when you open compute engine, that permission is inherited. We will start a new topic here today, and we'll do a small activity and stop it. All the complex things or detailed things we will discuss how on the on Wednesday. So we'll start storage today, and very basic things we will discuss, and we'll do a quick lab and stop it. So I'm skipping to module 5. This we will just changing the order. This we will start on Wednesday or something. Going to GCS or Google Cloud Storage. Just like IAM, this also not a complex topic, like it's a little tricky or logical, nothing else. That's why like we'll first deal with some light topic, then we will go to little more complex topics. Our second service, which is Google Cloud Storage, or it's called GCS. GCS, Google Cloud Storage. Google Cloud Storage provide worldwide highly durable object storage that scale to exabytes of data. There are two types of storage in general, okay, not about cloud. In general, there are two types of storage. One is block storage and the second one is object storage. Does anyone know what is this difference? Object storage plus block storage. Here, it's a general concept. Okay, I'll take some examples. Block storage is something you're getting a raw disk or raw storage, or you're getting a disk. Like for example, if you get a external hard disk, okay, how you will use it? You will connect to a machine, you will connect to your laptop, Sometime you will format it, right? If you ever did that, like formatting a hard disk, what exactly you're doing there? You're actually creating a file system. When you do a format a pen drive or hard disk, what you're doing is you're creating a file system there. File system is something logical division, right? It will divide your disk as blocks, and whenever whatever you write the data, it will be what are the zeros and ones that will be kept it in that blocks. That's how it works. So that kind of storage, like you are getting a raw disk and you are using it however you want. You are creating a file system according to your requirement. Maybe in Windows the file system type is different, in Linux it is different. So depends on your operating system. You are only deciding which file system you require, and creating the file system and using it, attaching and using it. Such storage is called block storage. Your external disk or pen drive, all these are the real-time examples. When it comes to organizations, you may get the storage from the you may get the lens or some storage from the storage team, like we discussed the storage boxes, right, in the initial session, like large storage boxes. From there, some logical, some 100 GB space you will get, and you will do the formatting. If it is Windows, you will do the disk management and formatting and use it. If it is Linux, you will use some commands and use it. So such storage is called block storage. You are getting a raw disk, you are customizing and using it. That is block storage. Today we are going to discuss about object storage. Object storage means real-time example. If you take Google Drive is an object storage. We can say that. What is Google Drive? Unlike your pen drive or hard disk, unlike what you're not doing there in Google Drive, it's a ready-to-use storage as a service, right? Ready-to-use storage. You're not formatting. You're not worried where it is hosted, whether any server or something where it is hosted, or you're not creating any file system. You're just using it, right? You're just uploading your content, setting the permission. If you want, you're sharing to others and just using it. That is called such storage is called object storage. In Google Cloud, you have both the options. Under Compute Engine, we are going to discuss about block storages, and here we are discussing object storage. Object storage is a separate service. In AWS, it's called S3, Simple Storage Service. S3, 3S are there. Okay, Simple Storage Service. So here it is GCS, Google Cloud Storage. So it is object storage. I hope this is clear. The basics, it is clear. And cloud storage, you can see images, pictures, videos, or objects. Storage for custom data analytics. What are the use cases of this storage? That's what we are discussing. You can save any object. What is object actually? Object is any data you save in your storage. That is called object. It can be images or videos, anything, documents, anything you can store it in the storage. So images, pictures, videos, objects, blobs, unstructured data, anything you can store it. Then we can use it for data analysis, data analytic pipelines. You can use it. You can keep the data, and using any other external tools like a data flow, BigQuery, any data warehousing tool, or any kind of tool you can attach with the storage and use it. You can keep your data here, and using the external tools, you can do the data analysis. Then storing multimedia or hosting your website, like if you have a static website, like where there is no such many transactions are happening, just a static website, you can store it, you can host it in Google Cloud Storage. We are using it in some second half of our training. This one, keeping a website in the storage, you keeping your web front end in storage. Then backups and archives. Okay, you can use it for keeping your old backup and archives, like large amount of file, you can keep it. All right, these are some of the general use cases of storage, but technically you can do anything. You can keep anything in storage. It looks just like a Google Drive, like the usage is just like Google Drive, like you can open using a web interface and upload the content. You can set the permissions as well, but much more advanced. It's an enterprise level storage. Unlike Google Drive, there are a lot of other options here. Features: unified experience, strongly consistent listing, geo-redundant we'll discuss. Scalable to exabytes. So highly scalable, unlimited storage space. It's an unlimited storage. When you create a storage, what you do, like when you're creating a disk and all, generally in cloud or somewhere else, you need to specify the size, right? like I needed 20 GB, 25 GB disk, 100 GB disk, something like that. You need to specify the size. But here, it's not required. It's unlimited storage, which means you don't need to specify the size. You can just create a storage and use it. And you will be charged based on how much content you keep it in that storage, how much content you upload into that storage. Storage as a service. This is called storage as a service. We discussed, right? IaaS, infrastructure as a service, then platform as a service. Just like that, those are the basic service models. But here it is called storage as a service via web app API. Like you're getting as a service, you're not adding any disk, or you're not managing any disk, expanding or whatever. You're not worried about the backend, what is happening. You're getting it as a service. That's the idea here. Data durability, these two numbers you need to remember. Durability is 99.999, availability is 99.999. Fast and highly available. No minimal object size, like you can save any small bytes of data also, you can save it. Pay as per core model. I already mentioned it depends on, you'll be charged based on how much size you keep it in that storage. Depends on your usage. This is the most cost-effective solution of Google Cloud, like the, I can say, most cheapest storage of Google Cloud compared to any other storage which we are going to discuss further. Maybe the databases or compute engine storage, disks. Compared to everything, this is the low-cost solution, very cost-effective solution. So if you have large amount of data to keep it in less for less cost and all, this is the best option. Large amount of data and you don't need to pay, you don't want to pay much. So instead of keeping it in server, you can keep it in GCS, object storage. Some of the general features again, lifecycle management, versioning, retention policy, object hold, encryption, ACL permissions, notifications. So all these we are going to discuss in separate slides. So I'm not getting into all these, like what is versioning, retention period. All these are general concepts also, like nothing is new. Maybe work a few you may able to relate it, right? Something, some retention policy, versioning, encryption, of course. Then all these are general terms. We will discuss how this is applied in Google Cloud Storage. So this is the architecture of storage. It will be under project. Okay, that's called bucket. Your storage is called buckets here, and it will be under a project always. Everything is under project, right? So directly under project, you can create storage. And when it comes to Google Cloud, we call this bucket. Okay, every storage is called as bucket. Even in AWS is called bucket. S3 buckets. Okay, under bucket, you can keep the objects. Objects are your actual data. Without a bucket, you can't keep your objects at all. Bucket is the first logical entity. It is nothing, it's a logical container which holds your data. Every data you store will be under a bucket, and the bucket name will be globally unique. This is very important. The bucket name is globally unique. Example, if I created a bucket called GCP training, no one in the world will be able to create another bucket with the same name, no matter whether it's in same project or different organization. No matter what, nobody will be able to create. It's globally unique. Okay, just like email ID. If someone create an email ID, others won't be able to create using same, right? The same way, you won't be able to repeat the bucket names. So no matter if just because you are in a different project, it won't make any difference. Bucket name cannot be changed once it is created. Labels can be added. We'll see what is labels later. IAM provides security and permission. We already did that today, bucket, right? We provided securities and permission to the bucket today already. So when you create a storage bucket, you need to think some criteria. While naming the bucket, you need to think, you need to consider all this. It should be lowercase, and underscores are not allowed. Spaces not allowed. Starts and end with a number or letter, 3 to 63 characters. IP addresses are not allowed. You cannot create a bucket name with a 10.90.2.2, something like that. You can't create it. And also it should not start with the Google and any other misspellings of Google. So these are some of the naming criteria of a bucket. Even if you don't know these criteria also, it doesn't matter because it won't allow you to create if you violate any of these things. But it's good to know this, right? Like in an exam and all, sometime you may get a question that which is the valid bucket name in it. So you need to remember all this. Objects are your actual data. Okay, buckets and object. We are discussing about object storage. Objects are your actual data, and there is no limit when it comes to object. Object has two components, object data and metadata, just like normally only, nothing new. Object owned by the original uploader, and permissions are based on your bucket. This we are going to discuss. We will see this how this permissions are based on bucket and all. Now minimal object size. Maximum size of a single object is 5 terabytes. Maximum size of a single object. Recommended to have fewer bucket and more objects anyway. Signed URL, you can set up the when you share the permission. We do the sharing using Google Drive also, right? So imagine you just went for a trip and you uploaded all the pics in Google Drive and you are sharing with someone. So you will create a link, right? You will create a URL and share it with the others. So in that, like you don't have an expiry time, right? For that URL, you can set an expiry time for shared URL here. Like if you are providing access using a URL, you can set up that, okay, after 2 days the content should not be accessible. That way you can set it up using the concept called signed URL. Time limit, resource access. So these are some of the features of objects. Let's do a lab. We'll create a storage and create a bucket and upload the content. I think I'll only do it because I need to show a few things. Go to storage. See, there are many other storage already. Okay, I'm creating bucket. See, this is a storage console. You can navigate from different places, main menu or wherever. Creating a bucket. Is the font readable? Should I increase? Okay. So here is the bucket name you have to provide. For example, if I'm providing, don't allow because the bucket name is already taken. Because the bucket name is globally unique, so the general names and all you won't get it. See GCP, if I try GCP training, you won't get it. So I'll just provide the date today, 25. I'm just providing 25 April. Okay, that's fine, that's working. So if you try common names, it won't work. Bucket name is globally unique. Labels, these are optional if you want to add any label, something like production. If this bucket is to keep your production data, the production you can keep it, or and value you can keep it maybe 1 or 2, or production db you can, not db, right? Db won't be there, maybe web, whatever you can. You can just do the labeling for your identification, what exactly it does, the environment, maybe life cycles, based on life cycle, based on your business unit, anything you can do the using anything you can do the labeling. If you're managing many bucket, labeling helps. I just clicked on continue. Then location type, you can see multi-regional, dual regional, and regional. See, we discussed in the last session, right? I asked you to make a note about scope of a service. When we discuss service, I mentioned scope we will discuss, right? So here you have multiple option where and all you can create. Either it can be it is in a region. We know what is region, right? It's a city, and inside region there are zones. And here dual region is there, and also multi-regional also there. So there are 3 types of scope, right? We discussed. One is global, regional, and zonal. So just assume, just guess what is the scope of a bucket. Just guess that. Scope is based on the availability, right? Where maximum, where and all you can create it, what level you can create it. It's based on availability, right? So take a minute and share your thoughts. And you have three choices: zonal, regional, and global. See here, you have option to create multi-regional, a multi-region, which means it's global. More than one region means you can consider that's a global. It's not mandatory to that everywhere, like in every region you may not be finding it, but if it is more than one region in Google Cloud, like we can always consider that as a global service. If it is more than one region, maybe both the regions are in US Central, maybe here it's US, not Central. See, even if I select this, it's in US itself, multiple region. When I select this multi-region option, right? This is US itself, multiple region, but still it can be considered as global. I mean, the service type is, the scope of the service is global. See, if I select a region, I can go with any region. See, any region, I can choose it. Dual region, there is another option, dual region. See here itself, based on the continent, you can select two regions. All right, you have option to select two regions like this, dual region. And also the global multi-region or global, we can say multiple regions in US, Europe, or Asia. So what is this exactly? Location type, which means if I uploaded a file, just imagine I uploaded a picture or file, and I'm creating a regional storage. Example, I'll select Belgium. Okay, in a region, in a single region, there are more than one zone, right? Three zones are minimum will be there. So if I create a file or whatever, a picture, if I upload one object, that object copies will be saved. More than one copy definitely will be saved. So in one zone and one more zone, minimum two copies will be there. That's how it's make sure the high availability. If I keep it in a region, one region. All right. Next, if I choose dual region, see I have option where and all, that copy where and all, I can save it. So again, more than one copy will be there. One copy will be there in US Central one, and one will be there in. Now I'm not exactly saying one copy, but it depends on them. It's not really communicated to us. But more than one copy will be definitely there. One will be there in Iowa, and other one will be there in South Carolina. Okay, you got the logic. What is the location type? It depends on what you choose. So if you want more high availability, you need to go for the maximum possible option, multi-regional. Okay, in regional also you will get high availability for a zonal failure. If one zone fail, your data will be safe. About the location type, see, according to the location, the cost is also getting changed. 0.026 per GB per month. If I go for this one, see again it's reduced 0.20, little more less. Okay, I'll go with the regional. Next one is storage class. This one we will discuss on Wednesday. See, there are 4 types: standard, linear-line, core-line, and archive. Storage class we are going to discuss in detail, so I'm going with the default option, standard. Next is see how to control access to objects. Here you can two options, access wise, uniform access or fine grained access. Uniform access means in your storage, whatever, no matter what you upload, everything will be having same access. But fine grain, you can set up the granular access, just like Google Drive, right? If you have a drive, you have different directory, you can provide different permission. That even though it's everything is in your Google Drive, when you're sharing to others, different permission you can provide. So fine grained access, I'm going with fine grained access because I need to provide different permission. How to protect the data? There are few options. So versioning, retention policy, all these we will do it. We will discuss later. I'm going with none. Okay, no other protection. I'm not using any protection, data protection. So I'll go and create. There is an encryption option also. We will discuss this later. I'm going to create. All right, it's created very quick. So one, we created a bucket. Okay, important. We created a bucket. See which one? 25 April, the last one. It is 12. Delete it. I think there is some retention or something. It's not allowing me to delete. Too. I need to check that why. We'll do it later. Bucket. I just went inside the bucket. I can upload any file. All right. So we'll upload a file. I just uploaded an image. All right, it's very quick. I just clicked on upload file and it is uploaded. Anywhere you can upload it. There are different ways you can copy the data or upload. This is just manual upload. You have multiple options. From command line, you can upload the content that we will discuss on Wednesday. As of now, I went with a very small option. So I just uploaded it. See, I can go inside. See, I just selected the object details. If you go to object details, you will find everything. See, size, type, everything. There is an authenticated URL as well. And you will see the preview also sometime. The version history, it's not really visible. All right. So I'm just copying this authenticated URL, or I'm just clicking on top of this authenticated URL. All right, it's just downloading it. While we creating storage, we have seen one option, which is storage classes, standard, airline, core line, and archive. These are the storage classes we saw yesterday. I said we'll skip this, and I think we went with the standard storage. So let's see what it is. Standard storage, and there are three others. Standard storage, it's ideal for frequently accessed data. If you have planned to access the data, like yesterday we created a storage and we uploaded some content. If you have planned to access the data, maybe every day or a few times in a week or few times in a month, in all these cases, you can go with standard storage. Cost is higher than all other storage classes. Keep the data in same region if other service use this storage. It's good for serving any kind of daily basis or frequently accessed content and serving website, videos, executing interactive workload, or serving data, supportive, anything. Okay, all the general purpose you can use it, like whenever you access the content on daily basis or at least few times in a month. That is standard storage or all the general purpose. Different storage classes got different SLA. Anyway, that you don't need to remember it. Airline storage. Here the difference comes. It is good for infrequent access. If you have planned to access data infrequently or once, if you have planned to, if you are not planning to touch the data at least for a month, you uploaded the content, you're not at all touching the data. When I say touching the data, you're not reading it, you're not listing, modifying or anything. You are not doing all these things for a month. Okay, you are not even listing the data from storage. All right, and also you are not deleting the data. Also, that's also important. You are not deleting the data. You are at least 1 month. You are keeping the data in storage. That is nearline storage. In that case, that storage we can keep it in nearline class. 30 days minimum storage duration. So in this 30 days, I'm repeating, you are not accessing the data. Accessing means reading. Then not deleting the data, not even listing the data. All right, you are just keeping it just like that. In that case, we can keep it in nearline storage. Next one, core line storage. The same concept. 90 days you are not touching the data. 90 days you are not touching the data. In that case, you are just keeping it. You are uploading the content, and 90 days you are not touching the data. In that case, you can go for core line storage. And what is the difference here? Like, why do we need to keep in different storage classes? You will save the money. You can, the cost wise it is less compared to standard. Nearline is less compared to nearline. Core line storage is the more cost effective. In the same way for archive storage, 1 year you are not touching the data. It's ideal for data archiving, online backup, disaster recovery, etc. So it depends on what kind of data you are keeping. You can just classify, and if you are properly keeping it in right storage class, you can save the bill, like you can save the money. And here is the cost difference. If you choose US location, US multi-region, okay, multi-region storage, we now write multi-region, dual region, and regional, 3 types are there. If you choose this one, standard storage, per GB per month, you're paying 0.026. And when it comes to archive storage, it is 0.004. There is a huge difference here. Okay, so we are discussing different properties or different concepts of storage. Next is security. IAM policy applies at bucket level and ACL applies at object level. Let's see what it is. All right, if you go to storage, on the extreme right side, you can just check this, edit access. So when I click on edit access, it is almost showing the IAM console, right? It's a kind of IAM console. See here, add principal, all these are IAM roles, right? If you go to add principals, just like IAM, how it comes, you can provide the access, select the role, only storage related roles will be listed here. See all the, wherever storage is involved, all those services are also listed here. Data flow, wherever storage is involved. So bucket level, you have IAM permission, very important. Bucket level, okay, bucket level, you have IAM permission. And when it comes to object level, all right, this is object, right? Object level, it is ACL permission. This is what we did yesterday, right? ACL. ACL means access control list. It is a common concept, not just in cloud. Access control list. These are the lists which control access. If you want, you can add more into it. So it's bucket level, different permission, and object level, bucket level IAM, and object level ACL. This you need to make a note. So 2 different type of access you can provide. This we already know how to do, and IAM also we already know. All right, next, data encryption options. And while creating storage, we just saw one option, which is encryption. There are different types of encryption. This is a general slide, okay, not just applicable for storage. It's a general slide. There are different types of encryption provided by Google Cloud. Before that, I just wanted to make a general statement. It is in Google Cloud, each and every data, what are the data you upload in any form, not only in storage. Yesterday, from my laptop, I have uploaded one image, right, into storage. Just like that, any kind of data which is traveling over Google Cloud network or any services, that data will be encrypted. Without, you won't find any plain data without encryption. So that is the first statement, not just with the storage, any kind of storage related or wherever the data is involved, any kind of service, when you are creating, there will be a storage, the encryption option. Example, if you go to compute engine and disks, data disk, any kind of service where data is involved, their encryption options also will be there. And there are 4 types of encryption. See here itself, 3 types of encryptions are there: customer managed, customer supplied encryption key. All right, and where in storage also there were encryption option. You don't need to remember which encryption option is where, that and all you don't have to remember. Just generally there are different types of encryption option, and also all the data, entire data will be encrypted. That's also you need to remember. Google managed key. First one is Google managed key. Google encrypt the data before saving the disk using Google Managed Key. Google Managed Key is the default encryption. You don't have to do anything. Any service you will be finding by default Google Managed Key. Google itself will create the key and manage it. Second one is customer supplied key. You can create and manage your own encryption key. There is key management service here in Google itself, Google Cloud itself. You can, okay. Third one is that, okay. User can generate and manage keys using key management service. You can create the key and attach the key, the encryption keys. And the second one here it is, you can use any encryption service, like you can use any encryption tool in your laptop and you can provide that particular key. The last one is client side encryption. You can encrypt the data and then upload it. That's also an option. There are 4 ways you can encrypt the data. Most of the cases Google Managed Key. By default you can go for Google Managed Key. Like if you have your own encryption solution for your environment, you can use that as well. So what you need to remember is generally entire data will be encrypted. Just imagine you have a text file, okay, whatever, maybe a Word, MS Word, or a Notepad or whatever. You have a text file, that is file 1. File name is file 1 and the content is 1, 2, 3. Okay, whatever it is inside this content is 1, 2, 3. Okay, whatever it is. File 1 is the file name and it's a text file. All right. So normally if you keep it in Google Cloud Storage, and if you're uploading the file 1 again, like the same file with the modified content, if you're uploading it, it will be just updating. Modified content means 4 and 5 is 4 and 5 are also there. All right, it will be updating in the same file. There will be single file. Finally there will be only one file. All right, file 1 only will be there. But by default versioning is disabled in Google Cloud Storage. By default you have option to enable it. If you enable the versioning, what will happen is, see, file 1, this is your content. Just okay, initially this is your content and you're modifying the content in this file 1, which means cloud storage is a totally read only storage. You can't really edit it inside the storage. So you're uploading, you're modifying, and the new file is coming up, okay, with the same file name. So here 6 is also there. In this case, what will happen is it will archive this file 1 hash. It will archive this file. It will keep a copy, okay, whatever the random number with the name, and new file will be created, file 1, with the new content. Okay, 1, 2, 3, 4, 5, 6. 6 is there. The old one will be archived. This will be keep it as a copy. All right, and always whenever the user access the latest one, the new one will be available whenever the user access it. All right, instead of overriding in the existing file, it will keep a copy, or it will archive the file, and always the latest will be accessible. Instead of overriding the existing content, it will keep a copy of the file, so that if you have a chance, like if there is some files multiple people are managing, so you can find who is making what changes, and if you want to revoke or something with the older file, you have option. You have the versions kept, multiple versions kept. Is this clear, Devika? So versioning, that is it's a general concept, like in different levels of versioning is there, like here and there. If you notice Word, when you're using Word also, there is some kind of versioning in it. Applies at bucket level and disabled by default. If you enable versioning, instead of overriding, it set versions at file level. While accessing the object, it's always give live object. And version names starts with hash, your actual file name plus hash. Version names. Lifecycle policies. There is one option, lifecycle All right, this is the requirement. Just imagine this is the requirement. You are saving some files in Google Cloud Storage on day one, and after that, you want to move this file to backup. Okay, any other class we can call nearline or core line or whatever. Any other class, 6 month maybe not nearline. Maybe we can go for at least core line. And after 1 year, you need to move that content to archive, and after 5 years, it has to be deleted. This is your requirement. You're dealing with the too many number of files, and there are a lot of storage also, and daily basis content is a lot of files are getting generated, so you can't do this activity you manually, right? Because after 6 months, whatever the file which is older than 6 months, you need to move the class storage class. So what you can do is, this is your requirement: standard, nearline, core line, or delete file. Okay, nearline, this can be anything, whatever it is. You are changing the class, and after some years, you are deleting the file. This can be achieved using lifecycle policies. Here is the option. You can add the lifecycle rules. Lifecycle rules. You can change the storage classes, or you can delete the object based on certain conditions. You can see these conditions based on age, maybe which is older than 1,000 days, something like that. You can provide, or created before, some maybe before 2015, something like that. You can mention all these different criterias. You can set the condition. Either you can change the storage class of the existing content, or you can delete the content using lifecycle rules. So I can set something like, okay, 2 files are there, and add row, delete, continue, age which is more than 1 day. So what will happen is, whatever the content you're adding in this bucket, it will get automatically deleted after a day. Creating it, you can't really see this right away, because this lifecycle rules run. There is no specific timing. They have set up some timing. Next to 24 hours, anytime it will run. All right, right away you can't see this option after doing it. So if you set a rule, next 24 hour, whenever the patch runs, it will be applicable here. All right, that is lifecycle rules. And while creating storage, we saw a couple of options. Let's see that as well. Permissions, protection, like not permission, protection. There is something called retention policy. Retention policy, if you set, example, I'm setting 2 days, okay, retention policy. What will happen is, it's almost it's like lock your bucket. There won't be changes, or deletion or modification won't happen. Modification will happen, deletion won't happen. Accidental, this is to prevent the accidental deletion. Okay, I just set up retention policy just for 2 days. All right, and if I try to delete this content, it won't happen. See, I'm trying to delete this file. And including you, that's the important part, is including you. Even though you are the owner of the bucket, if you set a retention policy, including you or your teammate or whoever got access, they won't be able to delete your contents in bucket, which this is called retention policy. All right, so if you go to here, no, protection, and if you remove it, you can delete the content. And retention policy is for entire bucket, the whole bucket. The retention policy is applicable for entire bucket. But there is one more option. If you go to a single file, okay, retention policy, it's applicable for the entire bucket. If you enable it, if you have 100 files for all these, it will be applicable. But if you wanted to do the same for one file, you can use object holes. There is one option of hole status. You can go for object holes. Save the hole settings so that only this file won't be able to delete them. Image 3608, right? So I'm trying to delete this content. Okay, this is deleted and this won't be able to delete. All right, error. So this way you can log the content, like if you're working in a file and nobody else wanted to modify that, in that case you can just set up this either retention policy or you can go for object holes. See, if you go here, configuration, fine-grained access we set while creating, protection object versioning. We can turn on the versioning maybe. Okay, these are IAM permissions. Protection, when it comes to protection, versioning plus retention policy and lifecycle rules. These all are the options. Total features of GCS buckets. Any questions in general? Actually, this versioning option were there only in command line earlier. So my documentation is in command line. So you can see this this versioning GUI option recently disabled. The maximum number of versions per object, maybe we can make it 10. Expire non-current versions after 7 days. Okay, the old versions will be deleted maybe after 30 days, something like that. So maximum 10 versions will be kept for one file. So I'm turning this versioning on. All right, let's create some file. I'm doing in this graphical mode for the first time. I'll say I have kept a document in this document share, in that it will be in command line. You can do it from G Cloud Shell. Okay, this is my file, and content is file 1. I kept it in desktop. I'm closing it. This is the content 1, 2, and 3. This is my content. Let's try this. I'm uploading that file from desktop. All right. File 1 is uploaded. Let's see the content. Okay. I think I should go for the notepad. All right, I have created another file and version.txt. I'm just uploading this file. Let's see this version.txt. This is the file. All right, if I open this file and try to open this link, the content of the file is 1, 2, 3. Okay, just like a word, instead of that I used a text file 1, 2 and 3. And what I'm going to do is I'm going to edit this file, adding 4 and 5. Save it, uploading it again. All right, now my content is changed. Okay, in exclude object from this upload version dot. Okay, I have uploaded it again, and when I refresh this, new content will be visible 1, 2, 3, 4, 5. And if I go to version history, see there is one old version. This is the live file, and one more got created. All right, if you want, we can see this details. Can't really directly access it. It looks like. There is no URL involved. It is more easy with the command line for me. Let's download and see. The old version will be available. See, okay, download. When I click on download, it's opening in URL. So the old version will be available. What is versioning? We enable the versioning. We uploaded the content with the 1, 2, 3. That's the file content. And when we try to access it with the old version, see, when we override it, one version got created. See here, this is the time, and this is the version details. And you have restore button also. You can see the under versioning, and always when you access the live file, if you click on the live object, you will be getting the latest file. You can try this, add multiple time and try it here. And old versions and all, you can delete it. You can set the timing. Multi-layer encryption, logs and audit. Logs will be there so that you can see who all are accessing, what all the activities are happening in your bucket. Then ACL and IAM policy. We already discussed. ACL applies at object level and IAM policy applies at bucket level. Retention policy, object hold. This also, both are same. Retention policy applies at bucket level, and object holds, you can do it in one file or object level. Pricing criteria, first is for the data storage. The amount of data you keep it in storage, for that you need to pay network usage. The amount of data read from between your bucket, read from or moved between your bucket. What are the network usages? Operations, like including listing. Okay, the actions of cloud storage including listing, you need to pay retrieval and early deletion fees. This is applicable only for nearline, core line, and archive, not exactly in standard. Standard, there is no condition that you need to keep it for this many days, right? Only in the storage, when it comes to the storage class, the last three storage class, nearline, core line, and archive. Example, nearline, you need to keep it for 30 days. If you are deleting it after 10 days, then on early deletion phases applicable for you. That's how it manage it, balance it. So when I say you are not supposed to touch the data for 1 month, it doesn't mean that you won't be able to access at all. Like your data will be there, it will be accessible. But if you are violating this condition, you need to pay extra, the early deletion fees or retrieval fees. You need to pay for it. So you won't be getting the full benefits of the whatever the cost you're saving, right? You won't be getting that full benefits. That's the only case. Your data will be always accessible for you. These are the pricing criteria. And when I say listing and all, listing operation and all, there are some caps like first 10,000 and all not chargeable. But for data storage, there is no such. I mean, if you are saving very small files and all, it won't be hardly you end up on paying. If there is some certain GB only, you will be chargeable. Or instead of every month, like if you keep it in small file, maybe after 6 months, every 3 month or 6 month, including other services, it will charge. Like very small charges, it will be ignored. And again, for the listing operation and all, there are some caps. If you reach to that cap only, you will be chargeable. All right, let's do some command line activity also, because we learned about Cloud Shell. We will get familiar with the Cloud Shell as well. So let's go to Cloud Shell. This is the button. If you don't remember, this is the button. All of you be familiar with both the sides, command line plus GUI. Don't just stick with the GUI. There are some activities you can do it only command line, and also there are many options as well in command line. All right, there are many options. Here it's not just a CMD, like in Windows and all you have CMD, right? Not just that, you have many options here. See here, restart, upload, download, then many things. Here also there is an editor. Like if you're doing coding and all, there is an editor here. You can just make all your code changes easily. It's an inbuilt editor. See here, see there are some codes, right? You can easily do the editing of codes. Okay, play here. Just like any other editor, you will find it. You can access all your files from here. Then if you click on open terminal, it will switch back. So just to be familiar with it, just go with all other options. You can make it in full screen. There is a horizontal line. You can make it up and down. Okay. So as I said, if you open Cloud Shell, it will take you to the home directory. This is my home directory. If you open from your system, it will be to your home directory based on whatever the name you have it in email ID. Storage related commands start with gsutil. gsutil. All the storage related commands. gsutil ls. Those who are not familiar with Linux, ls is a Linux command, so it is very easy to remember. So gsutil is Google Cloud command, and ls is Linux command when it comes to listing. See here, I'm simply doing ls. That is also giving some contents which is there in my home directory. Home directory is something like a desktop. Okay, so when I do ls, it's listing all the content, but when I do the ls command along with the gsutil, it's listing all the buckets. See here, all these buckets are listing here. See this storage, what are the buckets I have, that's listing here as well. See this. And if you want to list the content of the bucket, here I'm just using 25 April, same command. All right, I'm listing the content of bucket. See that image, file 1, version 1, everything, version and everything. If you want to list the versions of file, there is one more command, al. See, versions are also getting listed. See, versions are something like hash and some random number. Okay, because we enable the versioning. Then if you want to create a bucket. So I mentioned earlier, command line tool, whatever you're doing with the console, you can do the same with command line tools also. So I mentioned that. So let's try to create a bucket. And the command is gsutil mb. And when it comes to command line, when you mention a bucket name, okay, you always it should start with a prefix, gs colon prefix. You can't simply provide a bucket name. So gsutil mb, I'm creating a new bucket. So instead of 25th April, I'm using 30 April maybe. All right. MB, make bucket. MB stands for make bucket. So just creating a bucket, and when I do ls, I can see the bucket. 30 April. If you come back here also, it will be updated. 30 April. If you go inside, nothing is there, no files. All right, there is 0 file in it. We just created a simple bucket. So if I do ls, there are many files in my home directory. I can upload any of this. Yeah, I'm going to upload this particular. Wait a minute, what is there in images? Okay, I'll upload this particular image. So to upload, again, Linux commands start with the gsutil cp. Okay, cp stands for copy. I just mentioned the file name, and I'm gonna mention the bucket name as well. 30, right? Not 25. You can ask any questions if you have. gsutil. I hope the text is readable. Font is readable. All right, it's uploaded the image. So here itself I can see. If you are doing multiple things like this, you will be familiar with all the commands. So here itself I can see the file name, and if you want to see more, so key map, if you go inside, you can access it. All right, the image will be accessible like this. There is a data transfer service. Here we have two storage. Maybe I will upload some more contents in 25th. See, this is the old bucket. I'll upload some more contents maybe. All right, anyway, we are not going to open all these files. I'm just simply uploading some contents. So in 25 April, this particular bucket, there are many content. I'm going to move and transfer into 30. So here source, there are from different source you can transfer the content, like S3 from Amazon S3, or from Azure storage, or Google Cloud storage itself, some internal storage itself you can transfer, or from any other URL like Google Drive or any other cloud drive or something. From any other URL also you can transfer the content. So these are the different sources. So if you go to S3, so you need to provide the access keys. This is the keys you mentioned, right? Access keys, the project access keys you need to provide, just like this JSON key we have in IAM, right? Just like that, you have to provide the key here, access ID and secret ID, secret access key. These two you need to provide for authentication. Or this anyway, you have, if you have AWS account, you can give it a try. Like maybe you can show in the next session also. So we can try from Google Cloud Storage, from one bucket to another bucket. So first bucket, my source bucket is 25 March. So if you want, you can see the file, select the files also. I'm just selecting it. And okay, that's the source. You have multiple other options like prefix and all you can add. And when I go to destination, I'll mention 30th April. So in 25th, there are many files. Okay, I'm going to transfer to 30th April. Then many other options also you have, like whether to override or delete, or from the source whether you need to delete or whatever. You can just explore this. If you want, you can schedule the data transfer also. And also you can schedule it every day, every week, from one place to another. Like if you are using, if you're working in multi-cloud, and if you want to transfer from AWS to Google Cloud, like you are running some, maybe some data warehousing in Google Cloud with all your content, no matter AWS or Google Cloud. So every week or every day you can transfer the content here. That's also an option. So create it. Okay, has been transferred successfully. The job ran successfully. So these are the content we have. Let's go back and check it in 30th April. In progress, it's not completed. That's about data transfer. And the similar way, there is data transfer from on-premises, not just from cloud. On-premises, and there is transfer appliance. There are different other options also. All right. So you can apply for appliance. Like this is a little different. Okay, we'll see this. So this is something. It was not part of our this one. Since he asked, I explained it. Data transfer service. We are moving to little complex one, which is compute engine, and one of the major topic of our whole course. Let's begin. Let me delete all this. If versioning is enabled also, you won't be able to delete it, okay, because versions will be there. See what all you need to check. You may need to check the object hold. See, there is an object hold instead of uh, retention period. There is an object hold, so it's not allowing me to delete it. All right, now 18th, this can be deleted. So if you are not able to delete, just check everything, retention period, versioning plus object hold. Compute, storage and networking. Compute, storage and networking. So here compute itself, when we discussed compute services itself, compute services is something like wherever the hosting or the computing is involved, like hosting a website or some processing, installing an application or hosting an application or anything, hosting a database. All these hosting part is involved, hosting a website or application or database or anything. Wherever the hosting part is involved, their compute related services comes. Under compute related services itself, there are many services. In that, very important one is compute engine. Okay, under compute related services, you have compute engine, Kubernetes engine, app engine. Just now I deleted few things, right? App engine related stuff. So app engine, cloud run, many are there. We are going to discuss rest of the things at the end of almost at the end of the session. Kubernetes is our last topic, and all other computing services are also almost we are discussing at the end of the training. But compute engine, this is the very important, like everything, all these upcoming, the Kubernetes and the app engine also, the backend is compute engine. So this is a very important topic, compute engine. Compute engine is a service we discussed right under in a data center. Three important things will be there: compute related service, compute, storage, and networking. So storage, we discussed one storage, and there are many other storage and database. When I say storage, it includes the databases also. There also technically you are storing the data, right? So it's coming up when under storage, more things are coming up. And compute engine, this is the first compute related. This is the first service we are going to discuss, which is compute engine. Okay. When I say compute engine, it's a Google service engine. That word is along with the Google Cloud itself. It's coming, and under AWS, it's called EC2. Okay, EC2. That's a service name. EC2 is a service name, and in Google Cloud, it is compute engine or GCE. Okay, it's called GCE, Google Compute Engine. And what we can do with this, with the compute engine, we can create Linux and Windows machine use under compute engine. What you can do is you can create Linux operating systems and Windows operating system, nothing else. Operating system means it's servers, right? In a data center, what you're doing ultimately, you're purchasing a server. Server mean hardware, and on top of that, you're installing an operating system, either Linux or Windows. And on top of Linux or Windows, you're creating whatever application, maybe middleware or a data or a database or a web application, web hosting application. And finally, your application will be ready. That's what you're doing it in real time, like in a data center also. The same way here, Compute Engine offers Linux and Windows virtual machines. Let's see what it is. An instance is a virtual machine. We call that as virtual machine instances. Under Compute Engine, if you create a Linux operating system, that is called VM instances, virtual machine instances. An instance is a virtual machine hosted in Google's infrastructure. Okay, EC2 also, EC2 instances we call in AWS. An instance is a virtual machine hosted in Google's infrastructure. Compute Engine instances are either Linux or Windows operating system runs in Google Cloud. Very simple. Why it's called instances? Okay, why it is called instances? Because, and also why it's called virtual machine instances. These are the some basics. Okay, this is not related to Google. It's something common concept. So there will be physical machine, there will be physical server. I had shown the diagrams earlier. This is how a physical server looks like, and on top of this physical server there is a concept called hypervisor. In we had a slide, right? IaaS, PaaS, infrastructure as service, platform as service. There also there is a detailed diagram, like from bottom hypervisor, on top of that operating system is coming, right? The same way, it's a small diagram of the same physical server. There will be physical server on top of that hypervisor. What does hypervisor do? This is actually helps to virtualize your physical hardware. Why do we need to virtualize that? Next question. So in a physical server, there will be plenty of CPUs and RAM, right? In our laptop, we may have some i5 processor, i7 processor, and some 16 GB RAM or 8 GB RAM or something like that. So in our laptop, if we notice, hardly we use the full capacity of our laptop. Most of the cases, your CPU utilization will be some 10% or 20%. If you ever check in Task Manager or whatever the depends on what operating system you use. If you check in Task Manager in Windows, you will find you hardly use the total capacity of your laptop. Maybe some 10% of your CPU, and maybe some 30% of your memory. That's only maximum you will use. Generally, that's a normal utilization, right? So when it comes to a physical server, there will be some 60 CPU or 250 GB RAM will be there. And if you install a simple operating system, just like a normal operating system, one operating system in a physical server, it will hardly use the capacity of your physical server, maybe 10%. Just like your laptop, it will hardly use a very small amount of capacity of your physical server. So that's the reason the concept of hypervisor. So it's underutilized, right? So you're purchasing a server and hardly you're using it. So some before 2000s and all, generally a server is something like that. One hardware, on top of that, one operating system, just like our laptop. One hardware and one operating system. That's how servers are also being utilized. So we are at that point of time, we already know it's totally considering the capacity, it's very much underutilized. So then only this concept, the hypervisor or virtualization, came into picture after 2000. So virtualization become more popular. What this helps is it virtualize your hardware, and you can create isolated, completely isolated virtual machines. Okay, virtual machines instance you can hold, just virtual machine you can create it. So that, see, you have an isolated Linux operating system with some 4 CPU or 8 CPU, then 16 GB RAM. So that if you have a large server, you can in this server you can have maybe some 5 machine or 10 machines, and everything is completely isolated. This can be Linux, this can be Windows, this can be Ubuntu, one can be different flavors, and there is no connection between these two. Okay, it's totally isolated. You can have one application here, another application here. So this is a kind of revolutionary concept, this hypervisor after 2000. There are many. Does anyone know any hypervisor name here? Like, have you heard about VMware? VMware is a hypervisor basically. So VMware is a company, plus their product is also VMware. All right. And there is a hypervisor called hypervisor itself. There is a open source which is called hypervisor. That itself a hypervisor. Then KVM is a hypervisor Google use in their backend. All right. So these are general idea. I'm not talking about Google Cloud. These are the general idea. If you are able to visualize this only, what you will be able to understand what is upcoming. Okay, physical server you are virtualizing, and so that you're effectively using the total capacity of your physical server. So far clear, right? Why do we need to use hypervisor or virtualization? You can use your total hardware more effectively. So here, now when it comes to Google Cloud, till here we are not managing it. Like in a normal data center, you need to manage physical server plus hypervisor. Till here, we are not managing it. We are directly creating a virtual machine instance. Why it's called instance? Because in VMware, if you want to create a virtual machine, a Linux machine, it will take some 20 minutes or 40 minutes. It will take, depends on the capacity. Here it is very quick. In cloud, it's a pretty quick, very quickly you can create. That's why it's called instance. This is what happening in the backend. Till here, we are not managing also, but this is what in the backend. Physical server is there, and virtual machines here creating on top of physical server. This will use the CPU and memory from here, all here for all the processings. So it's scalable. Like we are going to create it. Before that, we will go through the general features. What is Compute Engine instance? It's a Linux or Windows machine creating under Google Cloud. Scalable, high performance virtual machines. It is flexible for different workloads. When I say different workload or any CPU intensive, memory intensive, any kind of graphical intensive like animation or any type of workload, it is suitable. Different types of virtual machines are there. Linux and Windows. These are the two flavors it support. And Linux itself, there are different types of Linux, right? Ubuntu, Debian, and Fedora, Red Hat Linux. Different types of Linux are there. Different types of machine types are available. What is machine type? We will discuss later. Load balancing. So GC VMs are all these few I'm skipping, which we are going to discuss in detail. Now I'm not explaining what it is. GC VMs, which means Compute Engine VMs, that's the short form, are backed by Google's private global fiber network. We already discussed this, right? There is a networking between all the data center. GC VMs are all VM. When I say VMs are backed, which means data centers are connected, interconnected. CDN. There is a special feature, live migration and auto restart. This is a Google exclusive feature. All right, that's why I highlighted in different color. We'll see what it is later. Different types of disks are available. Storages are available in the backend. OS patch management, printable VMs. All these are special features. GPU, graphical processor. If you are hosting any workloads like animation, games, or any kind of high-end video editing, in all these cases, graphical processing units will be required. So that's available. Billing. When it comes to billing, it is per second billing. Every second you need to pay. When I say every second, like it is cut short into second level. It's if you use a VM for 3 days, 25 minutes, 25 minutes, 32 seconds. In that case, you can you as soon as you delete it, in second level billing stops also. Different types of discounts are available when it comes to billing. Container support. Container, I mentioned about this Kubernetes, Docker, container, all this I mentioned. It support containers. KVM is the hypervisor used in the backend of Compute Engine and GKE. So I was mentioned about just we discussed about hypervisor, right? KVM. Okay, that is hypervisor name. This is what used in the backend anyway. We don't have any control on it. We don't need to bother about it also, but just for your information. When I access a VM, like so we are creating a VM in Google Cloud Compute Engine, and when we access a VM, how to do that? We need to access it, right? That is conventional method only. If it is a Windows, you might have access to some remote machines, right? If it is a Windows, using RDP, and the port number is 3389. RDP is the protocol can be used. And if it is Linux, you can use SSH protocol, the normal method only, and the port number is 22. All right, we will create a VM right now, and then we will move on. First, we will create a Linux instance and configure a web server in it. We will host a website in it, and we will access the website from public network. This is what we are going to do now. Let's create a Compute Engine. Yeah, just click on Google Cloud Platform or go there. Scroll it up a bit. Yeah. Okay, just go to project settings. You can rename your project. No, the name, project name. Save it. All right, just go to compute engine now. You can go to the search box, or you can go to the main menu on the left side. This is only IAM admin left side. There, yeah. That button, left side corner, that menu button is there, right? On the blue bar. Yeah. Click there. Scroll it down. Compute engine VM instances. All right. So enable. You can click on enable. You know what is happening right now. There is a service account is getting created under IAM at this point of time. Compute engine default service account. And also it's enabling all the APIs required for compute engine. That's what's happening now. Only in the large services like app engine, compute engine, or Kubernetes engine, in all these cases, this will be happening. You need to enable the API. When it comes to storage, you don't have to do it. Enabling API, you don't have to do it. So directly it will open. It's enabled, and we are in the compute engine screen. You can hide the info panel. Right side top, there is a button, hide info panel. Now this is left side, you will find a lot of options. We will go through later one by one. Then create instance. First we will have a very simple machine with let's not discuss so much. We'll create a simple machine. Create instance. All right. So first one is instance name. That's your host name of your VM instance name. You can give something like web-server. If you try with block letters, it won't accept. There are some naming conditions and all. So web server, that is fine. Web server will be fine. On the right side, you can see the total estimated cost with the default options. If you whenever you're changing the options, you can see the cost is also getting changed. Next one is label. Label we already discussed under storage. You can label something like production, development, something like that. You can do the labeling. You can add label. Maybe prod DB. You can mention prod and under value you can mention DB, DB1 or something like that, or web prod. In the value you can mention web. So it's a production web server. That's what we meant. All right. Production web server. So maybe web 1, web 2, web 3, if you are dealing with many, you can label. I mean, in every organization, there will be some labeling, naming conventions also that you need to use it, like based on development, production, and based on the billing unit, multiple things will be there. You need to use the labeling accordingly, like not your whatever you think. So that's how it works in labeling. It is used for filtering and also to understand the environment, and all this purpose it will be used. Next is region. You can go with the default region. Either you can go for I recommend to go with the US Central one. Like all the older account, by default it will be showing US Central one. All the new account, it is showing different one. Go with Iowa, that US Central one. So now the US Central one. Machine configuration. If you scroll a bit down, scroll down. Machine configuration, there are different types of machine families. General purpose, compute optimized. Under machine family series, right, there you can see the details, like N2. N2 family means in the backend, Intel Cascade and Ice Lake CPU platforms are getting used. N2D means AMD processor. T2D means all these things. Okay, this you can read yourself what exactly it is. It's not very important for us, but when you really design the environment, you need to consider all these things, like which CPU platforms will get used, and all these things you need to consider. You can go for N1 series. You can select N1. There is no reason. I'm just simply asking to select something. Machine type is machine type. Okay, machine family, machine series, and machine type. When it comes to machine type, there are many. There are some. If you scroll it down, there are different combinations of CPU and memories are available. This area we are going to discuss in detail. So as of now, you can go with default one CPU, very small one, 3.7 GB memory, very small one. You can go for it. Yeah,
This
whatever
one.
it is. Just no, not that small. That standard under standard. The N1 standard one is there, right? That
Okay.
one, yes, default. Okay, rest details we will go later, like that compute optimized and all this part. All right. Okay, hold on. Scroll it little up. If we skipped, that is okay. We are discussing later. Just come little down. Boot disk. There is an option. Boot disk. Change it. Click on change. Boot disk. So this is the place we select our operating system. Boot disk means where you install the operating system, right? So this is the place you choose your operating system. Public images. Under public images, you can find operating system. Drop down that operating system. Yeah, you'll find a lot of OS. Scroll extreme up. Start with CentOS, and if you go to extreme down till Windows. Okay, just before Windows, whatever you're seeing is all are Linux flavors from the top, CentOS to Ubuntu. All are almost all are Linux flavors. In between, there is a Windows SQL on Windows, something like that. Apart from that, all are Linux flavors. You can see SUSE Linux, or Red Hat Linux, CentOS, or anything. You can go with the CentOS or Red Hat Linux. Okay, so when you are doing this lab, you can either go with CentOS or with Red Hat Linux, and also version 7. In the extreme up, you will find CentOS or Red Hat Linux also fine. And version 7, the reason is some commands I have mentioned in the lab document. Those commands works either with the CentOS or Red Hat Linux. Okay, so if you are switching the operating system, you need to search and find the commands for that. There are just 2 commands, so it doesn't matter. So you can search the alternate commands for such operating system. If you go with Linux, only couple of things will be changed. So CentOS we chose, and there are some other options. Custom image snapshot. This also we are going to discuss in detail. Boot disk type. Drop down that. So there are different types of disk backend it's available. So someone asked, right, like why this under storage? What is the cost differences coming? Just like this, different types of storage options are getting used. And when it comes to storage, there are ultimately it will be saving in disks, right? So disks itself, there are different types. SSDs are there, standard disks are there, all these things are there. So everything cost wise also it will be different. So you can go with the balance itself 20 GB. And one more point, if you choose an operating system, by default it will choose the minimum size of the disk. See, CentOS it directly chose 20. You can increase it but can't decrease it. If you try it with the 15, it won't work. If you try 25, it will work. You can give a try. Size. Try with the 15. Okay, it won't work. You can increase it. The boot disk size, you can increase it. 25, right? Right. So this you can do it. Okay, always you can increase as per your standard. So just select anything is fine. Like size is fine, and then select. Click on select. All right. If you scroll down, okay, allow default access, and firewall allow HTTP traffic. You can just simply click on allow HTTP traffic. And there are many other options also. There is a button, right? Network disk security management. There are plenty of other options. If you click on that next button, networking disk security, yeah, there you will find a lot of other options. We are skipping this as of now. we are going to discuss later in detail. You can create it now. You can click on create. You can just count on it, maximum some 20 to 30 seconds only it will create you. It will take time to create a VM. If you consider the VMware or any other traditional technologies to create an operating system, if you ever install an operating system in laptop or something, how much time it takes? Some 45 minutes, 1 hour, right? Here it's a matter of seconds. Now you can hide that related actions at all, building all this. There is a button. Okay, so cool. We created a VM called web server, and there are two IP addresses got created: internal IP and external IP. Okay, this area also we are going to discuss under networking, so I'm not getting into the details, it will be confusing for you. Now we can directly log into your VM. There is a button called SSH connect. You can simply click on SSH. SSH is a general protocol to connect any Linux or Linux machines, any flavor, doesn't matter, Linux or Windows. I mean, not Windows, any like which CentOS, or you can simply click, one new window will be opened. If you're only sharing browser, then you need to share one separately. Is it opened for you? Yeah, right, that's right. So it's opened. It's a new window in browser window itself. It is opened. This is how it looks like. On the right side top, there is a settings button. You can drop down that. Go to font or text size. Go to text size. Make it large. Okay. Or medium also will be fine. Text size medium. All right. This is the web server you have created, and you're able to log in also. You're able to log in the operating system. Like ls space -l. Okay. You can simply run this command ls space -l. Yeah. So nothing is there. df space -h. df space -h. Yeah. This is the file system structure. This is something like we open my computer in Windows. You can see from bottom, third one, 20 GB. You can see the disk size from bottom. You can highlight that 20 GB. You can just highlight that area, 20 GBC. This is the disk size we selected, right? That's also visible. So let's do the activity. You can run this command, sudo yum install sudo yum install httpd-y. This is the command. We are going to install Apache in it. HTTPD is the package. Apache, it's a web hosting platform, right? A web server where you can host your web server. So either you can type or copy and control V. Copy the command and control V. You can do any of this. Or you can type sudo yum install httpd-y. All right, what are we installing is Apache, and we need to convert this. See, if you simply create a Linux machine, it's nothing, right? You need to host an application there. That's why we are creating. So if you to create any application, it depends on your convenience. Anything you can create it. We are creating a web server. We are hosting a small text website in it. All right, we installed the Apache. So next, what you can do is there is another command to start the service. All right, it started. If you want to check whether it started or not, you can press up arrow. Press up arrow, and instead of start, same command, instead of start, you can try status. Status space HTTPD. All right, it is running, service is running. Now you can go back to your previous screen, the GCP console. All right, now you can simply click on external IP. There is an external IP, right? Start with 104. Yes. You just simply click on top of the IP. It will open in a new tab. It's not visible to us. Yeah. So here it's showing testing 123. This page is test to proper installation of Apache server. So this is the default of web page. Okay, default website page. It is a website technically. It's CentOS default page. So let's have some customization. So this is the default page of CentOS. Let's have some customization in it. We will create our own page. So run this command. Just copy this command and run it in the console. So what this doing is it is going to var www.html index.html file. That's the Apache configuration file, default configuration file. It is adding some text content, and the text is hello, welcome to GCP. That is the custom text. We are adding some text in it. Okay, you can copy the command and paste it here. Enter. All right, now you can restart the service. Okay, go to the same command. If you press up arrow, the previous commands will be visible. Again, one more time. Yeah, instead of start, you can use restart. You can use arrow key, like without removing HTTPD, you can use arrow key to move or navigate. So HTTPD won't get removed. Enter. So it's successful. Now you can refresh the page. All of you can you can switch to Akhila. You can switch to your web page and you can refresh it.
Yeah, sure.
That one not for that one. VM instances tab. Now there is a 10.128 IP, right? Internal IP. Using internal IP, you can use some putty or some other normal tool to access it. That's the right way of accessing.
Yeah.
Okay.
Sure.
Right now we are not doing the right way because connecting from SSH, there are external IPs involved. Okay, no, not for using that IP only. Actually, we are when you connect using SSH, that's how we are accessing. That's not the right way because since it's training and we don't have an internal network, we are going with the this way, like external IPv. All right, you can go to the screen, the next web page screen. So this screen is because of the last command. We just updated index.html and we are able to access the website. Others also, if you refresh it, you will be seeing this page, web page. And you can try from anywhere, from your mobile or anywhere. If you type this IP, it's totally public website. This page will be accessible. If you are good with web page or whatever web development, you can have your own page also. If you edit this text, only text-based page will come. Like if you want to add more, you're free to do it. Or instead of web, you can host anything. Like if you are comfortable with any other software or anything else, you can do it. Instead of website, you can install database in it. Anything you can do it. While creating the VM, we just selected machine type. All right, I'm trying to create a machine again, compute engine. So here it is, machine configuration, series, machine type. Let's see what are these options. First is machine family. You can see series under machine family. You can see the series. So series is totally based on the backend processes, what all it's using. So first one is E2. It's select based on the availability. So there is no specific processor family here. Here it is Cascade Lake or Ice Lake Intel processors. Okay, different. Intel processors. Here it is AMD processor. T2D also AMD. Again, N1 is Intel Skylake processors. So what are the differences? You will see the difference in speed. It is in the machine family, the machine type or series uh, documentation. It's very clearly mentioned, like every family, what are the processor speed, like 2.1 gigahertz, 2.4, 2.6, like that. It is specifically mentioned. If you are more interested, you can check the documentation. What is the exact difference between all these things? It's totally based on the performance. So that is series. Under that, you can find machine types. This is very important. Machine type in our slides, you can see this is machine types. There are two types: predefined and custom machine types. Predefined machine type plus custom machine type. Here itself, predefined itself, it's classified into standard, high CPU, high memory, and shared core. Let's see what it is. So again, here machine type, this is the difference. Predefined and custom. You can see it starts with custom machine type. Under that, shared core, then standard, high memory. I hope this font is readable. If not, I'll increase a bit. So high memory and high CPU. So if you look at standard, it's a very common machine type. Like you can see the proportions of CPU and memory. It's kind of okay. So you stand 2 CPU and 8 GB for CPU and 16 GB. It's kind of normal. And when it comes to high memory, it is 2 CPU and 16 GB. The proportion is slightly different. In memory is more. And when it comes to CPU, it is 2 CPU and 2 GB memory. High CPU, you can see 4 CPU and 4 GB. Again, compared to standard, the proportion is different. All right, CPU capacity is more. And when it comes to shared core, it is very small machines. See, if I switch to N1 and shared core, it's very small machine, 1 CPU and the 614 MB. It is less than a mobile phone configuration. Very tiny machines. And the processor core, it is shared on multiple machines. See, you are creating a VM under shared core configuration, and the same CPU may shared into another VM also. Maybe someone else might have created the same. The CPU will be shared. That's why it's called shared core. Core. That word core is related to CPU, right? Many multiple core will be there, right, in a CPU. So that's why it's called shared core. Anyway, just for your information. So this is the 4 type: shared core, standard, high CPU, and high memory. Everything is self-explanatory to understand. The other type is custom machine type. So why custom machine type? Because if you look at the standard machine types, it's 4 CPU, 15 GB, and 8 CPU, 30 GB. I want something in between, 6 CPU and 20 GB if I want. In that case, you can go with custom. So here you can select it. Right, very straight. And it's always recommended to go with predefined machine type than custom machine type. All right, because the price is, cost is, and all, it is near. Like if you're really after selecting custom machine type, if you're really saving good amount of cost, then only you need to go with custom machine type. Otherwise, predefined or predefined machine type is the recommended option. Next, here again, few more options you can find. General purpose, compute optimized. So when I say compute optimized, the entire hardware, the backend hardware, it is optimized for compute, high performance, compute intensive workloads. I can say compute intensive workload. The entire backend hardware. Again, series is different here. See here, it is N1, N2, T2. All these series are there, right? And here it is different. It is C2. From series itself, you can figure it out. C2 because compute optimized. All right, here the processor speed itself very high. You can see the Intel Cascade Lake processor here. Generally the speed itself very high, and you will find some configuration. Compute intensity, it's not about number, okay? It's not about how many CPUs are there. It's more about the entire workload, like entire hardware is optimized, and also one specific CPU the speed is high. See here, here also for CPU, maybe in here also you will find for CPU, but the one CPU core's speed is high. All right, that's why it's called compute intensive, like compute optimized. And again, memory optimized, again same case. Here the configuration itself very high. You can see 416 vCPU, 5.7 GB memory. It is very high because it's a RAM. It's talking about 5.75 GB memory. GPU, graphical processor unit, optimized graphical intensive workload. You can select any of this series. You can select here, and you can add the CPUs, how graphical processor, how many you want. Different types of NVIDIA processors are there. You can add it up to 4. That's about machine configuration. Some shared core, okay. Custom machine type, if none of the general purpose machine type is not matching your need, and again it costs slightly more to use custom machine type than the equivalent predefined machine type. So if you, that's why I said if you are going with the custom machine type, you need to make sure this is you're really saving some cost. All right, all our examples we have already went through. Okay, these are some of the use case of different machine types. All right, we went through already. One more point here. So I asked to select US Central one, right? When you do the lab or when you do the during training, I asked you to select US Central one, right? The reason is, see, here the region is US Central one. You can see machine family, 4 types of family. I'm switching into another location. I was looking for some option. It's not really coming as expected like earlier. All right, leave that. The point is, what I was trying to say is, many options are more, or it is US Central one. If you notice, many configuration options are more in US Central one. Now it's a kind of almost even. Okay, everywhere you are getting all these 4 types. Like earlier, like maybe a few months, couple of months back, if you select somewhere else, some other location, all these options were not there. Maybe GPU optimized, that is not there. See here, it's still it is same. See, this is this error. Okay, error type is type got changed. When I select Europe West 2, it is asking to select some other location than Europe West 2, because this option is not there. This GPU option is not there in Europe West 2. This is the error. Okay, error type got changed. I was looking for a different error. So again, if I select other West 6, again it is asking to select Europe West 1. Only in Europe West 1, this graphical processor optimized option is there. Everywhere it's not there. Again, if you go to memory optimized, see I selected west 6 and it is asking to select west 1. There only this M2 mega, this memory optimized machine is there. Okay, everywhere all these machine families are not available. So if I go back to US Central 1, see it is available. That error is not there. Okay, that error look got changed. That's what I was wondering. All right, you got the point what I'm trying to say. See in US Central 1 and a few of the locations only, all these machine families are available. See when I switch, see this is not available. Memory is not available here. Memory optimized one is not available. While doing the lab, you can just select this everywhere. All the options will be available. US Central 1 if you select it. All right. That's all about that. Unique features, high migration and auto restart. Some of the unique features of compute engine, live migration and auto restart, printable instance, TPU, encryption of boot disk. We'll see what it is. Live migration and auto restart. So just imagine this is hardware, the physical hardware. And this is the machines you have created. This is the compute engine you have created. All right, clear, right? Like last time the diagram I have shown, right? This is the hardware. There is a hypervisor here. This is the virtual machine you have created. Okay, and if there is any issue with this hardware, okay, the physical hardware, like right now, like in our laptop, if there is an issue with hardware, your operating system is also down, right? If that is crashed, so if there is an issue with hardware, this also won't be working. But in this case, like we have created an instance in the lab, right? And if there is any issue with hardware, it will be automatically migrated to another hardware. Like if there is any power failure or if any OS crash or any serious hardware issue, all these virtual machines also will be migrated. Instead of going down, this will be migrated into another hardware. This is called live migration, and it will be migrated, and also it won't go down during the migration. It will be 100% available. Your application will be still accessible. It won't go down. That is called live migration. And while creating the instance, there is an option to choose this. So there is a button right here, network disk security. There is a button. If you expand this, go under management. So here on host maintenance, there is a setting. There are two options: migrate VM or terminate VM. If you select this option, it will be migrated to another hardware. When compute engine perform periodic infrastructure maintenance, it can migrate to another hardware without downtime. So not only if there is a failure during the migration, also periodic maintenance also, this will be migrated to another hardware. Okay, this is one of the very unique feature of compute engine. Next, the same live migration and auto restart. Again, if you come back to the previous mode, if there is any host any operating system level issue, so this is about maintenance and hardware issues, right? If there is any OS issue and system detected some OS issue and system detected that this is going to crash, this operating system is going to crash in some time, at that point of time it will be automatically restart. There is an option automatic restart. All right, automatic restart recommended is on. This also recommended is on, and if you turn it on, to avoid the crash, it will be automatically restarted. The VM will be automatically restarted. Depends on the type of VM. You need to either turn on or turn off the settings. That's about live migration and auto restart. These are some of the scenarios this live migration will happen. Live migration can happen. in these scenarios like regular infrastructure maintenance and upgrade, network and power grid maintenance, failed hardware such as memory, CPU, all this, host OS and BIOS upgrades, system configuration changes. These are some of the scenario the live migration happens. Auto restart is during the maintenance, like if automatically it will restart. Going to discuss many properties, so it will be confusing. You can make your own notes about each one. Printable instance. All right, there is another option here, printable. Few of the options are swapped. It was supposed to be here on top of host maintenance. Okay, on VM termination. Okay, this is grayed out. Choose what happens to your VM when it is printed. Right. So if you turn this option on, okay, spot, this is the printability option. Choose spot to get discounted printability VM. So earlier it was the view was slightly different. Instead of two options, only one option, printability on or off. Okay, earlier means just maybe 2 weeks back. So slightly this is changed. So either you can choose standard or spot. So if I choose spot, okay, the printable option will get on, and okay, I just choose this spot and I created this VM. What will happen is, okay, see, many other options got grayed out, like your live migration, auto restart, many options got grayed out. So I created this VM, spot and stop. So when I created the VM, within next 24 hour, anytime this VM will be deleted, or Google will take this VM back. That's called printability option. Okay, printable VM means if I turn this on, next 24 hour, anytime, maybe it is after 5 hour or 6 hour, anytime this VM will be taken back. All right, that is about printability. So what is the point of doing that? Can someone guess, like, what will be the reason of why do we need to create such an instance? Why do we need this printability? You see, either the VM will be stopped or deleted. You can choose this option. Yeah. Any answer? Why do we need such VMs? So if you turn printable option on, okay, printability is on. All right, you will get the VMs in very low cost, almost up to some 70 to 80% cost, low cost. You will be getting a VM. While creating VM, there is boot disk. This is the place you select the image, public image. Image means it's operating system image. And there are public image, which is provided by Google Cloud itself. It is optimized for GCP. It's not the raw CentOS you're getting. It is in this image. Like many things are optimized only for Google Cloud. Additional features are there. Some small softwares are there. So all these are optimized for Google Cloud. And there are lot of Linux images and Windows also there, and you can find the different versions of each image. The latest 2022 data center edition is available. And custom image, there is another option, custom image. See, if none of these public images are not meeting your requirement, you need an operating system. It's totally different than all this. In that case, you can create your own image. For example, there is no HP Unix here or Solaris here. Okay, those are some of the old operating system. It's not really very popular, it's used. But for some reason, if you want to use that, maybe one or two machines, you need to run that application is only compatible with these operating system. If you want to use that, you have option, you can create your own image under custom image. So how to do that is, you need to go to this compute engine, left side images. So first, if you have that operating system Solaris or whatever the operating system image, if you already have, you can upload that image into Google Cloud Storage, and you can create an image. So storage, you already know, right? We can create image from image one. You can select maybe storage, cloud storage file. You can we already know how to upload. Just map that here, upload it, and select the file from so and so buckets. Okay, if you select it, that's all. You can create an image. So any of you got any specific operating system, like maybe Windows 10, that image is also fine. Windows 10 and all, it's not there, right? Here only the data center versions are available, right? Under Windows also, you don't find any Windows 10 or desktop versions. You won't find it here. Only the data center versions you will find it. Server operating systems. Okay, so that's custom images. All right, if you create a custom image, it will appear here. All right, now it's little tricky concept, like not tricky, storage options. If this is one of the important topic area of today, different type of storage. So there are two types. One is persistent disk. Under persistent disk itself, you will find for classification, standard, SSD, balanced, extreme. And the second one is local SSD. Two types of storage option. One is persistent disk and the second one is local SSD. Under persistent disk itself, there are four types: standard, SSD, balanced, and extreme. All right, let's see what it is. Okay, it's little tricky, but interesting as well. See, while creating boot disk, there was an option to select boot disk type, right? Boot disk type. You can see balanced, extreme, SSD, and standard. All are persistent disk. We already discussed there are two types of disk: persistent and local SSD. All these are persistent disk. What is persistent disk is? See, this is your hardware. This is the compute engine you hosted, and in general, where the disk will be. In general, like in a normal concept, where will be the disk, like as per your understanding? Disk means storage, like your C drive, D drive, all these disks are there, right? Where exactly it will be? When I say where exactly it will be, like in hardware, right? This is where generally. Am I right? This is the hardware, so disk will be inside this hardware. Am I right? In your laptop, where exactly the disk is? Inside your laptop. Am I right? Yeah. Okay. But when you create, see, in general, if you take a Windows machine, C drive is the place where your operating systems are installed. If you open C drive, there will be a directory called Windows. There you will find all the configuration file, all your OS related configuration file, right? So that's where your OS is installed. Okay, it's very little tricky. Just listen carefully. That's where your operating system is installed. But here, see, if you choose boot disk, this is the place you install the operating system, right? You can find all the persistent disks. This persistent disks are coming from the large pool of storage, external storage, large pool of external storage. See, we already discussed in our first session, right? What is storage? I wanted to visualize this in your mind. So here, storage, I said, right, there will be like huge storage boxes. Inside the storage, you will find the pool of disk, like a lot of disks will be there inside the storage. When I say disk, see, each one is disk. All right, large pool of storage. See, this kind of storage, in every box you will find a lot of disks, like this each blue one is disk. So imagine this whole array, like this whole storage, how much disks how much total capacity it forms. So this disk is coming from a storage. This boot disk itself, your operating system boot disk itself, for that whatever the 20 GB, whatever it is selecting, it is coming from a large pool of storage. See this one, this selection, this 10 GB or 20 GB, whatever. This will be coming from the storage. This is called persistent disk. Persistent disk is something, the disk which is coming from a which is located in a large pool of storage, large pool of network storage or whatever, the external storage, not from your hardware, local hardware. In your laptop, generally, like where your boot disk will be, it is inside your hardware. But in Google Cloud, if you create a compute engine, that is not really, it is not really coming from the hardware. Only the CPUs, GPUs, memory, all these will be consumed from here, but not the storage. So what is the advantage of this? Just I'll give a couple of minutes to understand.
Maybe better memory utilization.
No, it is generally, it's related to only disk. Like if you connect a large pool of storage, what is the advantage? And, like instead of using the local one, anyway, in every hardware there will be local disk also, right? It's not about
Can
memory
explain.
utilization. That is, yeah, only it's only about storage. See, storage and memory are different. Okay, when everywhere in compute, generally in compute, when you say memory, it is about RAM, like what you select here, right? RAM, random access memory. Storage is the permanent storage, permanent data storage. See, this is RAM, 4 GB. Here, the 4 GB is RAM, and this is storage. So when you
Common
say
access.
memory utilization, do you mean storage utilization itself?
Right, right, right.
Okay, yeah. So it's not about utilization also, like this one, if you keep it here, instead of, if you use here, what is the disadvantage? Can you think in that perspective? If you use the local one here, what is the disadvantage? If there is any failure of this machine, or if there is any crash, it will affect here, right? See, what was live migration? Like last time we discussed, what is live migration? If there is any issue here, this will be moved to another hardware, right? If you use any disk from the local, like your operating system is in local, just imagine you are using a disk from local. Will this be possible, that migration moving from here to here, is it possible, that live migration? Because you have a direct dependency here. That is the point. And not only that, okay, when you create this large pool of storage, the data loss is very less, like the chances of data loss is very less if you use these kind of storage boxes. Okay, the reason is the data backup and many other redundancy related stuff will be happening in the storage level, in this storage level. That's the advantage of using external storage. All right, so the understanding here is your boot disk or your operating system itself, it is kept in external storage. See, all these are persistent disk. What is persistent disk? This is the pool of storage, external storage, not from your local hardware where you host your compute engine. So what all the advantage, like during live migration and all, it doesn't have the dependency with um, the physical hardware. you can move, this will be migrated just because your disk and your operating system, everything is here in an external storage. Make sense, everybody? Like, can you confirm this is clear? This what is persistent disk? It is coming from a large pool of storage from here.
Yes.
Okay, others, can you confirm? Because this is a little tricky. There is, we discussed, there is persistent disk and local SSD, right? The second type of disk what we have is local SSD. What is local SSD is, anyway, this particular physical server, anyway, it has many disks. Local disks will be there. Every hardware, there will be local disks also, right? In our laptop, inside our hardware, there are disks. That one only we are using. We are not using this one in laptop, right? So that one, the local disk which is already have in your hardware, if you want, optionally you can use it optionally. By default for operating system and all, it is again persistent disk. As an additional disk for additional data also, you can use this here itself. More than one disk you can add. If you want to add more than one disk, see here, anyway, this is mandatory. This first disk is boot disk is mandatory. That's for operating system, right? That is mandatory. If you want to add additional disk, there is option here, add new disk. So more than one disk you can use it. Okay, in the server, definitely it is required. Say 100 GB or whatever, you can use it more than one disk. See, this is also persistent disk. If you add it here also it is persistent disk. You can add additional persistent disk. It will look like this. Okay, in one machine, more than one persistent disk. And if you want, optionally you can use the local disk also, optionally. Okay, it's not mandatory. So to use local disk, every machine type wants support local disk. So I just changed the machine type. And if I drop down under disk, there is a button, add local SSD. Either you can add new disk or add local SSD. Anyway, one disk won't be enough to handle all your, if you are creating a large server. All right, add local SSD. This is optionally you can use this if you can. So local SSD is something which is inside your physical hardware. See, when you choose local SSD, you can't choose the size. Like you can't really choose size something like this. See here, when you are choosing boot disk or additional disk, you are choosing the size, right? See, I'm choosing 55 GB. This is what I want. But here you can't really choose the size. You need to use the entire disk, 375 GB, and you can choose the number of disk you want. See, 2 into 375. One disk size is one local SSD size is 375, and you can choose the number if you want, 1, 2, 3, like that. You can choose. Okay, up to 24 you can choose. Total 9 GB local SSD capacity you will get. Up to 24 disk you can choose from local server. Is this clear? What is persistent disk and what is local SSD? So theoretically, you need to understand or you need to visualize in your mind. This is something coming from external pool of storage. This one optionally you can use it. I'll give you a minute to understand all these things, because if you never deal with all these things, you will find it little confusing. Generally, only you need to understand a lot. You don't need to be too much into it. But generally, when persistent disk, if I say persistent disk, you need to think it is coming from external storage. And local SSD, from the name itself, you can understand. It is local. But what exactly local? Because it's local server. It's coming from local server. Okay, now little more detail we will go. I won't confuse much, but still there are some mandatory areas are there. So I'm going to add a new disk, or I'll add a new disk from a different area, say compute engine, disks. I'm creating a disk. See, without creating a VM instance, I can create a disk here, totally different. I can create an independent isolated disk without a VM, without an operating system also I can create it. See, while creating a disk, there is a button, compare disk type. compare disk type. If I click here, you will find different types of disk: standard, balanced, all these 4 types we already discussed. So what are the difference between these classification: standard, balanced, SSD, and extreme? See, standard and SSD, we are already using it. Like all of us, we have connected from laptop or desktop, right? In that laptop or desktop, either standard or SSD disk only we are using internally. So how many of you know like which disk is in your laptop, like whether it's standard or normal hard disk drive or SSD? Any of you know? SSD. These two are Google specific, it's Google kind of disk. Okay, Google invented disk type, not really the common one. These are common ones, standard and SSD. Standard is older one. Like if you notice for 100 GB, this classification. Okay, this classification is totally based on performance. Performance, the speed of the disk, like input output speed of the writing speed, reading speed of the disk. If you notice 100 GB disk in standard, 75 is the speed, IOPS, input output per second. And when it comes to SSD, it is 3000. All right, 3000. And balanced, you can see by balanced, this is Google's on type of disk. Balanced is something in between standard and SSD. See, SSD is always fast, it's very fast. And extreme, I will come to this. SSD is always fast. Like if you notice here, the SSD, if you notice the SSD one, the cost wise it will be little high than the HDD. If you notice the entire configuration and this. All right, in our laptop, either HDD or SSD will be there. Same way here, there are 4 types. The very low cost one and performance wise also it is low. This is standard, which is standard. And SSD always it is costly. 3000, you can see the performance, right? Up to 3000. Balanced is something in between. This is Google's own type of disk. You won't find it in AWS or somewhere else. And there is one more type. It is extreme persistent disk. What is extreme persistent disk is? This is recently, like maybe even 6 months back, Google added this option, extreme persistent disk. You can choose the performance. You can customize the performance. See, extreme I chose, and provisioned IOPS, you can see it is 10,000 to 1,20,000. All right. See, if I want, I can choose 50,000 IOPS. Like this, you can customize the performance. That is called extreme, and up to 1,20,000 IOPS it's about. If you choose this SSD and all, you can't customize it. Like depends on the size, it will vary. See, if you increase the size, this also will increase. See, for 100 GB, 3000 is the IOPS. If you make it 1000, 1 TB, this is increased. All right, depends on the total size, the performance vary. And when you increase the size, the performance also increase. But there is a threshold up to some extent only it will go. But in extreme, it will go up to 1,20,000. That's the difference between these 4. All right. What you need to understand is all these 4 are coming from the external pool. Depends on what you select. Some of the type of the external storage will get select, and from there logically it will be assigned to your VM. Logically, completely logical. It's not already this large pool of will be connected to your hardware, and when you select 20 GB, that 20 GB will be logically assigned. All right, let's move on. That's all about disks. Okay, there are 2 types, persistent and local. Persistent itself 4 types. These are the 4 types: standard, balanced, SSD, and extreme. See, storage is the place where you keep your data permanently. Storage is, that is something like a very basics of computer, right? Here, see, what is this memory? This memory, like for 3.7 GB memory, that is your RAM, random access memory. Whatever you're seeing in this display, see, when you turn your computer on, whatever I opened a browser, right? Everything is coming from RAM, because and if I close the browser, it will disappear from the RAM also. But when you save some data that is in your disk, correct? Whatever the data I saved here, see documents, all this I'm saving in data. Even if I power it off and power it on also, this data will be persist, right? That's why it's called persistent disk, like in general. So here, whatever the data I'm saving, that will be in the storage, correct? See, this is my storage. And always when I refer memory, okay, when I refer memory, that is about RAM. In general, not only me, like in general, in memory means it's RAM, and storage, like if it is about disk, storage is about disk. All right, storage is about disk and the memory. Like in your mobile phone also, you will find a RAM plus a total phone memory, right? Phone memory is disk and maybe memory card probably, but still that's a permanent memory. But RAM is different. RAM will be more fast and everything, because you need to load everything right here. Let's go through the slides. Persistent disk is block storage. See, when we discussed about GCS, right, Google Cloud Storage, I mentioned that is object storage. If you remember, that is object storage. This is block storage. Persistent disk is block storage, because why I say block storage, we are going to do a lab right now. We will understand at that point of time, because I already mentioned also, you will get a raw disk. You will be creating the file system, depends on the operating system what you use. You will be mounting it and using it. That kind of storage is called block storage, like your pen drive, your external hard disk, everything is block storage, even internal hard disk. So that's what we are dealing with, right? That's called block storage, because you are getting a raw disk. It's up to you which operating system you're using. Anywhere you can attach any type of file system, you can create and use it. That is block storage. Object storage is what we already learned, GCS, Google Cloud Storage. That is ready to use storage or storage as service. See, it can attach from a network storage, external network storage. It behave like a physical disk of your laptop or server. OS disk is a persistent disk. This is a important highlighted area you can see. In our laptop and all, OS is also inside the laptop, right? But here it's not, it's from external. So different variants, independent from virtual machine. This independent from virtual machine means you can delete your VM by keeping this disk. See, I can delete this, okay, by keeping these disks, okay, not about as local SSD. Local SSD one also will be deleted if you delete the VM, but you can keep this disk separately and delete the VM. All the data and everything will be there. You can delete only VM, because this is independent from virtual machine. See, I can simply create also without a VM creation. I can simply create a disk also, independent from virtual machine. And delete compute engine instance by keeping the disk. Performance scale up with size, that you already saw, right? For 100 GB there is certain performance, and more than that again it's increase. Online dynamic resize, you can resize it. Scope is zonal. Okay, what is scope? Again, I'll explain in some time while doing the lab. Scope is zonal. See, disk scope is zonal. Earlier we discussed about images, right? Image scope is global, but a disk scope is zonal. We'll see what it is. Maximum up to 128 disk can be added on one instance. 128 total number, okay, count. See, one disk size will go up to 63 terabytes. Okay, 536 GB, which means 63 terabytes. One disk total maximum size will go up to 63 terabytes. And just like that, 128 can be added. So it is very huge. The total disk which support is very huge. That much is not at all required. See, one disk can go up to 63 terabytes and up to 128 can be added also. This number may change, because don't stick with this number. Total size you can stick with it, but this may change. This may increase. Local SSD are physically attached to the server where you host your VM instance. Okay, local SSD is the fastest storage. See, local SSD, one more point I want to make here. Local SSD is the fastest storage. See here in this list, Extreme is the fastest one, right? See, up to 1,20,000 IOPS it support. Input output per second. In 1 second, 1,20,000 input output blocks it support. So here up to 120, right? See here, when I go to local SSD, I'm going to add local SSD. See, local SSD. See, 375 GB I chose. Maybe I will go a little increase. See here, or if I go to some 4 disk, if I'm adding, see the input output performance. Or if I choose 1 disk, 1,70,000 for one single disk itself, 1,70,000. If I go to 2 disk, it is 3,40,000. From this to this one, okay, see, it's a very huge number. It support. I know why local SSD is very fast. Compared to all the disk, local SSD is the fastest storage performance wise. May I know why? Yeah, because it's just inside the VM, right? Wherever your VM
Yeah.
is there, it's inside that, right? Because this is the VM. It's coming from the VM means it's in this is the operating system only. It's not using any external cable or something. See, if you check your C drive, D drive, and if you connect any external hard disk, where the copying and all where will be fast. If you copy data from C drive to D drive, that will be more performance wise. That will be more, right? If you connect any external hard disk and copy the same amount of data, it will be less because it is connected using cables. This is connected using cables, right? It's all network cables. Using these cables, it is connected. So definitely the local SSD is the fastest one. Logically, you can answer this question. Fastest storage. Its total size is fixed. Either you can you can increase the number, and up to 24 you can add, which is 9 terabytes. VM with a local SSD cannot live migrate. Another logical concept. See, live migration we already discussed. VM with a local SSD cannot live migrate. Why? See, VM with a local SSD. It cannot live migrate means it won't move here. Why? Because there is a dependency with this hardware itself. If there is hardware failure, this will move, right? That's the concept of live migration. But if you attach a local SSD, it won't move. The reason is there is a direct dependency with the hardware. Local SSD, you can't add it in shared core machine. What is shared core? The very tiny machine, right? Very small machines are shared core. You can't add local SSD. The reason is local SSD, you require only the fast machines, like where you read very high performance. And it is not available in shared core because shared core itself is small machine. That's why the logical conflict. Local SSD can attach only while VM creation. So if you notice again, if you come back here, while VM creation only, you have option to add the local SSD here. See, local SSD. After VM creation, you can't do it. Once you create a new VM, you can't add a new local SSD. So if you have planned to use local SSD while VM creation itself, you need to add it. If you add one, you can increase it later. But if you have planned while VM creation itself, you should add it. So this is the difference between standard and SSD. If you ever notice, this is the older technology. Like in future, it will be hardly used. Now also, when you purchase a laptop, you have option to choose HDD or SSD. But this is an older technology. Like size-wise, it's big and it will be little noisy. Like when you turn on laptop, like older laptop and all, you will feel right something is rotating inside. That is mostly disk. So if you turn it on, this will be rotating and this will be reading and writing. That's why the performance is very low because it's an older technology. Like there is a mechanical part inside. But SSDs are just like pen drive. It is a name itself. SSD means solid state drive. So it is like pen drive. There is no moving part inside. You can. That's why performance is high because it looks like this inside. All right, balanced. It's performance wise somewhere in between. Okay, balanced also in the backend they are using SSD only, but performance wise it's not up to the normal SSDs. Again, someone asked, right, how in the GCS session, compute storage session, like why the classes are different. The backend, like nearline, code line, the classes are different, right? I think now you got a better visibility into it. Like different types of disks are used in the backend. In the backend, maybe SSD, standard disk, all these different types of disks are used. All right, this is almost same diagram what I draw, like different combinations of um, compute engine you can use. Like either when you create a compute engine, definitely one boot disk will be there, that is mandatory, and you can add additional disks. This is what we did in last session, and this is what we are going to do now. Okay, we are going to add one more disk in our existing VM. So this is what our current configuration is. We are going to add one more disk today. Okay, this is what we are going to do. Okay, this is what current configuration, this we will do it. One more disk, we are going to add it in the existing VM. So that's our second lab. Add new disk in Compute Engine and mount it. Discussed in detail about disks, like we spent enough time to discuss about disks. So what are the types of disks and everything. Now, whenever we save some data in disk, or whenever a disk or storage is involved, we should have a backup plan. Backup plan means keeping a backup of that particular data. Whatever the data you're saving in disk, we need to keep a backup as well. So wherever a data or disk or whatever is involved, okay, we should have a backup plan also. When I say backup, like that's very important in an organization. Most of the organization, like there will be backup tools, like existing backup tools will be there, like some Net Backup, Tivoli. There are many backup tools in market. Any third-party backup tools will be used to backing up all your VM data, what are the virtual machine or disks or whatever the data. There will be backup plans. So here in Google's own backup solution is snapshot backup. So there are different types of the backup, like snapshot backup means it is taking the entire snapshot of a VM or a disk into a single file. One file will be there that represent your entire VM, or either VM or disk. In Google Cloud, it is disk. When it comes to snapshot backup, it is taking the backup of entire disk. In the one disk, whatever is there, it will be backed up. But there are, in normal cases, in large enterprises, it's not really snapshot backup. It will be file level backup, which means, just imagine in your D drive, there is a directory called data, and inside one more directory is there. Inside that only you kept all your files. All right, D drive slash data, maybe one more directory called files. Inside only all the files are there. So in normal, like file level backup, you can just set it up, the backup, something like that. Okay, in this server I want from D drive slash data, whatever the content inside slash data I want, not slash data, right? Like a d colon data in Windows. So you can set up the data or backup like that. But here it is snapshot backup. It will take the backup of entire disk, no matter what it is, what is inside. Entire disk backup it will be taken. So that is snapshot backup. That's the default solution from Google Cloud. If you want, like if your enterprise is already using any third-party company backup solution, that also can be used. But by default, Google's native solution is snapshot backup. Periodic backup solution of persistent disk. Snapshots are incremental and automatically compressed. Scope of the snapshot is global. Scope is global. Okay, scope is global. That is very important. Scope of the disk is zonal, right? We clearly discussed and we confirmed also. Scope of the disk is zonal. But when it comes to backup of that same disk, scope is global. Okay, when we take snapshot, that file will be there, right? That scope is global. See, if you have a disk that is zonal, which means if the disk is located in US Central 1, always it will be in same zone. But snapshot is global. So what is snapshot? You're taking the backup of the same disk, right? That is snapshot, which is global. All right, I'll show you how it is. Then incremental backup. These 3 lines are explanation of incremental backup. I will do it separately. Regional and multi-regional storage locations are available. This also we will do it while doing. I'll show you. You can set up. You can automate the backup using snapshot schedules. You will see that. So this is incremental backup. See, you have a disk, persistent disk. See, in our case, we have a data disk, right? Data or this data hyphen disk. That's our disks. and we have when we and our content is file 1, file 2, and file 3. That's our content. All right, we have a disk, and our content is file 1, file 2, and file 3. And when it takes its first backup, which means snapshot 1, that will be the full backup of your disk. So snapshot 1 means we are creating a snapshot of this particular disk. Okay, so that will be full backup. Full backup means in this backup also, this is the original content. Okay, this is the original disk, and you are taking a snapshot which is snapshot 1, and this will contain file 1. Okay, this was taken on Monday. Okay, so Monday morning or Monday night, 10 p.m. The first snapshot is taken. Just assume that. And next snapshot is Tuesday. Okay, so we a backup solution means daily basis we need to take the backup. Okay, so in the disk and all there will be changes every day. There will be changes. So daily basis, whatever the changes is happening in the original disk, that should be taken. So if you consider your laptop also, maybe a D drive you are taking the backup. So you are keeping some file. So Monday, if you worked in your laptop, definitely there will be changes, right? Some new files will be added, or old file itself you might have modified. So if you are taking backup, you need to take periodically, right? So in organizations that is mandatory, maybe daily backup or hourly backup, like every 2 hour or 4 hour also the backups will happen. So we are taking the next backup on Tuesday, which is snapshot 2. And by the time snapshot 2 is taken, see here, instead of from the original source, one more file got added, which is file 4. All right, there is some files got changed and one more file got added. So in snapshot 2, what will be the content? File 4. But what just happened in snapshot 2 on Tuesday, only file 4 is there because this is already available. This concept is called incremental backup. Whatever the newly added or modified content will be, only the newly added or modified content will be taken. But first snapshot, everything, the full backup, full snapshot will be there. But when it comes to incremental backup, the second snapshot, either newly added or modified files only will be taken. So in this way you are saving a lot of disk space, because when it comes to backup, you need to keep the, like, when daily basis when you're taking backup, you should have the enough storage also, right? And every day you don't need to take everything. That's also a point. So this way you are saving a lot of space. This backup concept is called incremental backup. Not only in Google Cloud Snapshot, it's something common in the industry. Now here I'm making some changes in file 2, file 1, or just file 1. I'm making some changes only in file 1, which means if it is a word file, MS Word file, I'm adding some more content into it. All right, and next backup, which is on Wednesday. Yeah, only file 1, because this is modified content. Here it is newly added content, snapshot 2, newly added content, and here it is modified content. This concept is called incremental backup. How many disks we have right now? Just click on disks, scroll it up and click on disk. Okay, we have 3 disks and 2 are in use. First one and the last one are in use. You can see that on the right side. One is empty. Okay, web-server, that is empty, and 2 are in use. Okay, how that happened? Because it is supposed to use the web-server, right? Like when
We
we
deleted
recreate
that.
it.
We deleted that VM.
Yeah, but still when we recreate, we are supposed to recreate using the existing disk, right? The two existing disks. Did we select OS or something later? Hmm, that's strange. Maybe while recreating, we might have done some mistake. That's why the total 3 disks. It is supposed to be only 2 disks. That's why that mounting issue also happened possibly. All right. Anyway, there is one more tab at the end, snapshot schedule, and it's showing none. No, in this screen itself, snapshot schedule, and it's showing none. All right, that is fine. On the left side, under disk, there is a button snapshots. Okay, create snapshot. So this is how you can create the snapshot. So you can mention a snapshot boot. You can mention snapshot hyphen boot disk, boot hyphen disk, or anything. Yeah, fine. And source disk you can select, which is your boot disk. Web server new is your boot disk, right? Yes. Go ahead. So we are taking snapshot of one particular disk, one whole disk. And location. Location means when you take the snapshot, you can keep multiple copies in different location. That's what location, where your snapshots will be stored. That's the location. It is the you can select here either regional or multi-regional. If you select regional, there will be multiple copies in different zones. No, any region you can, region you can select. See, your disk is in US Central 1, and you can keep the backup in totally different location. That is possible. So imagine your disk is in US Central 1, backup is in some totally different data center. So that way also you are achieving some level of high availability. So if total US Central 1 is down also, your backup, your disk backup is there in totally different location. So while choosing the location, you need to follow the organization policy, whether which location needs to be saved, either in a single region or multiple region. So you can select multi-region also, multi-region. So multiple regions in US and multiple region in Europe and Asia. That way also you can select. So that way your data will be always safe if you, because multiple copies are keeping in different places. All right, you can select anything regional and any place, but this is the interesting area because you can, if you select, there will be multiple copies. Okay, now if you scroll it down, label and all, I'm skipping, keep coming down. All others are small additional options. You can create it. Okay, so we have taken a snapshot successfully. If you look at the snapshot size, it is 477 MB, megabytes. When you take a snapshot, and the size is 477 MB. It is like your total disk size is 10 GB. Okay, you can see in the same screen at the end, total disk size is 10 GB, and snapshot size is 477 MB. It's the size of the actual data. Not only the size of actual data, and actual data will be somewhere around 1 GB or 2 GB, and when you take a snapshot, the data will be compressed. It won't consume the total size of the data as well. It will be compressed, so that you can save a lot of space. See, for this save for 77 also, you are paying extra, right, for snapshot also. So total, the consumption will be less. Total cost, storage consumption will be less. All right, so because snapshot is something daily basis, you have to take it, right? So that's the reason the data will be compressed. And you can take the snapshot of other disk also, the data disk. Create snapshot. Snapshot hyphen data disk. So you have one server. In that one server, you have two disks, right? So you are taking the backup of both the disks. That's the idea here. All right, you can simply create it. And this is not the right way of setting up the snapshot, because we can't really daily basis, you can't really sit and take the backup, right? You need to automate the backup, right? Because you may have 100 servers to manage, and in 100 server total 500 disk will be there total, and you need to set up backup for every disk. So, and a daily basis it should happen as well. So you can go for snapshot schedule. On the top there is a button, snapshot schedule. Now you can create snapshot schedule. See, schedule is to automate the snapshot. You can make the you can give the name something like daily snapshot. If you come down, see schedule location. See here there are two locations. When it comes to schedule, there are two locations. You can see schedule location, and then there is next option, storage location. It's pretty clear anyway. Snapshot schedule location is something where your disks are located. Okay, if your disks are located on US central one, you can choose that. If you choose some US west or something, you won't be able to take the backup of your location. So this is first one is disk location, where your disks are physically located. So that is US central one, that's fine. And storage location, you can choose. That's already we know what exactly it is. And schedule options, you can see daily backup, so daily snapshot, hourly and weekly. Daily means you can select Monday to Sunday to next Saturday, any day. Like can you select daily and go to the next option? Yeah. So daily, what time the snapshot should happen? Normally, the off hours, like when all your application users are disconnected from the application, maybe some 10 p.m. or something. If it depends on your application, all right, you can choose anything. This timing also actually it should be based on the organization policy, what time it should take the backup. And there is one more button, auto delete snapshot after 14 days. See, if we set up a daily snapshot, like after 6 months you will be having plenty of snapshot, right? That may not be required, because as per your organization policy, last 30 days backup only you need to keep, or maybe last 90 days, depends on your depends on the criticality of your application. There will be some policies, so you can follow that. And you can't really manually delete all the older backup, right? Instead of doing that, you can set up the time, like maybe 30 days or 10 days or 90 days. So the very old backups will be deleted, so only last 30 days backup will be kept. So that way also you are good, like it won't consume too much of storage, and we don't need to keep too old backup also, because it doesn't make sense. You doesn't make sense, right? Every day your data will be changing, no matter what, like application will be writing the data, so every day it will be updating. So very old backups are not required. Okay, so next, deletion rule, keep snapshot. Or okay, there is one more button, it's not very relevant. When you delete the source disk, what needs to be done, whether to keep snapshot or delete snapshot older than 30 days, that's not very important option. So if you select 30 days, last 30 days backup will be there. For in our case, you can make it some 1 week, some 7 days or 5 days. That will be fine. So you can monitor every day this is happening. All right, 5 days will be fine. Otherwise, 30 snapshots will be there in your console. You can create it. So we are taking, okay, before creating, just scroll it up a little bit. Daily, can you switch that daily to some other option? See, weekly, if you select weekly, and weekly, every week, some day in a week, either Saturday or Sunday, whatever the day, you can select, you can take the backup. Otherwise, you can go to hourly option. Hourly. So every repeat every 5 hour or 8 hour or something like that, you can set it up. Not every 1 hour. It's up to you. That way also you can set it up. So in our case, we can go with daily backup. See, we created a schedule, but that's not enough. We need to attach right now. We need to bind this schedule to your disks. Go to disks, left side. See on the extreme right side, you can see snapshot schedule, none. Okay, nothing is, no schedules are attached, which means, see, we just created a schedule. Okay, the time and everything is set up, but we didn't really select the disk, right? Which disk need to be backed up. You can have multiple schedule also, like one daily backup, and for the critical application, maybe hourly backup every 8 hour or every 4 hour. You can set it up the backup. You can create multiple schedule like that, and you can attach right disk, like if there is any critical application server that you can attach to maybe hourly schedule, some non-critical you can make it in daily schedule, and some which is not at all used kind of server, weekly you can put it. So what you can do is you can create the schedule there, come back here, go inside any disk, like a data disk or whatever, just to select, go inside more. No, yeah, edit. Yeah, right side there are three dots, right? Right side top there are three dots. No, not that one. Yeah, here, edit schedule. You can drop down. You can see your snapshot schedule which is created. So if there is more than one schedule, that also will be visible. You can attach according to the type of disk. Save it. Disk listing, just come back. Yeah, refresh the screen. There is a button, refresh button next to create disk. Yeah, now your snapshot schedule is ready. Any questions? So we took a manual snapshot, and one we set up the schedule also. So according to the time, it will be taken. The snapshot will be taken. So tomorrow, if you check almost same time, there will be a snapshot, automated snapshot. Recover using snapshot. You can, or you can create a new VM using snapshot. See, how do you recover? See, you are taking snapshot. How do you recover the snapshot? By creating a new VM. And we also learned snapshot is global, right? Snapshot scope is global, which means using snapshot, you can recreate VM anywhere in the any region. I can say any region. So okay, just go to VM instance. I'll make it more clear. VM instances, and where is the location of this VM instance, which is US Central 1C. And when we were trying to recreate using disks, it was not possible, right? We tried this Europe option, but your disks were not visible. Remember? Right? Like we tried, right, last time. So now snapshot is global, not like disk. Disks are zonal, but snapshots are global. So just to give a quick try, go to create instance. And this task, like all of you need to try from snapshot. You can create anywhere. See, you can select some region instead of US. You can select some Europe location somewhere. Any place is fine. Yes. And go to boot disk. Change. Go to existing. Which one will you select here? So we are planning to create from snapshot.
So snapshot tab.
There is a tab. Yeah, here itself. Go to change. No, hold on. Change, boot disk change. So there is a tab, snapshot. Drop down. Which one will you select? Boot disk.
Boot disk.
So did you get the idea here? See, we took manual snapshot, 2 manual snapshot we took, right? That snapshot is visible no matter which location you choose. See, your original VM is in US Central 1, and snapshot we took, snapshot is global. So everywhere, no matter which location you choose. See, here you chose Belgium, right? If you choose any Singapore or Japan, some like Tokyo or anywhere, this snapshot will be visible, which means if you have a VM in one location and you need a copy of that VM, like you need to clone that VM or copy that, you want similar VM with same application, same data somewhere else, you can take a snapshot and recreate it without disturbing your original VM. Like, it's not only for backup purpose, we can use it for such requirement. You can completely clone your VM. You'll get the exact copy. Okay, just select it. Select this. Go to, we have one more disk, right? Just to scroll down. You can allow HTTP traffic. Click on allow HTTP traffic. There is a button, networking disks. So anybody got confusion? What are we doing? See, we are recreating using snapshot, recreating the VM using snapshot. So disks, you can go to disks. Add new disk. Okay, let's not change the name and all. Just go to disk source type. There is a button, disk source type. Drop down that snapshot. Select snapshot here. So instead of creating a blank disk, earlier we created blank disk, but instead of doing that, select snapshot. Drop down source snapshot, and here it is, data disk, right? Not the boot. Which one did you select under? Yeah, data disk. Yeah, save it. If it is confused, you can ask. Okay, if you are not getting what is happening, scroll it up and make sure you selected the right boot disk, because I am confused. Okay, snapshot boot disk only. That's right. Now you can create it. So using snapshot on a totally different location, we created a VM. So it's the exact VM of what that web server knew. It's a similar instance one, right? You can log into that instance one. SSH there is button. So df space -h. So there is a data disk. See in this today, like in this creation, the data disk properly mounted. If you from bottom, the third line, right, /data, because we made the entry properly. So after recreating also, it is here. So you can do cd to /data ls, right. So your file 1, file 2, file 3, the files we created, that is still here. After recreating, it's totally, say, look at the idea here. Your original VM is in US Central 1, and you created a clone or created using snapshot in totally different location, which is Belgium. Okay, but there also your data is visible. The copy of your data application, everything is there. That's the idea. Like everything is very easy, like to create, copy, cloning, everything is pretty easy. So now about pricing. So how the pricing concept works, and it is pricing is very depends on the service, right? When it comes to IAM, it is totally free. IAM was free, and storage, when we discussed about cloud storage, that is based on total data you save it in object storage. But when it comes to compute engine, it is different. There are three areas where pricing get impact. One is resource. You need to pay for the number of CPU, RAM, graphical processing unit, network card, all these, whatever you use there. Image, like image means which operating system you use, Red Hat Linux or CentOS, Windows. Based on all these, the pricing varies. Total number of CPU, RAM, GPU, and so on. So for that you have to pay. That is resource. For resource you need to pay. Next stop, storage. Depends on how many disks you add, either local disk or persistent disk, and what is the size of that disk. And again, when it comes to persistent disk also, SSD is more costly, and a balanced persistent disk, that's also based on all these criteria you need to pay. Okay. Third payment is based on network cost. Network cost means whatever, like your users are accessing your application, and you are downloading and you are accessing some external sources. Your VM is connecting to another VM for other purpose, data copying and many things. For all these things, network cost is there. Like there are number of packets which comes into your VM and number of packets which go out from your VM. For all these things, you need to pay. In this network cost, ingress traffic is free. Ingress means incoming traffic to a VM. Like if you think from VM perspective, whatever the traffic which is coming from all external source, which is coming inside to the VM, that is free. And if VM is communicating to another VM or some other network, your VM, right, or the web server, that is communicating to other, like, which means the traffic is generating from your VM and going out from your network. In that case, egress, that traffic is called egress. Anyway, that part we are going to discuss in detail, ingress and egress and all. But as of now, incoming and outgoing, you can say ingress and egress, like incoming and outgoing, that you can say. Egress is chargeable. Okay, so whatever the traffic which is going out from your VM, that is chargeable. Outgoing is chargeable, incoming is free. So, that concept. So these are the three costs involved along with your compute engine. First is resource, which means whatever the physical resources you are using, then storage, type of disk you are using, and network cost. And there also, when it comes to resource cost, first 1 minute will be built. After 1 minute, every second you will be paying. Second level you need to pay it. Like every second, after 1 minute, every second, which means if you use a VM 3 weeks, 4 days, then maybe some total 25 days, and 10 hours, 25 minutes, 30 seconds. That level, second level, as soon as you delete it, that second level billing stops. That is called per second billing. And there are discounts. Sustained use discount is there. Sustained use discount, which means if you are you created a VM and you are continuously using for few months, like next 6 months you are using. So the first month you will be billed some amount, and the next month little less, some sustained use discount will be added. Google will be automatically added this discount, like you don't need to avail this discount. Automatically you will get the discount because you're continuously using it. All right, so some amount will be reduced, like compared to the first month, next month will be little less, like that. Some up to some 20% or something, you will get the sustained use discount. For this you don't have to do anything. Next is committed use discount. Committed use discount means, see, before creating VM itself, if you are very sure you're going to use next 2 year or 3 year, you can commit that to Google that I'm going to use this VM for next 2 years. So from the very first month in billing, it will be reflected. The total amount will be reflected. You will have a, it's like some flat discount in the bill from the day one. All right, that is committed use discount. Sustained and committed. So from the name itself, you can figure it out. Sustained, if you are continuously using it, Google will be automatically added some discount. Committed, you have to commit it initially itself. But the discount, total percentage of discount and all, there is no specific value. Like it depends on your machine type, it varies. Preemptible VM get up to 80% discount. Preemptible, we discussed what is preemptible VM. So that will get 80%, up to 80%. So you can see the total amount, there is a significant difference. So when it comes to network pricing, ingress is free, and the egress, it varies, depends on the location. So we don't need to worry much about it. Depends on the location per GPNR, there are slight difference. So this we already did, created snapshot. We created the snapshot schedule and restored it. That's not a. So here, if you look at that yellow color font, that is your project ID. See, robotic so and so. That's your project ID basically. If this yellow color font is not showing, you may need to authenticate to your project. You need to switch to your project by running the command which is right top of that. Gcloud config set project. There is a command, right? By running that command with the project ID, your own project ID, you can switch to your project. So if this yellow color prompt is not coming, you need to make sure that's happening. And the command which I'm going to run, that's already there. So you can run something like gcloud compute instances list,
Compute.
space instances space list. Authorize. We already did command line activity under storage. So here, see, there is a command we ran gcloud compute instances list. So we can see the list of instances, web server new instance, on whatever the instance details we will be able to see. And instead of gcloud compute instances list, you can run gcloud compute disks list, DASKS. Same command, up arrow. If you press up arrow, the yeah, only you can replace instances with disks. Now you need to do only backspace. Just come, yeah. You can type disks. Right. So you can view all the content, something like this. And we will quickly create a VM from command line with the minimal option. The command is gcloud compute. Wait a minute. instances, create my-vm.
What was the
Create after
create?
instances, create space. You can provide any like my-vm, my VM. Yeah, that's fine. Try. So did you mean a zone US central one? Either you can choose yes, or if you choose no, all the zones will be displayed and you can choose from there. You can provide yes here. All right, it's quickly created. See, my VM, US central one, IP address, both IP addresses are also visible. If you want, you can double check. You can go to the previous tab, Google Cloud Console, and double check it. You can close this, not authorized, reject. Yeah, close this window from, refresh the screen. There are three dots. No, not that. Yeah, there. Refresh. So using a simple command, we have created one VM. My VM got created. So I'm repeating, whatever you're doing in console, the same thing you can do it using command line as well. So this is a news from 2014. Flipkart apologies to customer for mega sale glitches. If you notice the news, they have announced a big billion day sale, and site was not working. There was a lot of network issue on the Flipkart website, and they couldn't. That's because of the big billions day sale. A lot of users logged into the website at the same time, and the background infrastructure were not able to handle the traffic. So here you can see, and later they've sent an apology mail to everyone. This incident I personally remember, that's why I kept it here, because at that point of time I was also trying to log into the site and it was not working. Later I also personally got a mail. So this topic is very much relevant to the I mean, this news is very much relevant to the topic we are discussing today, which is load balancing. High performance scalable load balancer on Google Cloud Platform, cloud load balancing. So if you notice here, so in the last session, or we have spent some couple of days for compute engine, right? The details of compute engine. So we have created, in last lab, we have created one compute engine, single compute engine, and we hosted a website there, and we were accessing that website. Now we are moving to the next level. What if this compute engine, this is down, or for some reason if this is not working? All right, like we have a single compute engine, right? One instance it is running. There are a lot of possibilities that instance is crashed, or it's not working, it's down, or multiple reason. If this is down, definitely the users also will get affected, right? That your website won't be working. All right, now we are talking about high availability. Even in that case also, your website should be working. So if you deal with, we are like right now, um, there are a lot of website, right? Like this Flipkart, Amazon, or OTT platforms. So all these things, just because it's not really depend on one server in the backend, because a lot of users, we can't really imagine the level of traffic that those websites are handling from entire globe, right? It's still working without much issues. Like we hardly find some issues in these kind of website. How exactly this is happening? So definitely one server is not really handling the traffic. You need more servers in the backend in this case, right? More servers should be there to handle the traffic. Not only to handle the traffic, if one or two, like if few servers are down also, it should not affect your website. Our website should be always 24/7. It should be always accessible. Otherwise, affect the business, right? How this can be done. This is our topic. Technically, this is our topic, like how to provide high availability and also load balancing. When I say load balancing, when more users at a time, see, if you take OTT websites, on weekend the traffic will be more. From maybe from Friday to Monday, definitely the traffic will be more to the OTT platform. So in such situation, how to handle the traffic? All these are our today's discussion. So cloud load balancing, high performance, scalable load balancing on Google Cloud Platform. A load balancer distribute user traffic across multiple instances of your application. So you can have multiple compute engine in the backend. A load balancer is responsible to distribute the user traffic across multiple instances. By spreading the load balancing reduce the risk of your application become overburdened, slow, or non-functional. So it reduces the risk of all these load balancer. All right, overburden means due to a lot of traffics, like your application is struggling to handle that one, slow or non-functional. So here is the diagram, or before coming into this diagram, so how load balancer works. So in our previous lab, there were only one compute engine in the backend, and we can have more compute engine here. So how exactly it works? So when one user access, okay, just one user access. Okay, when user number one, when they access, it will hit on one compute engine. All right. The next user access, just imagine I am accessing the website, it will hit on one compute engine. When the next user, one of you access the website, it will hit on the second compute engine. All these are similar instances which is providing the same traffic, like same website, similar instances. When the second user access, it will hit on the second compute engine, and so on. You can, depends on your website, you can have any number of compute engines in the backend, and so on. It will so it distribute the traffic here, so that one VM won't get that much loaded. All right, and so on. Like different user, every user's traffic will be diverted to different compute engine. And so as of now, we have 3 in the backend, right? What if the 4th user comes? Again, it will divert to any one of this round robin. Maybe it start from here. Like this, it will 1, 2, 3, and so on. It will distribute the traffic by spreading the load. So if you come to this diagram, it is little more detailed diagram. That's a very basic way of load balancing. Load balancing is not really a new concept. Also, it's not really a cloud concept. It's there in different level before cloud, also in the network level or the hardware level, operating like some using some proxies. Multiple way the load balancing was already there, but this is in cloud. It is more interesting, and it's global load balancing because of the privileges of cloud. You can have a global load balancing with more additional features. So if you notice Google Cloud load balancing, there will be a front end. This is the load balancer here, load balancing. So here you can see configure front end any guest IP. This is an HTTP load balancer for website or public website. You can use it. So here there are different part of the world users are accessing, and in the back end you can see US Central region, there is group of servers, and Asia also group of servers are placed in Asia, 2 different location, and users are also accessing from 2 different location. So as I said, in Google load balancer, more advanced features are there, right? Here load balancing, this is the place load balancer is kept. When you create a load balancer, you will get a single IP address. You don't need to depend on the VM IP addresses when it comes to load balancing. You need to depend on a single IP address. So when a user from US access your load balancer, it will hit on your IP, and that traffic will be diverted to the nearby region, which is US Central one, which is available here. So it will divert to the nearby region. Same way a user from Singapore access, so that traffic will be diverted to the Asia region, which means you can have group of instances in the backend. It's not individual instance. This is a group, okay? And this is a separate group. We will be creating, today we will be creating a group of instances in every location. So the traffic will be, if there is a traffic, when a user hit in the load balancer IP address, depends on the user's location, load balancer divert the traffic to the nearby location. That's how load balancing works. There will be single IP and there will be different group of, you can have one more group on Europe as well if your application demand. So far so good. Based on the user's location, it will divert the traffic to the nearby group of servers. Okay, I'm repeating, this is a group. Okay, we're going to discuss what it is. What is that group? Now, for some reason, Asia region is not accessible. Okay, for some reason, Asia region is not accessible for maybe a network issue or a serious network issue. Just imagine. So a user from Singapore, user is totally end user. You can see like a Amazon or Netflix user is something totally end user, right? So here total region is not accessible. So this is hitting this load balancer IP. User is hitting the load balancer IP. So if the backend is not accessible, the load balancer have a mechanism that always it will be checking the backend. If backend is not accessible, it will be reported. The load balancer will be aware about it. There is a mechanism that also we will discuss later. So it will be your load balancer is aware that the Asia region is not accessible. So when a user from Asia region access the IP, this traffic also divert to the US region. Traffic will be divert to the US region. That's how it makes sure the high availability. So it doesn't matter one or two server or the entire group itself, if it is not accessible, the traffic will be handled. It will be automatically. You don't need any manual intervention there to divert it. It will automatically divert to the US region. That is the second. See, first, it is spreading the load based on the user's location. That is first thing. Second thing, high availability. It will divert the traffic. The third feature. So in this case, so here imagine Asia traffic is also diverted to US region. In that case, what will happen? In US region, the traffic will be more, right? Like Asia users are also accessing, US users are also accessing. So initially you will be creating the number of, I said it's group, right? You will be keeping the number of based on the US traffic only. We don't need, we don't really keep a lot, right? So in that case, if every user traffic is diverting to US region, there is a chance that this won't be able to handle the traffic. It's possible, right? Logically, it's possible. At that point of time, what will happen is, so just imagine these are the group of server and every user traffic is coming to this particular group. At that point of time, another feature get invoked, which is auto scaling. All right, auto scaling, which means automatically it will add more instances in the group. More instances. If the user traffic increase and the existing VMs are not really able to handle, it will add more instances in the group automatically. That too. All right, that is auto scaling. So here more instances will be added. So these are the main features of load balancing. This is how it works. This is how we can design the load balancer. So main things are, main points are, the load balancer is something, it spread the load, distribute the load across multiple instances. Second thing is high availability. Third is auto scaling. It is a single anycast IP, distribute your load on multiple instances located in single or multiple region. Okay, there is a concept anycast IP. Anycast. Here you can see anycast. When you create a load balancer, you will get a single IP address, one IP address. And in the backend, see, we already know every compute engine got an IP address, right? So we don't really depend on those IP address. Instead of that, a stable single IP address we will be depending on. So that is called anycast IP. Anycast IP is something I don't know how many of you are aware about IP addresses. We are going to discuss under networking, the next topic. But generally, I think everybody will be remembering, right? Everybody will be knowing it, right? So I'm not getting into that. If anyone doesn't know, you can ask. So Anycast IP. So Anycast IP is something, an IP which receive the traffic and divert the traffic to other IP addresses. All right, that's called anycast IP. It is casting, like you know, right? Unicast, broadcast, all these the word casting, right? Which means it is distributing. All right, so it is receiving the traffic from users and it is distributing to other IP addresses. Normally that won't happen. Like in our previous lab, there was IP address, right? We just external IP address. We just hit the IP address. It is directly hitting the VM itself. But here it is hitting your IP address, that traffic is diverting to other IP addresses. That's called anycast IP. So that is an important term. So it receives the traffic and divert to other regions. Software defined load balancing, including health check. So when I say software defined load balancing, as I said before, cloud or now also, there are many levels load balancing is happening. There are hardware level load balancer also, like switches, routers and all. You can configure some kind of load balancers in the data centers. So this is a software, completely software defined load balancer, including health check. I said, right, there is a mechanism to check the backend is working or not. That is called health checkups. Okay, here health check mechanism, which will, while creating, I'll explain how that works. Automatic multi-region failover, with generally moving traffic from fractions if backend become unhealthy. As I said, automatic multi-region. If one region is failed, it will automatically fail over to the other region, gently move the traffic. It's about 1 million queries per second with the consistent high performance and low latency. LB can set up with auto scaling to build high available application, practically zero downtime. So just if we come back and look at the diagram again, imagine there is one more region which is in Europe. Like you have a global website where different part of the globe people are accessing your website. So Europe also there is a group of servers. So in this case, what are the chances of your application is going down? Just can someone say what are the chances your application is totally down? That chances are almost zero. That's what it say, practically zero downtime. So look at this. See, if there is a single VM or something is down, that will be taken care in the group itself. Like that we are going to discuss. Okay, see here. This is a group, right? Just imagine only US Central one group. So in this case, imagine total 6 are running. If there is an issue in one compute engine, what this group does is it will delete that compute engine and create a new one, a fresh one, if there is a group. That is auto healing. That's called auto healing. So it will be taken care in the group itself. If one VM and all it's down, it will be taken care in the group itself. And if the entire region is down, we already know the traffic will be diverted to the other region. And since if other region is heavy, like if it is facing heavy traffic, it will auto scale. So even in this diagram, the chances of application is going down is entire Asia region should go down and entire US region also should go down. In that case only your website will stop working, and that chances are less. And if Europe region is also there, then again your high availability is pretty much high. There's a reason, like these days, even though a lot of see compared to 2000, that's why I specifically showed the 2014 news. Compared to 2014 for e-commerce website and OTT platforms and all, number of users will be maybe at 10 or 100 times extra, right? But still we don't face much network issue compared to 10 years back or something. We don't really face a network issue in very huge websites where it's handle a lot of traffic. What different protocols, HTTP, SSL, TCP protocols. It supports CDN. CDN we will discuss separately. When it comes to types of load balancer, there are external, internal, regional, and global load balancer. So external load balancer is something. If your users are reaching your application from internet. The whatever the examples I said, right? The OTT platforms and all the users are end users, like users like us, right? We are connecting from the public internet. In that case, we need a external load balancer. If your application is open to internet, we need an external load balancer. Internal load balancer, when your clients are in within Google Cloud, which means within Google Cloud network, uh, you have an organization and there is an application which use internally within your users, which means an application where in your office your employees only will use that application. In that case, internal load balancing will be fine. Then regional and global, if your backend is in single region. And if we go back to the diagram, see here backends are in two different regions, right? US central one and Asia, two different region it's there. So this is a global external plus global load balancer. It's an external because users are from external network, and the backend is multi-region. Multi-region means always global. Regional and global. Okay, if the users are from across the globe, it is global load balancer. Regional, if it is single region, if your users are in single region, that is regional load balancer. So this is not for different types. It can be an external regional load balancer, combination of 1 and 3, external plus regional. If your users are from internet and if your backend is in single region, it can be external global. And if your backends are in more than one region, it is external global load balancer. And internal regional load balancer, it can be, see this, it can be divided something like this. See, external, internal, external. When it comes to external, global and regional both are possible. When it comes to internal, only regional load balancer is possible. Internal, global won't be possible. Okay, if it is internal load balancer, only regional. Here, if you remember the basics, networking basics, this is OSI layer, maybe you might have learned in college and all. So in different protocol works in different layer, HTTP, SSL, TCP network. Always when you choose a load balancer, these are the different load balancer available: HTTP load balancer, SSL, TCP, and network load balancer. The thumb rule is always try to create a higher layer as possible. Try to go for HTTP load balancer. That's the most popular load balancer. So global or regional, how to choose the load balancer. Next question is how to choose the load balancer, global or regional. If your users are from different part of the world, you can go for global. If your users are limited to one country or something, you can go for regional. For example, like okay, you are creating an e-commerce website for a country, Singapore. It's a small country, right? So the users are from Singapore only. So in that case, you can host your servers in the Singapore location. That will be sufficient. But if your users are from some Europe and US, in that case, you need multi-regional load balancer. Regional, if your backends are in one region, it's about IPv6 and IPv4. If you're not really aware, you can ignore it. External or internal depends on users. Your end users are from internet, external, internal if your users are from your organization. These are the supported protocols. External support all these: HTTP, SSL, TCP. Internal, it support TCP plus HTTP. So this is a detailed diagram of load balancer, like how in real time we can design a load balancer. It got external plus internal load balancer. So just imagine a very complex application where some multi-layer application. You have a web layer, database layer, or application layer. In a large application, there will be multiple layers. So here it's a combination of external plus internal load balancer. See here, users are accessing from US plus Asia. There will be an external load balancer in the front end. On the web layer, mostly the external load balancer will be in the front end of a web layer, website, right? That's where we directly hit. So here you can see external load balancer. There is a web layer, a lot of group of websites, web servers are there. It's hitting. See this black line you can see. User from San Francisco, it's hitting here. And regional, US central one. In regional level, there is internal load balancer for the database, basically database. Because database level also load balancing is important. There will be a lot of database servers. See, if you notice a e-commerce website, see here, when you hit a e-commerce website, right now I'm hitting in the web server. I'm getting a web page open, right? Web server. And if I open a product, I'm just opening a product. Okay, if I open a product, these contents are coming from a possibly, like, not always mandatory, these contents are coming from a database. Okay, so when I open first time, it is hitting the web server. See all these details and all, it is grabbing from a database. And these pictures will be coming from some storage like Google Cloud, GCS kind of storage possibly. So something like this. See all this content about the details, entire details about the product is coming from a database. So here, if you compare the same, when you're accessing first time, it is hitting the web servers, the first page. And if you went into details, if you go to details of your website, it will be coming from a database. So there also some load here, also database server, we can't kept it single one, right? There also there are many servers, and you can just internal load balancer for that. So this is how in real design it works. So currently in my project, we are designing this. There are 3 layers. They here two layers are here, right? See, web and a database. So here in our case, there are 3 layers: web, app, and a database. Web layer, application layer, and a database layer. Auto scaling, we already discussed the compute engine offer auto scaling to automatically add or remove VM instances from the instance group. So I said, right, if the load is increasing, the backend VMs also, number of VMs in the backend also will get increased. Auto scaling let your app gracefully handle your increasing traffic. It reduces the cost when lower number of resources are required. Automatic scaling based on predefined configuration. Auto scaling policies are based on CPU, load balancing, server capacity, etc. We'll see that. How a VM will come to know this load is increasing. So that is based on CPU, multiple criteria: CPU, load balancing, serving capacity, and monitoring metrics. We'll see that again. Works with managed instance group. What is managed instance group? This is important. Okay, this is a very important area. The concept wise, you should be very clear when you create a load balancer. What is managed instance group? I was talking already about a group, right? See here, I was talking about a group. I specifically mentioned in the backend, it's not a single VM, it's a group. This is a group, and here also it's a group. US central one, it's a group. Deploy backend, okay, it's a group. So that's called managed instance group, or it's called MIG. Let's see what it is. It's a group of identical VM. That's very important. It's a group of identical VM. See, this is a group. We can say this is a group. It's a group of identical VM. When I say identical VM, all these VMs are serving same traffic. If it is, say, if you are hitting this one, all the VMs will be serving the same home page or the same traffic. That is group of identical VM. And whatever, if one VM in the group level itself, there are some features. As I said, if in this total 6, if one is not working, that group itself will take care to delete that and create a new one. So it's all are identical, right? So it will create the new one. Support auto scaling and load balancing, high availability, health checkup, and auto healing. This also we discussed. Health checkup is the mechanism that load balancer used to check the backend is working, and auto healing is something if one is not working, the group, if one is not working, it will delete and recreate. That is auto healing. Regional coverage, protect app from zonal failure. So it's a regional coverage. When I say regional coverage, group you can create only in region. See, when you create a group, it will be regional. We discussed about scope, right? Earlier we discussed something about scope, that image, the scope of image, scope of disk, and all we discussed. Just like that, the scope of instance group is regional. All right, it is regional. See, one group you can create. See, you can't create a group which cover entire globe, like a few instances are in US. That way you can't. You need to create separate group for every region. Regional coverage, protect from zonal failure. Automatic scalability based on the predefined configuration, automatic updates of like backend operating system and all automatically it updates. We will do a lab, create a managed instance group, set up the load balancer and auto scaling, and we'll do the testing. So now you can open 3 tabs. Okay, the same tab you can open 3. So you just right click on Google Cloud Platform home button and open into a new tab. Just right click. No, the blue bar, Google Cloud Platform. Yeah, no tab, not window. One more. Okay, so here you can go to Compute Engine in the first tab.
Is it like, oh,
Yeah, here you can just switch to Compute Engine.
VMs?
Yeah, VM instances.
It's
So you
all
can
stopped. Should I go ahead and start all of these?
you can delete all these, okay, because we don't need this. And also we may face some quota related issue if we keep it, because we are going to create many instances, right, as part of this lab. You can delete it and just go to disks and check whether any additional disks are there or not.
So should we delete all these
Okay.
ones as well?
Okay, first let the VM instances get delete, and after that remove the disk as well. Okay, this is deleted, right? Go to
Yeah.
disks and refresh your screen. That refresh button you can use. Okay, so remove these disks as well. So these are independent disks. You can zoom a bit. It will be more readable from the top browser. Yeah,
Is
fine.
it okay?
This is fine. Yeah. All right. Okay. Okay. Here you can go to VM instances and go to the next tab. Yes. Here you can. Okay. Instance groups. Go to VM instance itself, Compute Engine, VM instances itself, or instance template. The second one, second option, instance templates. All right. And the third tab, go to load balancer. Just type load balancer in the search box. Search box, type load balancer. So here, listen carefully what we are going to do. Just a click on remind me later. Remind me later, the top. Yeah. Yeah. Come to the second tab. Yeah. So here we discussed just make a note of the order. Okay, that order is very important. What are we going to do? We discussed about instance groups, right? A group of identical VM. How it is becoming an identical VM? That's because it is always referring to a template or referring to one configuration when it is creating. See, auto healing, it will delete and recreate it, and auto scaling also. Okay, auto scaling also, it will create the same VM, right? We discussed auto scaling. It will be adding more and more VMs. So where exactly it is referring? It is referring to a template, which means a configuration. A template means it's a configuration whenever it's adding a new VMs in the group. All right. So this is first in load balancer. The first thing you need to do is creating the template for the group, instance group template. we are creating. So just create instance template. So this order is very important. First, what you're doing. Second, what you're doing. That is important. So you can mention the name lb-template. lb-template. All right. Go to machine configuration. Drop down that series. Scroll down. N1. Select N1. And machine type. You can make it as small as possible because you may get some quota related issue. F1 micro. You can go with F1 micro. It's a very small machine. Okay. Come down. Boot disk DBN is fine. And keep coming down. Allow HTTP traffic under firewall. Now, networking disk security, that button. Okay. Management. So here, just come down a little. So there is a button automation. All right. There is a button automation. And there you can add a startup script, which means whenever, like just imagine you are creating a VM, and whenever a VM get created, you need to install some few group of software for your organization, some monitoring or backup or some group of software. In every VM is required. In that case, you can't really do it every time, right? Instead of that, if you mention those installation scripts in this startup, immediately after the VM creation, it automatically run. That's the purpose of startup script. And here, under load balancer, what are we going to do is we are just adding a small script which will help us to, okay, in the computer engine lab, we install the website, right? Manually, we ran the command and install the website. Here, instead of that, we are adding a script which will install the website. That's what we are going to do. So I'll just send the script. Wait a minute. The manual task which we did under Compute Engine Lab, that we are making it automatic. Just scroll it up. Yeah, everything is copied, right? Scroll it up. Okay, extreme down. Yeah. You can keep this script in a notepad as well. Just open a notepad and keep the script. All right. We'll check this later. Saving is not really required. It's there in the lab document anyway. Okay, scroll it down. Now you can create the template. The only difference what we did is we added a startup script under automation, under startup script area. That is to avoid the manual installation of website. Okay, now can you go to the first tab, VM instances? See, just as of now, we just created. You can refresh refresh once. See, nothing is there. There is no VM created. We just created a template. So far, we just created a template. You can go to the second tab. Template is just a reference point. Now, left side, scroll it down. In the middle, there is something called instance group. Scroll it up little. Yeah, there it is. Instance groups. Create instance group. Now we are creating the group, what we are talking about, instance group. Okay, LB hyphen group. You can mention LB hyphen group. Not caps. Hyphen group. Okay. So we are about to, okay, instance template, drop down instance template. Okay, this is the template we just created, LB hyphen template, right? That's visible here. We are selecting our template. Come down. So we are creating group which is in US Central 1. So remember, it is US Central 1. You can mention multiple zones. Okay, multiple zones of US Central 1. If you want, you can select customize as well. Yeah. So as per our design, say what was our design in the theory, like US Central 1 plus Asia, right? So here we are creating a single region, like regional external load balancer. So one region only we are creating, and your task today is to come back with a multi-regional load balancer so that Wednesday we can do a testing. So it is multi. So as of now, it is US Central 1. Okay. Come down. Auto scaling. See, this is important. Auto scaling. So instance group level auto scaling is happening. Auto scaling is actually happening in the instance group level, not really in the load balancer level. All right. Instance group level. Here we can make the configuration of auto scaling. So this is very important. Little tricky. You can just drop down the first one. Auto scaling on, which means it will add and remove the instance to the group, which means so add and remove, right? So when the load increase, it will add the number of VM, and when the load decrease, it will remove it. If you take the OTT platforms as example, every weekend the load will increase, right? So maybe normal Monday to Friday or Monday to Thursday and all, they just require some 100 servers to run it. In the backend, 100 VMs are required to handle the traffic. Imagine some OTT platform. And Friday, Saturday, and Sunday, they may require 150 server to handle the increasing traffic. So you can make a configuration is something like minimum always 100 should be running, and in the weekend or when the load increase up to 150 it can go. Like that, you can set up minimum and maximum number. So what will happen is from Friday it will start increasing. When the load increase, it will become 101, 102, and so on. It won't just jump into 150, okay? Just because you mentioned. Based on the increasing traffic, one by one it will add. And again, as I said, from Monday, definitely the load will reduce. So at that point of time, it will reduce from some 150 to 149 and so on, and it will come back up to 100. It won't reduce less than 100 because we are setting a minimum number. No matter load is there or not, minimum number we are setting it. So if you want that option, you can go with the first, add and remove. It will add and also remove. When the load decrease, it will remove as well. Then the second one is scale out, which means it will only add the instance. It won't remove. So from 100, if it is adding 101, 102, it won't reduce. It won't come back to 100. That is the second option. The third one is auto scaling is off. So you can set up a load balancer without auto scaling also. It's not mandatory to set up auto scaling. If you want, you can turn it off. Auto scaling won't happen, but load balancing will happen. You can go with the first option, add and remove. Let it add and remove both. All right. And you can mention the minimum and maximum number of instances. We need minimum 3 and maximum 5 you can mention. Netflix example, weekday, minimum this many are there, and maximum it can go up to 5. So we have some limitations. Since it's free trial account, we have some limitation. That's why we are reducing. We are creating less than number. That's enough for us, right? For training. This is very important. Minimum, always, no matter what kind of traffic it is, always 3 will be running. And when the load increase, it will go maximum up to 5. All right. Next. The criteria, the auto scaling criteria, it is based on CPU. We can go with the CPU, drop down that. So when the load increase, see, drop down that CPU utilization, there are multiple criteria. The CPU utilization, HTTP, load balancing utilization, based on the number of hits which is happening in load balancer, or any other monitoring metrics. Monitoring metrics we are going to learn later. Uh, as of now, CPU utilization. See, we in our laptop also, if you open a lot of applications like Word, Excel, any other application, and if you check the task manager, CPU will be increased, right? If you never noticed, you can try. You can open when your laptop. If you open a lot of applications and check your task manager, the CPU utilization, it will be increased. So CPU is one of the basic criteria. When the load increase, CPU consumption or utilization also increase. That's something very basic criteria. So we can go with the CPU utilization. Select that and make it target utilization is 90%, which means if one VM's CPU reach to 90% capacity, it will add one more VM. That's the idea here. Okay, 90%, not 100%. If it is 100%, that VM is, well, like, it will start giving trouble. So 90%, if it's reached to the capacity, you can add. So you have 3 instances, minimum 3 instances, right? In that one instance reach to 90%, so it will add one more instance. So total become 4, so that it won't affect the total your whole application. Is it clear? 90%. Concept is CPU reach to 90%. Now, it come down. There is one more concept, predictive auto scaling. We can turn it off, keep it off. It's little more advanced. As of now, it's not required. Come down. All right. Health checkup, auto healing, health checkup. Drop down that. Create a health check. Click on create a health check. LB-health. See, this is the mechanism I said. Load balancer always check the backend, whether it's really working or not. And based on that, it will consider whether to divert the traffic from Asia region to US region in our previous example. So this is a mechanism. Health checkup. You can mention protocol is 80. Protocol TCP, you can drop down and make it HTTP. First one. HTTP port number 80. So again, back to basics. HTTP is the HTTP and port number 80 is the website protocol, right? HTTP protocol is basic. Like if you hit a website, it is actually hitting in the port number 80 of the operating system, basically. So here we are going to host a website, right? We earlier also in computer engineering also we hosted a website that is in port number 80. So HTTP port number 80, and if you come down again, health criteria. This is very important. So we already know in our backend application is port number 80. We already know that. That's why I mentioned HTTP 80. If your backend application is something else, probably it's a database. In that case, the protocol will be different, and also the port number also will be different. It depends on your application. Health checkup you need to create depends on your application. If it is for a database, for a SQL database, you need to select TCP and 1433, the port number, SQL port number you need to mention. So that and all, it's too much. But you need to remember, health checkup is based on the backend application. You can't blindly select HTTP and port number 80 for all application. That's that won't work. All right, depends on your application. Scroll down. And health criteria. This is the logic here. It's a very, very basic logic. How a load balancer will come to know the backend is not working. You can check interval. You can mention 10 second. Under health criteria, there is something called check interval, 10 second. So you can have a look there. Check interval, timeout. Then healthy threshold is 2. Unhealthy threshold you can mention 2. Okay. Unhealthy you can mention 3. Okay. So here, the logic you can just check interval, which means 10 second. Every 10 second, it will send a signal to port number 80. All right, port number 80 every 10 second. All right. And if it is giving a response, so port number 80, it is sending a signal, one ping or ping response or whatever it will send. And if it is giving a response within 5 second, timeout is 5 second, right? Within, so normally if it is everything is working, it will get the response in a millisecond, not even a single second. Okay, so within milliseconds you will get the response. Then it will consider as backend is healthy. If it is sending the response, it is sending a signal and coming back, it is responding. Then for some reason, if the backend is down, it won't respond back, right? So from load balancer level, it is sending a signal to the VMs. It's not responding. So unhealthy threshold is 3. So which means every 10 second it will send the signal. 10 second, it send a signal. After 10 second again, one more time. 3 times it will send it. And if it is not getting response twice, it will consider as unhealthy. Where it will send the signal? Port number 80, top you have mentioned. If it is a database or something, the port number will be different and it will be sending to a different port number, whatever the port which is used. Very simple logic it is. It will just send a signal and wait for the response. If it is not getting the response, it will consider as unhealthy. Just because one a failure, it won't happen. Depends on your application, you can change this value. Instead of every 10 seconds, you can make it 1 minute or 5 minutes, doesn't matter. Like, how do you check like your friend is reachable or not? You will dial the phone and check it, right? If the friend is responding, that friend is reachable, or that's how the same logic. It will send a signal, it will wait for the response. Save it. That is health checkup. This logic is generally applicable in many places, not just in cloud load balancer. So health checkups, this sending a signal and waiting for the response spot load. All right. So I'm not getting into the port mapping and all. It's too complex as of now. Create it. See, we are creating the instance group. Group we are creating in US Central 1. As per our diagram, we are creating a group in US Central 1. So unlike individual instance, we are creating group. This one, if you're doing some 5 times also, it is good. Okay, so different combinations you can do many times just to create everything, test it, delete it, and create a different combination. For example, first you start with the regional load balancer, then you make it global. Like later, one more backend you can add. There's a possibility of doing different combination here. If you do it multiple times, you will get more insights. Like some specific some small points and all I skipped, purposefully skipped. You can read that area, what exactly it is. All these are additional. Once you create the load balancer, once you're clear with the concept, you will understand what is that additional options also. So you do it multiple times. This is very important. Once, like some 4 years back and all. So we created a group. To confirm this, can you go back to the previous screen? VM instances. Refresh. See, 3 VMs got created, 3 virtual machines got created. So the name and all, it's based on LB group, so and so naming. And it's part of, you can see in use by LB group. You can see, and every VM got an internal plus external IP addresses. All right, now let's do a small testing now. First VM name is ending with 7VCQ, right? 7VCQ. Just click on external IP address. Click, just simply click. And here, can you zoom it? Yeah. Here you can see load balancer lab. This is the expected output. Load balancer lab, Google Cloud Platform. Server name is 7VCQ. Can you open on that second VM? Second VM name is BCMN, right? BCMN. If you click, the other one. So if you click the second VM IP address, it is opening. It is showing that name. Can someone say how this is happening? It is showing the name of that server. So what this script does is it is installing Apache 2. It's the same thing what we did under Compute Engine. We installed HTTPD, right? The same thing, and it is switching to the var www HTML, that particular file that we did it manually, and it is adding some content. Load balancer lab. We just added welcome to GCP, something like that. Then server name is and it is running a command called hostname and adding the output there, hostname command, which means the script is running in the VM level, right? It is not running in load balancer level or whatever. It is running while VM creation. So what will happen is it will pick the VM name from the server name itself, like where after booting only it is running the script. Once the system is up and running, then only this script will start running. Okay, once the OS is up and running, so it will pick the that name of the VM and it will add it in var www index.html. If you want, you can double check it. Where you can just open one VM and just do an SSH to one VM. And if you open var www that particular file, you can see how this content is actually coming, like every VM's names, how it is displaying. If you open each IP address, if you open, you can do SSH. So this is just for our testing. Okay, we created a website, and it's also that website is showing the right VM name. I mean, whenever you click each IP address, it is you can do a cat. You can open the file cat command space /var, that path in the var www /www /html is the default path of every website /index.html. Enter. So here you can see this is the content is getting displayed there. Load balancer lab, Google Cloud Platform, and server name is LB group 7C. You can see the green color, right? That's the same VM name it's showing. So it is picking that VM name and adding into this particular file. So when we click on IP address, this file only getting displayed there. All right, this is how its logic works. Minimize this one, minimize. Okay. So what all we did so far? First, we created instance template. Now, then using that template, we created the group. Okay, so as of now, only backend we created. So far, only backend we created. Backend, we are talking about load balancer backends now, which is instance group. First one is instance group that we already know how that works, managed instance group. Second one is zonal network endpoint group. Okay, and internet network endpoint group, serverless NEGs. So let's see what is zonal network endpoint group. Okay, it is called NEGs. NEGs. Okay, that is what it's called, NEGs. So here, so we discussed about instance group, and instance group is a group of similar instances, right? And it got its own properties like auto scaling. If you delete one, it will recreate it. and so, just like that, there are multiple properties. But instead of that, you can have a load balancer in front of two independent VMs. Okay, see, it's not a group or NEG or what. I mean, it's not a managed instance group. Like here, when we create an instance group, it got created. Like we created instance group, but VM got created in the other side, right? Whatever the number you mentioned, that got created other side. But here, zonal network endpoint group, these are two independent VM. You can create VM. You can go to compute engine, create one VM, and then you can create next VM, and you can place a load balancer in front of that. Okay, you can create a load balancer in front of that and use it. That is called zonal network endpoint group, or NEG, network endpoint group. So these are individual VMs, and you can use it just like this. All right. So whatever the traffic, whoever access, it will hit on load balancer, and the traffic will go to one VM, and then next traffic will go to other VM. And just like two, you can have more than two also. Two or more VMs you can have in backend. So what all it doesn't have? It doesn't have the auto scaling option, and like that, there are many other options you won't be having. Like auto scaling option, you won't be having. That is the major difference. These are individual VMs, and it works accordingly. Similar instance, mostly similar instance, and it will hit one by one. This is so what you are achieving here. Like if one VM go down, it won't affect your total application. Auto scaling won't be there, but it just work normally without auto scaling, and high availability will be there. That's zonal network endpoint group, and everything. This two compute engine should be in the same zone. Not that's the condition. So these are not very popular one, but still it will use specifically during the migration and all, because when you in from the existing environment, if you're migrating something to cloud, every application may not support instance group. At this point of time, you can use zonal, and also know everywhere your application may not be that critical to auto scale and all. That much load and all won't be there. There will be application with consistent load, so you can keep it one or two instances, stable instances, and have a load balancer in front of that. That is zonal network endpoint group. Next one is internet network endpoint groups. So here in internet network endpoint group, the point is these two are not compute engine, not really compute. What is compute engine? If a VM virtual machines, which is in Google Cloud, that is compute engine instances, right? You can have a load balancer in Google Cloud, and also you can have the virtual machine in your on premises. You can have your servers in total on premises. On-premise means normal data center, your private cloud or some data center which is belongs to your organization. There you can have it. Load balancer in Google Cloud, and the backend is in your data center. Like this, you can configure with the other option, internet network endpoint group. There is no difference. Load balancer will be here, and here will be your on-premises. There should be connectivity, proper private connectivity should be there, so that whatever the traffic which comes to load balancer IP address, it will divert to the on-premises. That is internet network endpoint group. Then serverless NEGs. These topics we are going to learn second half of our training. So I'm just holding this. What is serverless NEG? Serverless network endpoint groups basically, and you can have a load balancer, and with the backend of App Engine, Cloud Run, and Cloud Functions. What is these three topics you will learn later. And the last backend is GCS bucket. We already know what is GCS bucket, right? So GCS bucket also you can have it as a backend. So just now in Jyoti's system, when we were trying, it is asking for a path, right? Specifically, it is asking for a path. If you are adding a different backend, you need to specify the specific path also. Why GCS buckets? Because you can't have GCS bucket, only GCS bucket as backend. Okay, just 2-3 buckets and have a load balancer. That is not possible. In an application, sometime your data or some images, videos, and all will be coming from GCS buckets. Possibilities it will be coming from GCS bucket. So only if in that case you can add GCS bucket along with the instance group or serverless NEGs or zonal network endpoint. If your application really using the bucket, you can have that bucket also added. For example, you see you have an e-commerce website, something like this, and you are opening a product. This images may be coming from a bucket. See this image, right? The details of this image, the full details, this will be coming from a bucket, possibly. Like I can't confirm, but sometime it will be coming from backend. Or if you have a website with a lot of videos in it, that video may be streaming from your GCS bucket as per your application configuration. So that way you can add a GCS bucket also in front of load balancer. And you need to specify the path here, like whatever the host path and roles we have seen, right? So I asked you to mention slash. So just like that, slash and additional some specific path you can mention. See here, something like this you can mention. It totally depends on your application, how you're configuring it. So the idea is sometime and for some application, some specific areas will be coming from back GCS bucket. That also you can add it in backend. Anyway, that's just be aware about it. And no, it's not a big, like, no need to. If you're a little confused, also okay, because if you really do that only, you will get to know how exactly that works. And the very important thing is instance group. Network endpoint group, this also you can give a try. Like you can have a network endpoint group as backend instead of instance group. This also you can give it a try in lab your own. So all of you are free to do it. How to do this is you will get the documentation. So still I can tell 2 VMs you can create. Compute engine, you can use compute engine lab or that documentation. So you 2 individual VMs you can create, and when you're creating the website, you can you can just mention we just use some script, right, to create the website. So welcome to GCP. In that you can mention 2 different messages basically. So you can create 2 individual VMs and then go to zonal network endpoint group. And create a network endpoint group. Then you can create the load balancer. So give it a try. That also is like after instance group, you may end up on using it. See here, somewhere here, you will get the CZ network endpoint groups. So you create 2 individual VMs and add it into a group, and then you can use it. Create a network endpoint group, add both the VMs here. Then this can be used as your backend while creating load balance. All right, that's about different types of backend instance group. Not only instance group, there are many types. So here also, this also you can try once we cover this topic. After once we cover this app engine, cloud run, these topics, you can give it a try. And the last topic is unmanaged instance groups. Unmanaged instance group. So in this case, so managed instance group, what is that word called managed? Managed means when the auto scaling, like when the load increase, it will automatically increase, add the number of instances, right? That's why it's called managed. It will manage by itself. That's the idea there, right? Here, unmanaged instance group. Unmanaged instance group, you can have identical or non-identical instances. UMIG, it's called UMIG. It's the backend may be either identical or non-identical instances. That is the difference. You can anytime you can add or remove the instances. It do not support auto scaling, auto healing, scalability, or high availability. It do not support that. You can only use load balancer in heterogeneous instances. If you want to use the load balancer in heterogeneous means different VMs in the backend, not exactly the identical instance. If you want to use, you can use UMIG. It is just like zonal network endpoint group only. Like you can create a create individual instances, and you can create UMIG that while creating instance group, you have different options. See, this is zonal network endpoint group, right? See, instance group, when you're creating, you will get unmanaged instance group option. See, these two are managed instance group. Here is the unmanaged instance group option. All right. So this is again heterogeneous instances if you want to use it. So here you can add the VM. You can select the network, and here you can add the VMs. So identical and non-identical instances you can use in the backend. Next, we have two more topics. That is CDN and DNS. Let me explain for others. CDN. See, we have load balancer, okay, and here we have instance group. Just imagine we have, okay, we'll keep the load balancer also aside. All right. So let's take a real-time example. We'll take the case of YouTube. Okay, YouTube, and just imagine we all are located in India, right? Different parts of India maybe, and will okay. So someone is accessing a YouTube content from Bangalore. Just imagine from Bangalore, someone is accessing a YouTube content, and that content is something just recently uploaded, like very new, maybe a very new movie trailer or something that is just recently uploaded. So when that user access the YouTube content, that specific, only I'm talking only about that URL, okay, only that content. In normal case, that will go reach to the original server. Maybe the YouTube server is located in US, so it will reach the original server, and you will get the content back, right? To that particular, that will be streaming from the original server, which is located in US. So so that movie trailer is very popular. Many users are accessing almost from the same location, maybe from Bangalore or nearby Bangalore or some nearby locations in India. Too many users are continuously accessing that content. Imagine, so possible, right? A new movie trailer, the possibility is more. Many you will be watching in short period of time. So many are watching from here. All right, from the same location. Location is also important. Like if someone is accessing maybe from Australia, that this logic is not applicable. Almost from the same location, many users are accessing same URL also. In that case, what will happen is, so in normal case, it is supposed to stream from the original server. But if CDN is enabled, okay, if CDN is enabled, what will happen is Google got a lot of edge locations. If you remember edge location, initial sessions we discussed, right? Region, zone, and edge location. See here, network, and here you can see cloud, CDN, point of presence. Edge locations, we already know which is network locations. We have network locations in different, almost 146 network locations are there for connectivity, right? Okay, so there are a lot of network locations. If you notice here in India, there are 3 network locations. I mean, there are two zones, right? Two regions are there, right? One is in Mumbai and the second one is Delhi. And there is one network location also you can see, which is in Chennai. All right. And it is, if you click on CDN also, that is applicable. It is CDN location as well. So network location, we already know it is to route the traffic, divert the traffic to make this possible, like all these connectivity possible. See, all these are cables, right? Physical cables, basically, all these are. So to make it possible, network locations are there. It's called POP. You can see point of presence, POP locations. Anyway, you can forget that. So there is one more location in Chennai, that is CDN location. What will happen is, if CDN is enabled for your website, okay, it is actually getting enabled in the load balancer level. We already saw, right, while creating load balancer, there is a button called enable CDN. It is actually enabled in the load balancer level. So just in front of load balancer, along with the load balancer, it is getting enabled. All right, in front of load balancer, both works together. So the very first user, when that user is accessing, that traffic will get in hit, and definitely it will go to the original server first time. Definitely that will happen. So in the second scenario, many users are accessing from the same location. So what will happen is, that URL, that particular movie trailer or something, that will be copied to the CDN location. This CDN location here, the nearby CDN location, Chennai, right? From Bangalore, the nearby CDN location is Chennai. It will be copied to Chennai location, and whoever the user is accessing, they will get the rest of the users. Okay, I'm not saying, I just said one. Okay, for an example, maybe it's not really one. If many users are accessing, it will copy into CDN location. As soon as it's copied to the CDN location, rest whoever is accessing, they will get from CDN Chennai location itself. So their traffic won't go to the original server and return. So you will get from the nearby location, which improve your website performance. Any website you can use like this. You can enable CDN. Once you enable CDN, whoever is, the same thing will happen if someone is accessing from some Australia or Africa. It's totally different continent. If many users are continuously accessing the content will be copied to the nearby their location. All right. That's how it works. So logically, it makes sense, right? It will definitely improve your website performance. Again, it's a common concept. It's not a cloud concept again. It's generally a networking concept basically. So this cloud CDN use Google's global edge network to serve content closer to user, which accelerate your website performance, websites and applications. So it makes sense, right? The same thing, only I draw. Backend CDN backend is the backend of load balancer itself. All right. This whole logic happens based on two concepts: cache hit and cache miss. I will just explain what it is. Based on two concepts, two logic, it happens: cache hit and cache miss. Cache means it's CDN. Cache, right? Cache, buffer, all are same. So when you copy the YouTube content into CDN, that's called cache. That's called cache content, which means you're keeping the same data in buffer, basically, right? That is cache. And when a user access, initially it will go to the original location and get the content. These lines you can see, somebody is accessing, it's going to original location, getting the content and serving to the user. This process is called cache miss, because it is missing from the cache, right? In the buffer memory or in the Chennai location, it's not there. So it's going to the original location. So cache is missing there. So how this works is based on the count, based on a small algorithm, not a very complex concept. Like cache miss count is increasing in a short period of time. Just imagine cache miss content is like count is increasing. So which means many users are looking for the same content, same URL, right? This count is increasing. Then the content will be copied to cache. Once it's copied, then cache hit will happen, that this count will increase. So many users will start getting from the cache itself or from a Chennai location itself. So that count will increase. Cache hit count will increase. So as per their algorithm, if this is matching, like enough cache hit count is there, then it will keep the data. Then when this, the maybe after 2 or 3 days, the trailer, right, movie trailer, that the number of people who watch the trailer will be reduced. Then it's not really, no more it's required in cache, right? Maybe some new content will be popular in YouTube. So at that point of time, it will clear based on this cache hit count. Cache hit count, obviously it will reduce when the people stopped watching. So it will reduce. Then based on this count, it will get cleared from cache. Very simple logic. That's how it works. It's not important to know also like how it works. It's just for your information. The point is, it works with the Google Cloud Load Balancer, GCP Load Balancer, and what is the idea of a CDN? This you need to know. It's a very small topic. It's not a complex topic or something. It's a additional feature of load balancer, we can say, and it's not something new. Also, you will find it in AWS or without cloud. Also, the cloud CDN was used. Okay, before cloud also, this concept was there. Okay, many websites get accelerate based on they keep buffer or data centers, small data centers, to keep the content nearby your location. And Kundan mentioned Akamai. Akamai is the very popular company who provide CDN services. This is a very popular company who provide CDN. See if you notice here, it's an American content delivery network, cybersecurity. So before cloud also, this company was the very popular one who provides CDN, and in Google Cloud backend also, they are only providing the technology support. Like in Google Cloud CDN also, they are only actually their technology only used. Akamai. One more process about CDN: cache egress and fill. Cache egress is these dots. Okay, what is cache egress means? From cache, the content which is going to users, and cache fill means this one, this lines. The content is getting filled in cache. So dotted lines are to users. These are to cache. And one more logic here. See, if the first you're accessing some content, as per if the CDN is enabled initially, it will check in CDN location, which is in Chennai, right? And if it is not finding in Chennai location, it will check nearby cache also. It won't directly look in the original location. Instead of that, nearby cache, maybe in Mumbai or Singapore location, it will check like two CDN location. It will check. After that only, it will go to the original location. So here you can see cache. First it is checking in cache, then it will check the nearby cache also, maybe in Mumbai or Singapore. That's a nearby locations. So if it is not finding the nearby cache, then only it will go to the original location. So, and if it is finding nearby cache, just imagine it's finding in nearby cache, it will copy to the Mumbai. So you're looking in Chennai first, it's not finding, and checking in Singapore. The system is automatically checking in Singapore. If it is finding in Singapore, it will copy to Chennai. Cache to cache fill also it will happen. Cache to cache fill. Okay, this one also it will happen. And everything is like, you don't have to do anything. All you need to do is enable the CDN and do some custom settings optionally. That's all you have to do. So next is DNS. So here, see, let me connect all the missing links here. See, we are coming in an order, right? First, we created compute engine and we set up a website there. That is a single one. Then we created a high availability, all the like advanced features in terms of high availability and load balancing. All based on all these things, we have created a full-fledged website. Okay, it is like, just imagine in a real-time case, right? You need a global website where the backend is in different part of the world, and you need a load balancer. You need a single IP in the front end. So you have a load balancer. In short, you have a full-fledged website where it never go down or something like that with all the advanced features. And finally, what you have a front-end IP address, right? You have a public IP address, external IP address, which start with some 35 so and so IP address. So that's what you have it right now. And a website, when you hit that IP address, it will reach to a website. So something is missing here, right? So you're hosting a website. Technically, you're hosting a website with all the advanced features, high availability, global load balancing, maybe CDN, everything is there. But something is missing here. We access with the IP address. not with the name. See, if you open Netflix, or if you see here, Netflix is there, right? Netflix.com. We are not accessing with IP address. If you access Amazon, it is Amazon.in. We are not accessing with the IP address. It is, we are accessing with a name, right? This is called domain name. www.amazon.in. This is called domain name. How to do that? How to attach a domain name with your IP address? That is our next question. So it is the protocol. DNS is the technology or tool or protocol. It's basically a protocol, DNS, domain name system. All right, that's the tool which helps. Not really tool. It's it's more than a tool actually. It's a protocol basically. So cloud DNS is a hierarchical distributed database that store your IP address and data, allows query by name. So how, before we move to cloud DNS, how this system works is, the DNS system works is, there will be central DNS servers, maybe for your organization, or the public servers. DNS servers will be there. Dedicated servers, the separate servers will be there, where it keep only the entries, DNS entries. You need to keep it. DNS entries means which IP address and which domain names, both are binded. Like Amazon.in, right? We were talking about Amazon.in. Generally, the centralized servers will be there for this. So here, see, I'm just checking with a command nslookup. Okay. I'm just checking google.com. Okay, this is not the one. Wait. All right. So if you notice here, when I do ns lookup and google.com, and also one more website, amazon.in, and you can see the server. This is same 128.22.47.100, right? Here also it's same. And I just ran one more command, and I was filtering server. This is showing the same IP address, 125.22.47 and 100. This is a server. First, see when whatever the website you are accessing, okay, www.google.com, it will go to a DNS server, where it's a central server. It's a public. It depends on your Airtel or whichever the provider. Based on that, it will go to a DNS server. There, it will look for the addresses. So here in this server, it will hit, and it will check for www.google.com, which is the load balancer IP. I'm just simply using load balancer IP for your information, which is the actual IP for this. See here for google.com, This is the public IP, which is where google.com is attached. This is the IP, the single IP. It will hit this particular IP 140, and in the backend, Google servers are there. Google.com servers are there. The same way here, if you notice Amazon.in, it will first it is checking this DNS server, and it is looking for www.amazon.in, where is the IP address, and it will find 104.18.15.146. It will divert there. So in our case, we have a finally what you have right now is this one, your website IP address. You need to attach with a domain name. All right, that is the idea. And in general, this is the place. There will be there will be multiple central DNS servers. There it will look when you create a DNS entry, it will get created in the central servers, and it will look for the actual addresses, the IP address, and it will divert the traffic. You got the logic, right? See, this entry, if there is in DNS servers, if this entry is there only, you will be able to access any website in the world. Not only Google or Amazon, any website. Whatever the website you are accessing, there is a DNS involved. That's why you are accessing with a name, and it is resolving to an IP address. If you want to see any website's actual IP address, you can use this command from anywhere. Like if you're from your laptop, if it is from command prompt, or if it is Windows, you can go to command prompt and run this command. You will be able to find it. Any IP address of any public website. All right. So that is the idea. Generally, you need a DNS. You need to create DNS server entry. And if it is organization, you may need to manage the DNS servers also sometime. If it is a organization level. Here in Google Cloud, the idea is there is cloud DNS. Instead of managing DNS servers, you can have it's just a tool. Like here in Google Cloud DNS, so there is a console. You can make the entry there. You can manage DNS entries there, which means we have an IP address, right? Finally, we have an IP address of load balancer. Next, we need to purchase a domain name. So you're hosting your website. You need to purchase a domain name. That's our next step. How to do that? Any of you know from where we can purchase the domain name? You have an IP address. Finally, you need to purchase the domain name. So see here, we are creating a website for GCP training. Imagine you're creating a website for GCP training, and you need to purchase that domain name, right? gcptraining.com. That's the domain name you're looking for. From where you can do it, you can simply type a name like Amazon.in is already there, google.com is already there, which means it's already registered domain. You can't use this domain name anymore, right? Amazon.in, you can't really use it, and google.com, you can't really use it. The same way, from where we are getting these names, that's the question.
There is a domain registrar. GoDaddy.
Yeah, like the places like the domain providers. There are domain providers like GoDaddy, Google Domain. All these are the popular domain providers. If you go to GoDaddy.com, you might all of you might have heard about this, right? GoDaddy. So I'm looking for GCP training domain. I just typed GCP training and I searched it. Here you can see gcptraining.com is available. Okay, this domain is available, and the cost is 77,519. It's very, very costly because my domain is .com domain. For .com, all of you know, right? .com, .in, and .org. Many domains are there that you already know. So gcptraining.com is available. Okay. But it is very costly. But if you notice down, see gcptrainings.com. Trainings.com is 299 rupees only for 1 year. All right. And you can purchase your domain from any domain provider, not only GoDaddy, there are many domain providers. Google domain is also there. You can purchase from anywhere. It doesn't matter. Just because you're hosting in Google Cloud, it doesn't mean that you need to host it in Google domains itself. You can purchase your domain name from anywhere. So see here, if you are trying for google.com, will show it's already taken. It's an unavailable, obviously, right? It's already taken. So this is how it works. So you need to purchase a domain name first. GCP training. So just assume that we purchase. You can go to add to cart, just like a normal any online purchase. You can purchase this domain name. You can add to cart. You need to sign in. You need to add to cart, and you made the purchase. Okay. So as you can select all this option, continue, and you purchase this GCP training.com. Just assume that. Okay. You can really purchase it right now, and you can go to cloud DNS and bind your domain name with the cloud DNS. That's all you need to do. You need to purchase from here, come back, see here CDN and DNS all together you will find. You need to create a zone. My zone, I'm creating a public, since it's a public website, I'm creating a public zone. And if it is within your organization, you can create a private zone. So DNS name, I'm providing www. I didn't purchase it. I'm just showing you. It won't work for sure. So www.gcptraining.com, and I'm creating a zone. Once you create the zone, see here, you just simply created a zone. As soon as you created the zone, what Google do is Google will assign DNS servers for you. See, 4 DNS servers Google will assign for this particular zone. See this, I mean, there will be other entries also in these servers. You can see NS Cloud D1 Google-domain.com. You can see the extension D2, D3. 4 servers it is assigned to you. All right, which means it's created an entry in just like this, right? The terminal we just created. See, there is one server 125. From here only it is resolving, right? I said. So if you check any other one also, it is resolving in DNS server. Just like this server, 4 different server it is assigned to you as soon as you created the zone. Now you need to add the record here. Add record set. GCPtraining.com. First, you need to add a record. There are many in DNS. There are a lot to learn. It's that itself a different technology. So here there are a lot of records are there. I'll just show you whichever is relevant to us, which is a record. A record, and here you can provide your IP address. This is what I asked IP address. So here and your load balancer IP, you can provide. I'm just giving some random IP. All right, and create it. See, it makes sense, right? Logically, it makes sense. You are providing your domain name and you're binding your IP address here. That store your IP address and other data allows to query by name. Now it's clear, right? Allows to query by. When you query by name in browser, if you type google.com, what is happening is it is checking in DNS database where it's stored for google.com, which is the IP address. Everything is stored in the DNS servers. So in the world, like if one entire DNS servers are down, just imagine if DNS servers, central DNS servers are down in the world, means the entire internet won't work. Total internet won't work. So recently, like if you remember, all the Facebook related applications went down, right? Like Facebook, Insta, and WhatsApp. I think these 3 went down a couple of months back. If any of you remember, in midnight, almost for an hour, it didn't work. So that is because of DNS issues. Basically, that is because of DNS resolution, that server routing, some related that issue. Because this is the central authentication of almost everything. If this is not working, the world will stop today. Okay, Cloud DNS is high performance, resilient global domain name system service that publish your domain name with the global DNS cost effective way. So here, very important point to remember is 100% SLA. This is the only service in Google Cloud which provide 100% SLA. All right, 100% SLA. You can make a note. In exam, I face this question like what is the SLA of Google Cloud DNS? So generally you hear the SLA 99.99, 99.999, all these, right? But this is the only service which provide 100% SLA. Scalable, reliable, managed DNS service in same infrastructure of Google. You will get high availability. easily published and managed millions of DNS record, 100% availability, automatic scaling, cost-effective pricing. What is automatic scaling is, as soon as you create an entry, you are getting 4 servers in the backend, right? That NS servers, four servers you are getting. If you have lot of DNS requests, like if you have a website with a lot of DNS queries, that 4 will increase. The backend automatically it will scale. These 4 will be increased. The backend. These are the servers which handle the DNS requests. This will increase. See, as of now, for itself, it is good enough. But if you have that high website, it will increase. Cost-effective pricing. It's all about DNS. So all are connected together, right? See, we have load balancer. Along with that, we have CDN, then DNS. So now, if you are setting up everything, see, we have some limitations to set up DNS and all. If you are free to do, like you can purchase a domain name, we can set up along with your load balancer. All right, so that when you hit a name, it will reach to your website. Okay, just bookmark this video. And okay, what is the idea here is, our next topic is networking. Okay, VPC networking, that's our topic. That's a very critical topic. Okay, so before to learn networking, there are some prerequisites. Like you should remember some basics, because I can't really get into the basics and teach that. So there are some prerequisites. So what you do is just watch this video, refresh your knowledge. Like you might have learned this in college. Like if you are coming from any computer science or engineering background, this might all of this you might have learned in college for sure. But so if you already learn it also, just to refresh the knowledge. These are very interesting videos. These are not only about what you are daily doing, like when you access a website, how exactly it is working. See, if you hit google.com, how exactly it is working and coming back, how you are getting the response. See, in this millisecond, what just happened in the backend, what all things are happening, it is explaining under networking. So you can learn this, and you need to watch till part 5. Okay, the same video, it is part 1, part 2, part 3, part 5. So these are very basic things. Like a few things you can just watch it. If you did not understand few terms and all, you can ignore. That is totally fine, but generally you will get an idea. So these and all, it's not very important, this cabling and all, but generally all together you will get some idea about networking. So that is really required. See, Wi-Fi daily basis, whatever you're using, that is the whole topic here. So you can just watch it. So this is a very important part. 3 is the very important area. So you can just watch before. If you watch it, it will be little more easy. Some terms and all will be little more easy from Friday. So Friday and Monday, at least 2 days are required to complete this topic. Okay, networking. So it's very important. If you are going to work in cloud, some or the other way, you will deal with IP addresses. You will deal with the network and everything. Otherwise, also the basic networking knowledge will really help you. Some or the other way, like if you are working in IT, you will end up on dealing with this. So until part 5, you can watch this. A very clear and very crisp explanation, very simple explanation also with a lot of graphics in it. So you can watch and come back by Friday. Okay. So till 5, okay, there are more than 5 also. Till 5 only it is required for us. See, this is IP address part. This is also very important. Okay, IP address, how IP addresses work. This is something, as I said, you are dealing with daily basis, right? Very important to know what is public IP, what is private IP. Like by looking at the IP address itself, you should be able to identify whether it's a private address or a public address. So when you create a VM, you are getting 2 IP address, right? Some 10 dot series, 10 dot so and so IP address, then some 35 to 25 like that. Your public IP address also you're getting, right? All these, what exactly it is, you will come to know. See, it is not only for cloud or whatever the cases, like if you are using a broadband, you have a public IP address. How many of you know that? You have a router, right? If you are using broadband, you have a router, right? How do you get that IP address? How do you know your router IP address? Any of you know how to check that? Okay, all these things you will know. Yeah, Kundan. So this is my IP. Everyone like everyone who use broadband, they have a public IP address. This is the same public IP you are using in load balancer, right? When you create a load balancer, you are getting an IP, some random number. But when you create a VM, you are getting a private IP also, some 10 dot series. Microservices. So this is it's a groundbreaking technology. To Kubernetes is a groundbreaking technology. When I say groundbreaking technology, so far how we host our application, that the total method itself getting changed in Kubernetes. All right. So how the things works, like it is the technology. I mean, when you host an application, in generally how you do it, this is how you do it, right? You may have a hardware infrastructure, and on top of that there will be servers, on top of that operating system, and on top of that you have, in OS level, you have libraries and dependencies like kernel, binaries, libraries, dependencies, and here only you host your different application like web server, database server, messaging platform, or orchestration, whatever you require, different application. On top of this layer only you host it. All right. So this is how we host our application. So this is the traditional way of hosting an application. There will be operating system, and on top of operating system, server, operating system, on top of that application. That is how we host anything. Any kind of application, you can host it in an environment. So when I say groundbreaking, this whole concept itself getting changed, and the management is become more easy. And but when we do that, a lot of many other things comes into picture. That's exactly we are learning in this architecture. Like till some 10-year back and all, the concept of microservice or this one, Docker, Kubernetes, containers, all these things were not in picture much. Some 10, 12 years back it was there, but it's not so popular. So at that point of time, here in this the traditional architecture, when you deal with this kind of infrastructure, there are some challenges. These are the challenges: compatibility, dependencies. Compatibility means you have different types of application. There is web hosting applications, databases, messaging, then Ansible kind of orchestration application. All these are there, right? When you, in this case, like when you set up an environment in a data center, different application demands different types of operating systems. Sometimes your web server required like this specific version of Linux, there only it works properly and got more features. And same way database required sometimes Windows servers, so that will work effectively in Windows server, more effectively in Windows server. So like that, there are some uh, compatibility issues and dependencies issue. Same way you have it got a OS dependencies, and it takes some long time to set up. Like if you want to set up all these application what you see in the screen, it will take at least weeks to set up, like set up the operating system first, install the web server, configure it, interconnect with the databases. Like a lot of activities are there to achieve it. Like, and there will be something that breaks and a lot of issues. Like if you ever set up all these things, you will get an idea. Like it is a very big task, and also the management is it is complex, and it increases the complexity of your environment when it communicate. Like this is not just a single operating system. Okay, here it can be either single operating system or more than one OS also. Here it is possible. So this is the setup. Updates, another point, another issue in the traditional way of hosting the application is if you want to update your operating system here, like in OS level, or if you want to update the version of web server, or if you want to upgrade the database, in all these things, it required a downtime. If you want to update the operating system, some new patches or some new service packs or patches released from the operating system vendor, if you want to upgrade it, you need to bring down these applications first, then you need to upgrade, reboot it. So its downtime is required to affect your business. So that is another drawback. And modification, just like update, modification of your backend OS, all these also, it required a downtime. This is the traditional way of hosting the application, and these are the issues, challenges when you manage traditional infrastructure. Microservices. First, we will go in order. Microservice. So you got some idea, right? We have some challenges. So when some new technology introduced at this point of time, it overcome all these challenges we have listed. Microservices. So what is the idea of microservices? On top of your operating system. See here, OS, and on top of OS, libraries and dependencies are there. But when it comes to the new idea, on top of operating system, one more layer is coming into the picture. You have your operating system in a traditional way, either as a virtual machine or on top of physical machine itself. It can be anything. But on top of operating system, one more layer is getting introduced. That is microservices. Let's not exactly, not my microservice. It is Docker. You can see on top of operating system, one more layer, which is Docker. What Docker does is, it virtualizes your operating system. Very important. What Docker does, it virtualize your operating system. If you remember our compute engine slides, like that slide is coming in the next session, but still, we are comparing that. If you remember the compute engine slides, there is hypervisor, right? On top of hardware, there is hypervisor, and on top of hypervisor, you have your operating system, different operating system, just like these boxes, different operating systems are there. So the same way, on top of operating system, you have a separate layer, which is Docker. And what Docker does is, it virtualizes your operating system so that you have separate libraries and dependencies for every application or everything you are hosting. See here, three things are coming into picture. One is microservice, and one is container, and one is Docker. Three things are coming into picture. So Docker is something which virtualize your operating system. If you compare back again, see, on top of OS, you have libraries and dependencies, like it's a single layer, libraries and dependencies, binaries, like all the, if you ask me, like that is kernel, like your operating system kernel, basically. So on top of kernel only, anything is getting installed when you install that, when you install any kind of software or any kind of application. So here it is virtualizing it for everything. You have separate libraries and dependencies to run. This is the groundbreaking part. Like when you do this, you are getting a lot of advantages. So this is the whole idea, like what we are going to learn. These are the three things. One is microservice, one is container, and Docker. First, we will focus on microservice, and we will, all the links will be getting connected. This slide, you can keep it aside now. First, we will learning microservice. So this is microservice. This is the traditional or monolithic architecture. If you go for an interview, if you mention this Docker or all these things, if you attend an interview, there is a chance that you will be asked this question: difference between monolithic and microservice architecture. So monolithic architecture is something, it's a single layer architecture. That's a traditional way of hosting your application. There will be one operating system. On top of that, your application will be there, and user interface, everything will be like dependent. You can see the user interface, business logic. So here, if there is an issue with this business logic, it is affecting your entire application. But the same concept, if you set up in microservice architecture. So I'll give an example. e-commerce website itself, there are different layers, right? When you open Amazon.com, and if you get in, like first you will type your username and password, and you will be getting in. So that is an authentication layer. After that, you may add, you may find some product, you will add that into cart. So that is a different layer, but adding into cart or adding into wish list. So that's a different layer. Then you will be making the payment. That's a totally different task, that payment. After payment, Amazon will be sending some messaging or something to you, right? Like a mail or an SMS, or all together, everything you will be getting, right? So that is also every layer is doing different purpose. So here you can see everything is in like a dependent layer, like in a single architecture. If there is an issue with one area, it will affect your entire application. But what is microservice architecture is one large application, it is dividing into small services. That's why it's called microservices. See, this is a service. See here, this is service, we can say total the whole service, and here it is microservice architecture. A large application, wherever the separate activities will be there, right? That can be divided into small services. So here on authentication, it's a microservice. You can, if we notice, like here, for if we compare with our example, this is authentication and adding into cart, adding into making the payment, messaging for each and every service, each and every activities in your website. If that is switch to or move to separate microservice, the advantage is breaking your application. Like if something is not working, it won't affect the entire application, the whole application, it won't be affected. That is one of the advantage of uh, microservice. It helps to separate business logic functions. Instead of a big program, several small application communicate via well defined APIs. These are the some of advantages. Again, it is language dependent. This is very important. It doesn't matter where exactly it is getting hosted. You can host it in any Linux flavor or Windows flavor, but you can't create a Linux supportive microservice on top of Windows, because the backend architecture is totally different, right? But you can, it doesn't matter which Linux flavor it is getting hosted, because on top of microservice always the Docker will be there, right? See, this is the way, right? Docker will be there. So this dependency is not there. This operating system, this is the microservice. See here, whatever inside this box, right? That is a microservice. And with the box, without box, it's a microservice. And with the box, or your microservice is actually wrapped or covered in a container. So here on top of Docker, you can see container basically. And I'll get into that container, everything I'll get into that. But as of now, see, you divided your microservice, which is maybe an authentication microservice. That microservice is hosted on top of Docker. So this microservice do not have direct dependencies with the Docker. You can see, right? It's on libraries and dependencies it got on top of Docker layer. So this is not directly communicating with your operating system. That's why it's called language independent. It doesn't matter which operating system you're running in the backend. Small team development, because small services, right? Fault isolation, like if there is an issue, it will be isolated into one area, like, or one activity of your website. Very important advantage is it can containerize. So what is microservice? I'm repeating, what is microservice? One small program of a part of which is part of a large program. It can containerize. That is the advantage of microservice. We will lead to containers. From microservice, we will lead to container. Let's see. Scalability, and some of the challenges when it comes to microservices. Complexity, because if you divide a large program into very small pieces, the complexity increase, right? And also the management, the overhead also will increase. So that these are the challenges of microservice, but we will address those challenges. So this is a challenge of microservice. See here, service A, B, C, D are there, and everything is divided into microservices. And to make it communicate everything, this is a challenge, right? Instead of small program, if you divide into bits and pieces, it's a challenge, right? But we are overcoming the challenge. Next topic, what is container? We already learned what is microservice. Now what is container? This is container, right? So what do you see in this? Like, what is container? Like, if you just don't think about cloud computing and computing itself, what is a container and what it does in a normal perspective? Container, what it does? See, different flavored things are actually totally enclosed in different container, right? So it is not mixed to each other, and also it is increasing the security. Like, it is totally covered, and it is increasing the security, right? Technically, this is exactly happening when it comes to container and a microservice. You have a microservice. It's a piece of program. It can be shell script, or it can be a Java program, Python program, anything it can be. So I said, right, in a large application, there are small areas. So that authentication may be happening through a Java program, possibly, right? So that one you can cover, or you can containerize it. Any service, any kind of program, you can containerize it. When you containerize, what is happening is you have a program, it is actually covering it. Actually, you are wrapping it, you are wrapping it on a container. When you do that, you have some advantages. Like, instead of running a shell script normally, like when you do a shell script, when you run a shell script normally, you will be going to some Linux machine and you're running that program, right? So instead of that, if you containerize it and use it, it is increasing, it is giving you a lot of advantages. You will see what exactly it is. A container is a lightweight piece of software that include everything you need to run it. What is that everything? Your libraries and dependencies. Code runtime, like not only libraries or dependencies, code runtime, system tools, libraries, and configuration. Everything you need to run it, everything is enclosed into a small program, that is containers. Container run regardless of OS environment, that I already explained, because container is not directly talking to the operating system, it is running on top of Docker. It's lightweight. This is a container. You can see there is an image behind. That is also a new topic, image behind. So you have a shell script. Just we will start from the scratch. You have a shell or Python script. Okay, just a Python script. See, we had a hello world Python script we had, right? And what we did is we deployed into App Engine in the previous session. We had a Python script and we deployed into App Engine. So the same thing, if you are doing it in a Docker environment, you have a Python script. What will you do is you will convert that Python script into an image. You need to first create an image using that particular script. That's why it's called image. And when we learned Cloud Run, if you remember, after App Engine, in the same day, we learned Cloud Run, right? So to host your Hello World application, instead of a program, we used an image path. If you remember, there is a path, the default path itself we used, and that image path we used. The same image we are talking about. So if you remember, what is the difference between App Engine and Cloud Run? Refresh that part, because Cloud Run is directly linked with what we are learning right now, because Cloud Run is something, it's a serverless environment where you can run the containers. So this is exactly, these are interconnected. So what will you do if you have a Python program and if you want to run in a Docker environment, you will convert that into an image and then you can run it. When you run that container image, that is read write, and that's a running program. Basically, this is a running program, like hello world application is running here, and in the backend you have your image layer. That's how it works. You have a program, you are containerizing it. What you're doing is, what will you do when you containerize? You will convert that into an image. This is what container is. You're wrapping a microservice into a container, and it is getting a lot of benefits. Like, we will see that how it is. And when you wrap it, when I say wrapping, that is in my own thought process. I said, like, to understand or make you understand. The point is, you're converting into an image. Any kind of program you can convert into it. It doesn't matter which language it is written, or whether it's Python, shell script, or anything it can be, database, anything it can be. You can containerize it. You are you are converting that into an image, a Docker image. And where exactly you will run? On top of Docker, right? What is Docker again? on top of Docker, we already discussed where exactly it will run. What is Docker? Containerizing platform. We learned microservice, container. Now, what is Docker? Docker is a containerizing platform. Whatever the things we were discussing, right? That you can run in this platform, like converting into an image, all these things, you can do it in this platform. And also you can host the containers on top of Docker. Docker is a containerizing platform. Not only Docker, there are alternatives as well. There are many other containerizing platforms as well. So any of you heard about any of this? Docker, at least you might have heard about it, but how about other topics? Anyone? So these are the other alternatives of Docker. So just for your information, not only Docker, there are alternatives as well. Container is a running Docker image. Very important. When you convert your microservice into image, that is called Docker image. Like now, see, there are alternatives, but still from now, we will be focusing only on Docker. So just for your information, there are alternatives. So when I mention Docker image, it's not only Docker image. If you're running the same, if you're doing the same in some other platform, it is whatever that Oracle image or that whatever we call. So from now, I'm just using only Docker because that's the most popular containerizing platform. All right. Container is a running Docker image. See, you have a shells, you had a Python script, you converted that into image, and you're running in a container. You're just running as a container. When you run the image, it is adding a writable layer on top of that image. So image is nothing but our compute engine image is there, right? Or if anyone, did you install some Windows in your laptop, or any of you like using a CD or something, ISO image or something, any of you installed in your laptop here? Using an image or pen drive or something, like did you install the operating system in your laptop? So when you do that, what exactly, or if you compare with our compute engine lab itself, what exactly we are doing? We have some lot of images, right? Red Hat Linux and CentOS. Many images are there. If you simply keep it that image, we can't use it, right? That's not an operating system. It doesn't have a read write layer. It's just an image. It's a raw image. We can't do anything with that image. If you install an operating system only, we can make use of it. When you install an operating system using that image, we are getting a read write layer, which means we are able to log in, we can make the config changes, we can create a file system, add more disk, we can install the application, many things we can do it on top of operating system. That's exactly here as well, but all are small programs. It's not that big as operating system. Container is not that big as an operating system, and also this is running on top of an operating system. But concept wise, it's same. So Jyoti, you installed operating system using an image or pen drive or whatever, possibly pen drive. So we can still consider that's an image. So using one image, you can create unlimited number of OS, right? Doesn't matter. You install operating system using same image, install other operating system in a different laptop. It doesn't matter, right? The same way here, using an image, you can create unlimited number of container. So image is a read-only concept, and you can run the image, and using the same image in some other places, you can create more than one container. Unlimited number of container also you can do it. When you create a container, it add a writable layer. Image based on you create container access separately and cannot be altered. It's like once you create the container, that exists separately. The same thing explained. When you run a containerized environment, you essentially create a read-write copy. The same thing. Okay, container layer, same. Docker container, it's a virtualized runtime environment where users can isolate application from underlying system. All these are upcoming diagrams are coming. Docker claims that these units provide the strongest isolation capabilities in the industry. So when I show that the container picture, right, or the actual containers like that kitchen containers. So isolation is one of the advantage you are getting. Strongest isolation. Docker claims this concept provides strongest isolation capabilities in the industry. It is lightweight. This is a very important slide of today. So all the missing links will get connected. So I know you guys are confused. You can take your time and understand what is the difference between an operating system or a virtual machine and containers. Just take 2 minutes and understand, then I'll explain. On the right side, virtual machines are there. There is a different diagram I have placed in compute engine topic also. There is infrastructure. Hypervisor is something which virtualize your hardware. Hypervisor virtualize your hardware. I had explained at that point of time. Like you have a hardware which got some 128 CPU and a lot of 250 GB RAM or something. If you install one operating system on top of that, that's not effective. Like it won't really make use of your total infrastructure. So that's why the hypervisor is coming into picture. So you can have more than one isolated virtual machines. This can be Windows. This can be Windows. This can be Red Hat Linux. This can be CentOS. Totally isolated virtual machine you can create so that you are making use of your infrastructure. It's not we are making sure it's not underutilized and it is properly utilized. All right, that is the idea of hypervisor. Like if I make it short, hypervisor is virtualizing your hardware. All right, very important. You can make a note. What is hypervisor? It virtualizes your physical hardware or servers. When it comes to containers, Docker virtualize your operating system. Docker virtualize your OS, so that in the same way it is running isolated containers. So this can be totally different container, it can be a different application, this can be totally different application. So on the same operating system, there is one more layer is coming, and you can have the totally isolated multiple application you can host it. Maybe you can host the same application also. This Docker is communicating with this and forming a complex application, or you can have totally different application as well. This can be WordPress, this can be Jenkins, this can be a totally different Hello World or anything. This is the difference between, see here, this is OS, right? This is operating system. Actually, so on top of this operating system, see, this is also OS, this is also OS. So on top of OS only, this is running. So containers are small and it is actually running on top of operating system. This is another diagram, little more detailed diagram. This is virtual machines and this is containers. You can see utilization, it is more big, resource utilization is more, size is more, and boot up time is, it takes, there are a lot of steps. Same way here, utilization is less, size is small, and boot up time is very fast. So we properly learned what is microservice and what is container. Any question? So microservice is a program, and if you cover it, it's a container. See, this is microservice. See, whatever you see inside this container, that is microservice. That's a long story short. So again, advantages of container: componentization, portability, quick deployment, orchestration, flexibility with the other topics like other services like App Engine, Compute Engine, lightweight security. Oh, what is a Docker? All right, we already know what is a Docker. It is a containerizing platform. So a little more about Docker. Docker is a most popular containerizing platform. It's an open source. It doesn't matter which kernel is running in the backend. So here, the same diagram in a different view: infrastructure, operating system on top of the Docker, and you can host different application, app A, B, C, so on. Right, that is about Docker. We already know. Now Docker image, this also we already know, but little more about it. A Docker image is an immutable or unchangeable file that contains source code, libraries, dependencies, tools, or anything you need that application to run. That is Docker image. Just like a ISO image where you create a operating system. So concept-wise, it's same, but it is more small. Due to their read-only quality, these are. It's like a snapshot. It's a single file, specific point in time. Like this is, you can't edit a Docker image. Instead of editing, you can edit your microservice and create a new image on top of it. You can't edit a existing image. Anyway, we are going to do all these things today, so we will get a fair idea. So it's a kind of a template, like we can say snapshot, templates, point in time, anything. You got the idea, right? You have a program, you're converting that program into an image so that it is immutable and you can't edit. It's standardize your program because nobody can change it, right? You can always, any number of time you can run, any unlimited number of containers, you can create it. These are some of the examples of Docker image. So from where I get this Docker images, I'll show you. Docker Hub, if you go to Docker Hub, you will find a lot of images which is created by the vendors itself. It is public image. You can use any Docker image from here. Docker Hub, hub.docker.com. See here, all these are images. See, there are a lot of official images, which means the product owners itself providing that image. You can see the official verified publisher and open source programs. So here you can see Ubuntu. Ubuntu, we already know it's an operating system, but it is a small piece of Ubuntu, like very small, tiny piece of an operating system, not the full operating system. See here, Redis. Redis is a database. So see Redis itself providing a Docker version of the database. If you click any of such image, you can go inside and you can see how to download this image. That command you will find from the Docker host. You can download this image. See many other details like what all it contains and many things you will be getting the information. See from that same, see all these are details of that image, a single image. All right, Redis. If I go back, you will find a lot of image. Just explore this area, hub.docker.com. See Python, Hello World, WordPress, Mcache. See, a lot of images are there. That is this. These are only official images, and you also can create your own program and host it in Docker Hub. You can create an account. You can have your own Docker image of any program, like maybe the program you developed or you customize any of the existing program. Anything you can also create, and you can host it here. So it will be under open source programs, like not from the verified or official image. So anybody can use it. You can also use it. You can also keep it for longer period of time, any number of time, any long, and it will be there in your account, your user account. And you can make it, either you can make it private or public also. Like there are public images and private images. You can use it as a repository, or you could use it as a public repository as well for others as well. See RabbitMQ. Do you remember what is RabbitMQ? Like there is an alternative in GCP of RabbitMQ. Do you remember what it is? Messaging, like MQ means it's messaging basically. What is the messaging service of Google Cloud?
Kafka.
No, that is Kafka is open source. Like Google Cloud got its own messaging service.
Oh, okay.
Pops up. Okay.
Yeah.
Messaging means all this pops up. Like I have drawn one diagram, right? Messaging, wherever you heard messaging, event-driven messaging, that is pops up. All right, let's come back. So just explore this part. You will find a lot of image. See, if you today we are what are we going to learn is we are going to create a virtual machine with the Docker. On top of that, we are hosting some application. All right. So we are learning that basic area we are learning. So you have like literally have a ground to play here. See, this is you have plenty of images available to learn. That's my point. Like you're getting some basics today and like very core understanding. Rest is on your hand. Like you can learn whatever. See you what all the images you have. Unlike like traditional technologies, right? Like I have learned Red Hat Linux like many years back, some 8+ years back. I have learned Red Hat Linux, but the gap I had is I don't have the proper setup to learn Linux. Like I can go to the institute, there they have proper setup. I can install the Red Hat Linux in laptop and all, but there are a lot of gaps. Like you, if you want to connect from client to server, many things there was a gap. But in cloud and all these kind of technologies, like now these days, what is the advantage is you can do anything in cloud. The same cloud console we are learning, right? The same only you are using in the real time and there is no zero difference except some quota related difference and all. Apart from that, feature wise, there is no difference at all. You can do anything if you are willing to learn. You have like lot of things to do. Like you have plenty of things to explore here. All right. So if as I said, when you are learning the older technologies, like not Red Hat is not older technology, but the time, the certification exam and all these things, you don't have the setup. If I want to practice something, I have to go to the institute. There they have the setup, and in that only I can do the exam oriented practices. But here it's not like that. All right. So you have a lot of things to explore. That's what this one I'm showing. So whichever your favorite application or whichever the application you wish to learn more, all these things, you have images available. You can run it. So some examples, these screenshots are actually from Docker Hub. As I mentioned, from one image, you can create unlimited number of Dockers. So some of the Docker commands, this you can refer later. We are going to run in lab with Rust. You can